Hello, Arthur and Matthias. Can you hear me?
Yes, I can hear you very well.
Perfect. Same thing here. So that's okay. We'll wait the real time because we are a bit in advance.
Sure. But you know, Germans are always very on time.
Here in France, we are not.
Okay, then I will share my screen. Yeah, so you should probably see it now.
Yes.
Excellent. And because I've prepared two small surveys that are running, I don't know if you're not a Zoom host, it's always difficult to set up surveys in Zoom. That's why I've prepared them in a different window where I can share the link in the chat.
Okay. If you need, maybe Arthur can grant you some more rights. You know.
Yeah, no. But I think it would be too few time now to put the surveys into Zoom.
Okay.
And I don't know if this works in this webinar. Maybe it should be. But
you're no co-host.
Yeah, I'm co-host, but I think it's not. There are no polls in Zoom. You have to activate it in Zoom before.
Okay.
We are heavy Zoom users at our university. So I know that polls can be easy and difficult in Zoom. If it's not activated, then you have no chance. So, but you can also see the survey here in the straw poll window, right?
What should I see?
Not my slides now, but something like a survey on my screen share.
I can still see your size.
Okay, then wait, then I will stop again, but it's picture one. And now?
I can now see your web browser.
Okay, and there's the survey. What field are you from?
Yes.
Yeah.
Exactly. Okay, perfect. Okay. Okay. Yeah, I'm just checking the. There are two people watching at YouTube. One is me.
And we have 13 attendants on Zoom.
Okay.
Definitely too early in the morning, even for Germans.
Yes, even in European time, it's quite early for Sunday. I guess people will join in the coming minutes.
Yes, I'm sorry for scheduling so earlier. There was just no other choice. I made the schedule. I started by keeping Sunday morning free, and then there were more and more talks coming. So then it was all gone.
That's good to have a lot of talks, and that's also good that everything fit in a weekend. I think we can start. I don't know, Matthias, if your presentation will be long, if we should still wait for 2 or 3 minutes.
I think we can start. I mean, we have the recording, so
yes, you're right.
You can also
exactly, yes, and we will have time for questions at the end of your talk. So please join me in welcoming Matthias Magdowski from Germany. Matthias works at Magdeburg University, something like 150 kilometers west of Berlin, if I know well, where he's in charge of, among others, the electrical engineering training. He enjoys experimenting with alternative teaching and learning methods, and in a apparently very successful way, because he received several awards as best lecturer since 2017. And apparently some of these teaching methods involve LaTeX. And Matthias, I will let you speak about that if you wish.
Yeah, thanks for the kind introduction. So I want to speak briefly about a method that I have developed in the recent years, personalized tasks for our students and corresponding sample solutions. And yeah, this I use in the field for teaching fundamentals of electric engineering. And as you already said, it involves LaTeX and some packages that also some people know, PGF plots for plots and diagrams and circuit ticks for circuit diagrams. Before I actually start, I want to do a short survey just to have some idea what are the people that are listening to the presentation now. And I will put the link into the Zoom chat, and I would ask you to click on this link and cast your vote. I will also say I'm from mathematics, computer science and technology. And let's have a look at the results. Okay, there are two more. There's one more person from science and education, and one more person from education and teaching. And one more person that says, okay, anything else, whatever this is. Okay, but there are now five people that said, okay, mathematics, computer science, technology. This is a little bit what I expected. This is good for me that then I can a little bit go into more detail about the technical details also from the field that I'm talking about. So some organizational matters, slides are available. I can share a link to the slides after the presentation. There will be a recording, of course. And if you want to ask questions also in between, no problem. You can also, if you don't want to interrupt me, put questions in the chat. And then we will come back to these questions after the talk, or of course, you can also ask questions after the talk. So, short overview over the talk. Of course, at the beginning, I will give a motivation why we have developed this method and what problem we're trying to solve with this. And then I go into the LaTeX details and take a look at two of these developed tasks about two different topics, charge and current and nodal analysis, and yeah, how are these tasks then generated in LaTeX? And at the end, the discussion, some evaluation of the results and what do the students think about it, and yeah, what has come out of it. So why do we do all this? At first, we want to let's say, stop our students from this bulimic learning, learn everything that you need to know about the subject 3 days before the exam, and then puke everything on the paper and forget about it after 1 week. But yeah, still at universities, we'll have kind of these traditional performance assessments. Students are forced to solve tasks alone. They just have, let's say, a paper and the plain calculator. And to be honest, this is not really how you would solve engineering tasks in real life. I mean, it would be kind of strange if Elon Musk says, here you are my best engineer. Now just take this white paper, a pen, and a calculator, go into this room for 3 hours and develop our new electrical car. So the real life demands in the working world more look like this. That of course you have to know something, and of course you need to be able to solve tasks a little bit on your own. But you also need to cooperate with people, and you need to discuss about engineering problems, and you need to make people aware of problems that you are thinking which are important. And yeah, you also must be able to present a solution, or to tell someone why you think your solution is right, but the other solution is wrong. Yeah, so you need to have this discussion ability, and this is nothing that we really assess in these traditional exams and performance assessments. So then a little bit how you can do this. I mean, there are classical e-learning tasks where you can test students' competencies and knowledges. But then the problem with these tasks is always they have to do a calculation, but at the end, they only fill in a number in the field, and you can only test the number at the end, but you can not really check the calculation. So that's not good for us, because in such a handwritten solution, students can really show if they have understood about all the details of, let's say, a problem, an approach, how to solve this problem, how to set up a calculation, and then how to do the mathematical calculation. And in this handwritten solution, it's also very easy for students. I mean, you had all these accessibility talks yesterday, yeah, how to write down equations, how to draw diagrams. It's much easier to do this by pen and paper than, yeah, we are talking about first year and second year students. If you tell them now you also need to learn LaTeX, how to write down an equation in an e-learning system, it will be too complicated for them. So handwritten solutions are quite nice. Because you can also easily see student misconceptions. And I've written down, or I've copied some examples here. Here is a student calculated the Fourier coefficient. If you don't know what the Fourier coefficient is, don't care, but it's something that should have the unit volt. And then because some calculation with sine and cosine terms, with angles and radians and degree was involved, students converted these results from volt into volt degree, whatever this should be. Yeah, and this is some misconception that you would never see if the answer to a question is just put a number in a field. Yeah, because then the student would say, okay, volt is something that I should calculate. Then I could maybe convert it into volt degree, but I would not do it because it's not asked for. Yeah, so we have it's easily visible to capture these misconceptions. And here's another one. If you know a little bit about electric engineering, so this is a complex impedance with a real part and with some imaginary part, and here the student converted it into a time function, which absolutely does not make any sense for this impedance. If this would be a complex current and voltage phasor, then this would make sense, but not for this. And again, a very interesting misconception, but you will only see this in this handwritten solutions. So what we want to have with this personalizable tasks for handwritten solutions, the solution should be handwritten because this is authentic. You can see these misconceptions, and students can easily write down formulas, schematics, diagrams, and so on. If it's personalized, students cannot plagiarize from each other, but they can discuss. They can ask their fellow student in their learning group and say, look, I got this task, you got this task. How can we solve this? They are invited to discuss about these problems and not only try to solve the problems themselves. Then, of course, if students have written down solutions, someone must check these solutions. And we as teachers don't have enough time to do this. So students should do peer review. This is also interesting for them because then they look at other student solutions. They see, okay, these other students, they got the same problems like me, or they got different problems, and they have to think about other solutions for similar problems and think someone has tried to solve this similar problem differently than me. Is it still right? Is it still wrong? So I think there are also is a big learning outcome from this peer review. Of course, it also lowers the correction effort for the teachers, but you need to have very good and also personalized sample solutions, because students that were not really able to solve their own question and problem should still be able to do a proper review of other solutions. And then Moodle is a learning management system, and email, so everything should happen electronically with PDF files, for example, so that we don't have this red tape, big piles of paper somewhere that you need to receive from the students and send to the students. So this is the idea. Then I have 3 diagrams, a little bit how it's technically implemented, and then we can come to the LaTeX details. And you see that LaTeX also already appears here. So these are always the students here. The students register in this Moodle, in this e-learning system. I get a list from all the students. And I did all the programming in MATLAB. Why? Because I know MATLAB, I'm an engineer. You could choose any other programming language, Python, for example, but I did it in MATLAB. And from this list of students, I get the names and I get the matriculation numbers, and I use the matriculation numbers as start seed for a random number generator. So every matriculation number generates a different task, but the same number generates the same task again. So if something goes wrong, so these tasks are randomized, but still a little bit fixed. Yeah? And so then LaTeX generates a PDF, the task and the sample solution. The sample solution will be stored into a folder, and the task is sent via email to the student. And then the student has 1 week to solve the task, has some idea or not, and submits the solution back to this Moodle, back to this e-learning system. I download all the student solutions as a zip file and put them back into MATLAB. And then MATLAB takes the student solutions and the corresponding sample solutions and sends them to other students. Yeah? So each student now gets 2 emails saying, here's the solution of a different student. Here's the corresponding sample solution. Please review it. Please score it. Again, you have 1 week to say if it's right or wrong. And then please submit it back into this e-learning system. And so then this is what the students do. They mark it. This is right. This is wrong. If it's wrong, they always need to say, okay, why do they think it's wrong? Give some score and submit these reviewed solutions back to the learning management system. And again, I download all stuff as a zip file, and then the students at the really end get back their 2 reviews and their own sample solution, so that they can once again check if everything is right or wrong. And then the points that they got are stored in a score list. And to be honest, these points are quite important for the students as some extrinsic motivation, and the points do not count for the exam, but so the students need to collect enough points that they can register for the exam. So that's the idea. So now, how is this implemented in LaTeX? How are these tasks generated in LaTeX? So I will take a look into 2 sample tasks. I think at the time I have 13 tasks developed in total. So this is the first task that I've created, that I've implemented. The task is more or less always the same for all students. So they get a displayed curve of a current, and from the current, as a function of time, they should calculate the charge by integration over time, over 4 time periods. Some initial charge is given, and then they should calculate the charge and again draw it as a curve, display it as a time function. And so the task is the same for all, but each student gets a different diagram. So here for some sample matriculation numbers, I've given different diagrams, and it's always a linear function here, and then 3 constant functions in this other 3 time steps. So one diagram looks like this, and the next one might look like this, and the next one might look like this, and so on. So they all get the same tasks, but they all get different diagrams with different values. So they have to develop more or less an own solution. So how is this done in LaTeX? For these diagrams, of course, I use this PGF plots package, and so this task, to be honest, is fairly simple. I'm not a really good LaTeX programmer, so I can only do simple stuff in LaTeX. This is what I could do. So here is the seed for this random number generator, and then I generate random integers for the currents at the different instance of time, and then there are some if then else functions. If the random number here is 0, of course it should not be 0. If the current is 0, the task does not make too much sense. So then I set it to 1, and if let's say in 2 adjacent time slots the current has the same value, then it's then I also need to catch this. I think here is something like this: if the current in 2 the previous and the next period is the same, then I just invert the sign so that they are different, for example. And then you plot a diagram out of this in a text picture in an Access environment, give proper labels, and then just use these random numbers that just have been generated and put them into the diagram. That's the idea of these PGF plots diagrams. So everything there really happens in LaTeX, the random number generation and the creation of the tasks. And then, as said, I also need the sample solutions. So what the students should do is a section-wise calculation, read the time function for this section from the diagram, put it into this formula for the charge, integrate over this linear function here, for example, simplify the formula and calculate the charge at the end of this first time section. And as said, for every student here in this case, it's really the same formula. It's just different numbers, but trust me, for a student that has just started studying electrical engineering and has just survived the first 2 or 3 weeks of his study, this is hard enough. So every matriculation number, just as you can see, just generates different numbers in this at this time, very same formulas. And how do I do this? Just again, calculate these numbers. Here I have something that trims the zeros at the end so that I really just get these integer numbers and then just put them as PGF math macros in SI commands from the SI unit X package. And this, I think this package got a major update in the recent month. So these commands here will change. I'm still working with the old package, but this is more or less it. Put the numbers into these equations. Okay, and then at the end, students should draw a diagram to check this, a diagram of the charge as a function of the time. And here again, I just create them in PGF plots. I've not given the LaTeX source here again, but you can see that these diagrams look quite different, and that's the idea. So, and at the end, if the students properly do the calculation and properly do the drawing of the plot, it's fairly easy at the end for other students to check, okay, these 2 diagrams, they really look the same or they do look different, these plots. And so just with these 4 different current numbers, you can generate very different graphical representations of the charge as a function of the time. So this, I have prepared a second survey, and the second survey, I will put again the link in the chat. The second survey is, if you are also teaching, and maybe also if you're just doing training somewhere, can you think of similar personalized or randomized tasks that could be used for your subject? And of course, I would say yes, immediately many, and take a look at the result. Okay, and interestingly, there are some people that say, okay, yes, some, or but, or but after some thought, I will once again update the results. Okay, no one said no and no how, no way. Okay, interesting. Thanks for your feedback. Yeah, so let's have a short look on a second task. And the second task is about nodal analysis. This is something in electrical engineering, a method to calculate all the voltages, and from the voltages and later on also the currents in a given circuit. And these voltages are called nodal voltages. And already symbols are given here for them. So the task is students should draw these nodal voltages in the circuit, in the given circuit diagram, set up an equation system to calculate these voltages, solve the equation system after inserting the values of the components inside the system of equations. So again, the task is the same for all, but everyone gets a different circuit diagram. Again, they are generated with a random number generator from the matriculation number, and all these circuit diagrams, they always have 3 nodes, a reference node and 3 nodes, and then different elements, current sources or resistors, or current sources in parallel to a resistor, or just a current source between these nodes. And so different matriculation numbers, as you can see, there are always these 3 nodes, but the circuit diagrams can look very, very different with these different options and possibilities that you have there. And so how do I do this? Now I do all the programming in MATLAB. This was too complicated for me, to be honest, to program it in LaTeX with all these. If there's a current source at this position, you need to have a resistor there, because here, to be honest, you really need to be an expert in your field to generate circuit diagrams that where it's possible to calculate them, where the matrix does not get singular, or where you can really solve this equation system, and where there's really just one definite solution of this equation system. So I do everything in MATLAB, and then just generate from MATLAB the LaTeX source code using this circuit-tix package. And then, yeah, you just draw path from a certain point in the coordinate system to a different point, and then say, okay, there's a short connection, or there's this creates a current source, this creates a resistor, this creates a current source again, and then you can just label them with, say, okay, this is the resistor 1, this is the resistor 2, and so on, and also label the nodes. Put let's say these soldering dots at the nodes, and then say this is node 0, the reference node, node 1, node 2, node 3. And then I can from MATLAB not only generate the LaTeX code, but of course also run PDF LaTeX from a command line and generate the corresponding PDF files. And then a sample solution. Here I've displayed the equation systems, or system of equations that the students should set up to calculate the network. And there are the conductances of the resistors, these nodal voltages, and the current sources that are connected to a certain node. Yeah, and now you can see, if I scroll through these different solutions, that these systems of equations really look different. Of course, it's always a 3x3 matrix, 3 unknowns, because the calculation effort should be the same for all students, but these equation systems really look different now. And again, I generate the corresponding LaTeX source code in MATLAB. Say, if there is a resistor connected to this node, then we need to have an entry here and there inside the matrix. If a resistor is connected between 2 nodes, then we need to have some entry here and there. And if a source is connected to a certain node, pointing towards the node or pointing away from the node, then we have a current source in this vector here with the plus and minus sign. And then, of course, for the MATLAB code, it's no problem to insert all the values, and then, of course, also to invert the matrix to calculate these 3 unknown nodal voltages. And yeah, so then the equation system or the LaTeX source code of the equation system generated in MATLAB just looks like this. So you have a matrix, you have all the entries inside some equation. Just that no human being needs to write down everything. The computer, the algorithm can automatically generate hundreds and thousands of these tasks and sample solutions. Okay, so what has come out of it? What are some results that are interesting to discuss? So we do these tasks, as you could see from the procedure, in cycles. A cycle is always 2 weeks. Students get the task, have 1 week to solve it, submit their solutions, get sample solutions from the students, and have another week to do the peer review. And after 2 weeks, everything is done. And then we have a 14-week semester, so we can have up to 6 of these cycles during a semester. And in a typical cycle, these tasks are sent to about 200 students. So this is about the number of students that we have in our lecture about fundamentals of electric engineering. And then, not all, but most of the students, so let's say around 150 students, respond and submit a solution. And then they only get points for their own solution if they also do the review and submit these 2 reviews. But some always forget, so you always lose 5 to 10 students, but let's say about 140 students do the review and carry this out. And from my point of view, I don't know if you have experience with teaching at the university. This is quite good. These are quite good numbers. So we could say, okay, this is kind of an excellent activation of the students during the semester to really solve some tasks and not say, "Ooh, the exam is long in the future. Why should I do something now? I have so much time to do it." So it's a quite good long-term preparation for the exam without this teaching to the test that at the end you have the very same problems in the exam that you covered before in some exercises like this. So then, because everything, of course, these score lists are stored electronically and students submit in this e-learning system, you can do some statistics. So look at the typical distribution of the points, for example, and then most of the students really get full points or almost full points. Why? I mean, they have 1 week to solve these tasks. They can do lots of checks. They can also use, of course, a circuit simulator like SPICE to check, are these nodal voltages that I've calculated by hand or maybe using MATLAB, do they fit to the real circuit? Of course, as said, they can ask their fellow students, I will check your solution if you check my solution, and let's see how we can get the best score, and so on and so on. And that's why, in most cases, they have almost full points. And sometimes also just very few. But as I've talked to students, if they are not really sure about their solution, or if they are quite sure that it's wrong, then they do not submit, because why should they then do the review and so on if they do not get any points at all? The next diagram that I would like to show is a typical distribution of the deviation of the points between the 2 reviewers, reviewer 1 and 2. And then you can see that because of this very detailed sample solutions, the reviewers in most cases also give more or less the same score with very few deviation. And then, of course, there are some cases where the solutions are very strange. Students have done it in a very different way that was given on a sample solution, and then the student reviewers who are not really experts in the field, of course, then they are unsure how to grade it. Should they count points or should they count failures? And yeah, sometimes it's also really difficult then to grade these kind of right but still very wrong solutions. And at the end, I just take the average. Yeah? So if there are two reviews and one said, okay, this is 12 points, and the other one said, okay, this is just 6 points, and I take the average of 9. And this works in most cases. Then it's also very interesting because you can check in e-learning system, in this Moodle, at what time of the day students submit. And so now it's 9:30, and as in this talk, attendance is rather light. Yeah, students, so the busiest times for our e-learning systems are in the evening. There are most stuff happens, and then but until late in the night, but let's say at 5 a.m. or 6 a.m. in the morning, you could shut down all servers. No one would notice because there really everyone is asleep. And then I've collected some fun facts. Of course, it's a German university, so I have to translate the German people can laugh right now, but for the other ones, I have to translate it into English. This is a screenshot from the submission page in our learning management system. And this is the file name of the file that the student submitted. And this file name translates into full points, which I think is very interesting. If as a student, you submit your solution with the name full points, or someone has submitted his solution under the name my own solution, and then as a lecturer, if you think, okay, if there's a file on the computer of the student that says my own solution, is there also a file that is named solution of my friend? And this is also quite funny. This says submit me PDF. Yeah, so, and to be honest, always interesting things happen. If you really, this is also a method where you can really get the students working during the semester and not push everything until shortly before the lecture. So if, yeah, as said, there are 13 different tasks that have been developed so far for all different topics within fundamentals of electrical engineering. And I have one simple task for mathematics. Yeah, where it makes sense to have this randomization, so where people get different diagrams or different circuits, or yeah, problems where you can do this randomization, and where it's still possible for a computer algorithm to understand the problem and to generate such a sample solutions. And so I've done it 4 years now, this method, 8 semesters with 36 runs, and as you can see, generated using LaTeX lots of these personalized tasks, and high number of students submitted solutions, and a very high number of peer reviews that have been done. There are some links to further information. There's a lightning talk, but everything here is in German. I frequently Twitter about this method under German hashtag personalisierte Aufgaben. There's an article in the German LaTeX journal Technische Komödie from German Dante e.V. From 2 years ago, and there's also an FAQ with lots of questions on SlideShare. And now I will also put the link to the slides into the Zoom chat. And so this finishes my talk. And now I would be happy to answer some questions.
Thank you a lot, Matthias, for your talk. That's really interesting. And I like your statistics about submission time.
Yeah, I think it's a little bit, if you would do statistics with this conference, you would get to the same diagram at the end.
That's probably the typical way of working, in fact. Are there questions? I have one about the scalability. You answered a lot of questions already by showing that you're managing the tests for 200 students at the same time. How much work does it take you to handle that?
You mean how to generate such a task, or how to
as a whole, for one? You spoke about cycles of 2 weeks.
Okay. Yeah, so for one cycle, of course, it's distributed. The work is a little bit distributed over these 2 weeks, but let's say I need half a working day to maybe 1 day. Yeah, because some of we at the moment we have a company that programs a new module for this Moodle e-learning system that should be able to do all the stuff on its own. So where you just upload PDF files of tasks and sample solutions, and then it does all this. Students submit something, you send back something to the students. Students submit something, you send back something to the students on its own. Some manual work is here involved because I need to download these zip files, unzip them, run a program that does like this, run a program that does like this. So this takes some time for me, but it's worth it. It's not too much. So for one full cycle with this, let's say, 200 students, 150 solutions, I need maybe 1 day. And the most time, as usually, I need for students that do something wrong. Yeah, so that submit to the wrong form, or that submit in the wrong format, or where that submit the wrong file, or that forgot about this and this. And then you need to send emails back and forth with the students. And this takes the most time if something does not strictly keep to the procedure and to the format.
Okay.
Yeah, so, and if you have 200 people and just 10% of them do something strange, let's say 20, and for each of these students, you need 5 minutes or 10 minutes to correct something, yeah, then 2 hours are over, unfortunately.
And how is human interaction with the students? Because I guess when they notice that they got a random subject, they ask questions. Maybe they are worried that in their case there is no solution, for example. So they
yeah. So we, of course, we have still the usual lectures, and the students have 1 weekly exercise, and they can ask the tutor at these exercises, and there are also office hours where they can come and meet the human and ask about the tasks. But the first thing that they will really always do, and I think it's quite natural for students, they will ask their fellow students, look, I've got this task here. I do not really know what to do. Do you have an idea? Yeah? And I mean, this is one of the things that we really want to achieve with this method, getting the students interacting with each other, and not just talking about what was on TV yesterday or what funny video they found on YouTube, but getting the students talk and discuss and interact with each other about engineering problems. Vic van Dijk has raised his hand.
Yeah, I've got also a question. I find it a really nice presentation, and this system reminded me of my secondary school, where the teacher said, okay, you are together in groups of 4 and you should explain a bit of the lesson to each other, because he said, well, then you learn the most. And then later on in life, when I had to teach some classes, I also discovered that I understood the subject of thermodynamics myself better when I taught it to other students. So I was thinking, besides this system of the assignments you have to correct for each other, do you have other incentives so that the students teach to each other? I mean, you just told that it's about to happen, but do you do more things to steer this, to achieve this?
Yes, of course, this learning by teaching is a well-known method in didactics and pedagogy. So we have a method. I'm not sure how to properly translate it. I would say I, you, and we. So in the exercises also we have a method where students get a problem and then they have like 5 minutes to think about the problem on their own, and they should really at first do it just on their own and maybe look up on the internet or in the script or in the book what information might be helpful to solve this problem. And of course then they will not get any further at some certain point, and then they should ask their fellow student, which is right, left, or right of him or her, and in the group of two, they should discuss about the problem. And maybe the one person found one solution or one idea, and the other one found another idea, and then what they could not solve and were not able to solve on their own in this small group of two people already, they see, okay, just by discussing about this, we now get further ideas and further hints on the problem, and we maybe develop a more elaborated idea on how to solve the problem. And then, so what they discussed in this group of two, then they also announce in this larger group, and then all these groups of two, maybe in a typical exercise you have like 5 to 8 of these groups of two. Then they shortly explain to the other groups what would be their solution to the problem, and then finally, then okay, you agree on this might be a good solution for the problem. Now let's write it down on the blackboard and see if it works. So this is also what we do. But as all these methods, it works quite well in the first week and in the second week of the semester, so then if students are always just as motivated as they really have time for the subject, so if then some other subject draws more attention, it's always difficult to really engage the students in such things. And sometimes students just say, look, we have no clue, just tell us what the solution is. But this is of course not the best way of learning.
Thanks.
Thank you, Matthias. I've posted some of your links on Zulip, but you can check. I guess if there are more questions, people can meet you there.
And you can also find me on Twitter, of course.
Okay. Put your Twitter. Maybe you gave it to me. Put your Twitter account on Zulip. Or in the,
I will do it in a second.
Okay. So thank you again for your talk. I'm one of the one who answered to your survey that I have to think a bit more about it to find some topics that can use that, because I'm in biology. So there are less computations and more writing, but that's definitely a very inspiring way of training people. So thanks again.
You're welcome.
Now we have Vic van Dijk, who is already here. So hi, Vic. He's from the Netherlands. He has a background in chemical engineering and founded a company named Set Your Text that provides services around LaTeX and LeX. I will put the URL in the chat. And today, Vic, you will speak about plotting beautiful graphs, if I understood well. We chatted yesterday on Topia, and Vic told me that he would keep his talk short, about 20 minutes, to have plenty of time for questions and discussions. So please, to everyone, prepare your questions, and I think we will have a great time discussing after. And now, Vic, I'm eager to listen to you.
Thank you very much. And indeed, I will try to show some examples in a presentation that I will put now on the screen. And I am very glad to receive your opinions, etc., and other ideas on this. I think you see it now. The first sheet. Indeed, my talk will be about R and LaTeX, about typesetting the graphs in a reproducible way in your report or whatever you are typesetting. So I will center on this typesetting in a dynamical way, so that when things change in your data or whatever, then also the typeset product can be changed without much effort. And also I will talk about typesetting, of course, your graphs in a corresponding style of your document, or in a totally another style, but anyway, that you have control over the style that these graphs are in. And I also think it's very important to be transparent about the calculations you perform for making these graphs or other research outputs, so others can check what you are really doing in a mathematical way. Well, I'll try in this talk to bring my experiences forward, and I hope that you will also bring your experiences, questions, and ideas and other wisdom forward during this talk or after the talk. So what made me make this presentation was the realization that in hindsight, I think, okay, if only I knew during my studies what I know now, because during my studies, I was tossing around this data, these graphs, these spreadsheets with all the results, and then something was wrong and you had to remake like 10 graphs, or you wanted another color or whatever. And then, yeah, it was really lots of effort for me to make sure that in the final product, everything would be consistent and nothing would go wrong. Of course, I could have done better at that with what I know now, so I will try to share that knowledge now. I divided the talk in three parts. First, I will show you an overview of the techniques I use. Then I will show you the examples I made. I think that's the most interesting part of the talk. And then I will close with the possibilities I see. And I hope that leads to further discussion with you in the audience about what possibilities you see. So to start with the techniques that I used. Of course, I use LaTeX. Personally, I use it via LIX because I wanted always the graphical user interface. And I believe also for people who do not use LaTeX yet, that's really a nice way with a low threshold to start using LaTeX. But of course, you could also omit the LIX part. Of course, I use R. I started using R via RStudio. And then there's the great R and LaTeX package Knitter. And Knitter basically ties R to LaTeX, makes sure that the output from R is input into the LaTeX in a really nice way. And I believe the Knitter, it employs in the background, it employs the TXG program that you also know well, I guess. So about R, this is a free open source programming language. It's used originally, I think, mostly in statistics and in finance, but there's many more applications available. And I believe also in many more fields it's being used right now. Yesterday in the conference, I heard also about people in genomics, biology using this. Connection to other languages is possible from R. So I think that's a great point, that you're not bound to R only, that you can also use other systems if you want. And what I also see is there are some great plotting features. Mainly I use then the R package ggplot2, and it makes possible really nice plots, I think. And then the next sheet for an example of how this looks like when you are in LIX. So this here, I think you see my pointer now, is the LIX window. And there you can see some code, the LaTeX code, or in this case, even R code. And you see that with this read chunk code, you can read in your files with the R code. So there is no need to redo your work in R or whatever. You have your R project with R code, and you can load certain parts into LaTeX. And the knitter is behind the scenes making this all possible. And then when you want to typeset a plot at a certain part in your LaTeX or in your LIX document, then you can execute some R code, because the previous screen I only loaded the R code, and here it's being executed. So for example, in chunk 2, here I call a function, this plot NO2 function, which delivers a plot. Basically, this is the LIX document behind this presentation, so you will get to see these plots in some time. It's not limited to only one line of code or something. You see here there is some more lines of code. You could in theory insert all the R code you will be using in your LaTeX document. I would strongly advise against that. It will be quite a mess, I guess, but yeah, in theory that's possible. What's also possible is to typeset the R code in the document, in your typeset document. So what I did in this report is I put in an appendix where I say, okay, here all the R code that has been used is being listed. And then basically the code should read lines and then the name of the file, and then it outputs, it typesets the R code used without executing this R code. And there's also options available to format the R code, to color it, whatever, to do this in an automatic way. Depends basically on what you want. I think it's very nice to be transparent about the things you are really doing with the data, so that others can also point you to some errors or omissions or whatever. When you typeset the document, in this screen I did it from LIX, then you see that the R code is being executed. In the messages pane of LIX, you will see this kind of messages that might look familiar to you. And then after this is completed, the R code is on 100% execution. Then after that, the PDF LaTeX is being run automatically like usual. I think it's quite complex what's happening behind the screens, but I think it's really nice that it works and that some other people, the developer behind it, took care of this. So now I will go to some examples to show you some examples of things I made. This is an example, and this sheet is building up quite slowly. That's not due to your internet connection, but it's basically because there's way too much data points in this sheet. What I did here is I downloaded some measurement data. It's publicly available on the internet. It's about nitrogen dioxide in air. And at a certain measurement station in the Netherlands throughout several years, as you can see. And this is way too much data points. This is why it gets one big mess, and you can only see a few circles, and these happen to be the data points that are out of the other data points. So basically, to show you, you have to think of how to format your graphs and what to do with your data to have some results here. So what I did here as an example is I just took out lots of data points, then you get something like this. Of course, this is very rude because I took out, I think I left only over one in 672 data points, and that's quite rude. I guess it's better to take median values that you say, okay, about this set of data points, I will take the middle, the median value. Then you have more an idea of what is happening with this data. Of course, this is only an example to show you what you can do. And behind the scenes in the R code, I found it quite simple to do these kind of operations, to go from lots of data to less data and get some insight. Another example is about maps. You've got this European Statistic Office, Eurostat, and they offer an R package. And when you download this, then you can select data you want to obtain from them, from R. So then you don't need to download separate data files. You just issue a command in R. And for example, for this map, I issued a command to get some data on poverty. And I also could manage to put this on a map. So with the colors, the value is indicated. You also see here that making a good map takes some care, because in converting this to the presentation, I didn't have time to also optimize the legend. And you can see here, it's very small. I think it's even not readable for you. Well, for the purpose of this presentation, that's okay to show that you really need to take care of how your graph or how your map looks like, because yeah, that's the point in R. You can tweak lots of settings, but it also means you have to tweak these settings to make some things visible. Another example with these poverty data is the time series. I mean, you can plot this poverty index throughout time for some countries. You see here, I made use of the option to display different dashed lines for each country that I chose, and also different colors. But you also see it gets quite messy. And I also think that for colorblind people, or when this is printed in black and white, you have a problem. It's not distinguishable at all anymore. So it's good to know this is an example of what can be improved. That R also offers a package to so that you choose colors from a colorblind safe palette. And there's also an option, I will show it in some coming graphs, to change the symbols of the graph, so you can always, also without color, distinguish the different lines. Also good perhaps to notice at this sheet that, for example, the graph labels here, they are in the same font as my presentation font. And this is basically because I typeset these graphs. I executed the R code from this presentation, and I did not change the font for the graph. So it's the same font as your LaTeX document. I think that's really nice that you, yeah, well, I mean, I think we all can recognize, for example, graphs that come from a certain package, like, for example, MATLAB. They always will look the same. And yeah, with using these techniques, you can adapt the style. And I think that's really nice. Another example of data on a map. You see here to the left a map of a pixel map of the city of Enschede, where I live, and you see all the circles. These are polling stations in elections, and you see with the color I denoted a certain turnout for a certain party. So you can see here the dark blue color. That's a high voting rate for a certain party at the university, and also here at the city center. And you see in south of the city, it's less votes for this party. So yeah, just to give you an idea that with maps, you can get a quick idea of how data is distributed. To the right, you see a map of the country of the Netherlands, and you see here the circles. The bigger the circle is, the more people live in this place. And those people, those are the candidates of the Dutch parliament. So you can see here basically that with the big circles, that most candidates for the parliamentary elections in the Netherlands, they come from Amsterdam, The Hague, Rotterdam, and not so many people come from the east. Well, when you look at this graph, then you see that I use the size of the circles to denote the value, as well as the color of the circles. So red is this 50 to 150 people, while blue is 1 to 3 people. So both size and color are used here. And of course, with the R code, I had to translate automatically the living place into the coordinates. And yeah, these are things that can be done nicely with all kinds of packages that people contributed to the R system. Yeah, for me, that was doable. I found it quite easy. I did not have to program or something like that. And of course, all the graphs I show, all the lines, etc., are vector, because that's always one point for me that I want to have it all vectorized in my documents. So only the maps itself will be in pixels. Then an example about from the Central Bureau of Statistics in the Netherlands. They also offer a package that you can load their data into R. And I chose here for this example data on motor fuels for transport. Here I chose to use different symbols so you can distinguish between the data. For this presentation, it got a bit compressed, the data, but I think it's still visible for you. And you can see here that all the motor fuel usage over the years since the 1960s. It increased over time. But then I was thinking, okay, yeah, well, it increased, but also the population of the Netherlands increased. So I also pulled down from via the CBS R package, the population data, and I divided this motor fuel usage by the number of inhabitants of the Netherlands. And then you get this graph. And what I also did is I took my birth year, 1985, and I set it to 100. So that's an index year then. And then you can see from this graph, I found it quite nice that you see that air travel here, the triangles, that one increased really a lot. The others also increased, but less than air travel. Well, I'm not an expert in motor fuels or whatever, but just to show you some possibilities, what you can do in not much time with some data, with some packages to typeset graphs in your document. My last example is a bit of fun example. It's about a photo book because I had a problem that I used some Python script to make a photo book for my grandma. And then this broke down, and I was looking around and I stumbled upon this R package to read EXIF data from photos, from JPEG files. And I thought, okay, yeah, well, it might be a bit overkill to use R to generate a photo book, but yeah, why not? Let's try this. And it worked out pretty well. So you see on the next slide an example from of 2 pages from this photo book, and you see here that the description that I added to the photos just in another program in Apple Photos, it has been exported into the EXIF data in the JPEG files, and then R can get this out and then give it to LaTeX, and it's typeset nicely. And also the date the photo is taken on is also typeset. And of course, I made R to sort all the photos on the date. And also R had to do some tricks with resizing the photos and giving the right dimensions, etc. So these were all the examples I had in mind to show you in the presentation. And I now want to end with some possibilities that I see for this combination of LaTeX and R and knitr. For reproducible research, because I think it's nice to have your research you do, of your work you do, in a reproducible way that others can see what you are doing and also can do the same. So I think that this combination of R, knitr, and LaTeX, it makes that the reader of your report or whatever, or your article, whatever you're writing, can read the true calculations you did, because you can include, if you want, the R code you use. When there is a need to regenerate the graphs or make some calculations anew, then you can do this quickly, because you change your R code and you push the button and then everything is regenerated. So that saves the hassle. What I did back in my studies, that I had to recreate like 10 or 20 or 100 graphs because I wanted a different color, or because I discovered a better method to calculate or whatever. And it also minimizes, I think, the risk of introducing errors while making these changes. And I will not even go into the risk of using an Excel spreadsheet and then filling out the wrong columns, and that you get some changes in formulas while you and that you are not even aware of these changes you make. I mean, with R, you can always read what is being done in all your data. And I think it's better research also because you have less redundancy in your calculation methods, and you can make it such that only on one place the R code is written down. For example, another example is that you can make measurement propagation error easy. What I learned in my first years of my studies is that it's important to estimate the measurement errors you have in experiments. And then you also have to take into account this measurement error when you do further calculations with these measurement data. But yeah, then in practice, it's quite tedious. And then in practice, many people don't do this anymore. But I think it's important to do it because it can matter for your final results. You should show error bars. So R can make this easy because there are some packages available for this measurement error propagation methods. Like I said, there's dynamic connection possible from and to R. I read about C++, MATLAB, Python, Fortran, Java, and I think there's many other connections you can make. So you're not fixed to this R system, I think, when you choose to use this. And I think that's very important, because I believe in that people should choose what they are accustomed to, or what they already have done work in, or whatever. And then, yeah, I think that the main idea is that, yeah, you can write about your research project, and you can process the measurement data of your research project at once using these tools. And I think that's better than waiting to the end for the end of the research project to write everything, because that's then can become quite a big hurdle for people to do all the writing at once. And with this parallel writing and processing, it's also nice, I think, for other people to see what you're doing, etc. So basically, that was what I wanted to, what I planned to tell you. Of course, I can elaborate on many points more, but anyway, I'm mostly, I would like to get some ideas from the audience. That would be very nice. Some reflections, some experiences you have yourself, or whatever, or questions, or whatever. And of course, after the presentation, it's also possible to contact me. I guess it's via the website setyourtext.com. That's very easy. So thanks a lot for listening, and happy to take your questions or suggestions.
Thank you so much, Viken, for your token.
You're welcome, you're welcome. I stopped the share, but of course we can go back to the presentation if people want that.
There is a first question, if you want, in the Q&A.
Yes, I'm also reading now. Oh, the Q&A, yeah. Let's see. By true calculations on the data, you mean that we can show the various statistical tests performed on the data and show alongside the graphs? Yes, yes, that's what I mean. So I presume in the R code you perform your calculations. For example, you in the nitrogen dioxide example, I took the mean value of a set of values. Well, there's then the R code, take the mean. And you can show that alongside the graph or in the appendix or whatever. And you can even, of course, you could copy this R code, but it would be best, I guess, to really reference from the LaTeX document to the lines in the R file. So when you change the R file, when you change your method, it's also being changed in your LaTeX document. I hope that answers the question, and otherwise we will hear. I hope.
That's and if you have a mic, you can also speak if you want.
Thank you very much for your talk, Vic. I had a look at your website, I have to say, shortly before this talk, and I'm impressed by your focus on the user experience. I'm also very pleased that you're working with R. I very lately come into contact with it, but never used it. But I've been very impressed by the sort of the community that they have. And Yuhi Z, who created Knitter, I think has got a great deal of good sense in terms of the way in which he handles LaTeX. And he treats LaTeX, he packages LaTeX as something you can use from within R. And I see you nodding your head, and I take that as agreement. So I wonder if you'd like to say a few words about your experience of perhaps of R and perhaps data science, and how the LaTeX community or with the needs of those people rather than the other way around, if you like. I've been a bit rambling, but there we go.
Yeah, thanks for your remarks. And only at the end there was some hiccup. So I believe you said at the end that USG also made it possible to use LaTeX from R. And you want me to elaborate on that? Yeah, okay. Yeah, well, actually, R was also for me a discovery like a few years ago only, because a friend of mine said, oh, you should look into R. And I looked, and I was also blown away by all the packages I saw in all kinds of different disciplines. And I must say, I also saw some comments of people like, oh, Python is better than R because, and it's better not to use for programmers because R is quite different from the usual programming stuff. But then other people said, yeah, but once you have gotten used to R, then it's quite usable. And indeed, I'm very much on this user experience. Myself, I originate from chemical engineering, and what I saw is in chemical engineering, there's many people who want to have the LaTeX output, but don't dare to start the so-called programming part. It feels to them like programming, while the other colleagues from from physics, they are all using LaTeX. They can do this. They find it nice to do this programming stuff. So yeah, indeed, I think R can be really nice. You should get accustomed to it. For me, that was also like, okay, it's a bit different. But once you get the thinking behind how this R works with data, then it works really nice, and you need really not so much code to achieve things. So I use it mainly, indeed, from my LaTeX perspective. I guess also because I was using this earlier on already. But indeed, I saw USC did a very good job in integrating all these parts. And I also believe that people are making reports from R itself or from Markdown of the combination of the two. And what I saw from these applications is you get nice reports, but I guess it's a bit limited when you compare it to using the full LaTeX possibilities from LIX, for example. And that would be my advice from what I know, that okay, you could make a report from R using the LaTeX capabilities, but you don't have then the full set of possibilities, I guess, at hand. But you might differ in opinion, or you might be thinking about something else, Jonathan, I don't know.
I'm very pleased with your answer, Vic, particularly as it's based on more experience than I have. I think sometimes it's a really big advantage not to have the full choice of possibilities.
True, yeah. Let's see, do we have another question from Vatsal? The knitter equivalents, what are the knitter equivalents for Python and MATLAB? I haven't looked into this into detail, but what I understood is you can connect Python and MATLAB to R. So then if you put it into a scheme, it would be like that your data and calculations, they go from Python or MATLAB to R via knitter to LaTeX. So I believe knitter connects R and LaTeX, and whatever connects to R then also can go via that route. If you would integrate Python or MATLAB on itself with LaTeX, I guess there are possibilities for this. But that's another topic, I guess. I've seen once, I dare to go into there, that there is some Python LaTeX, if I'm not mistaken. So yeah, there is a separate way for doing this, but I'm not accustomed to that.
I could answer that question perhaps, because I'm a long time Python user. The equivalent to knitter for Python is their documentation system, which is originally based on LaTeX to HTML. And they developed their own language called restructured text. And the Python documentation, which is very, very good, is written in restructured text and can be compiled to HTML or EPUB or LaTeX. And you can put restructured text in your source files, and the tool chain will extract it from the source files to create documentation for the project. Now, as I realized that, I thought, but it's not for producing reports. And I realized that R is a language for data scientists to use, and data scientists need to produce reports. Python is a language for programmers to use. The users of Python are also programmers. And so they need documentation, and they need to document the stuff that they're doing. So it is the equivalent. The data scientist wants to produce a report for the general public. The programmer, particularly the sort of programmer's programmer, wants to produce documentation for other programmers. So it is the equivalent, but it's for a different audience. Another point of overlap, if you like, is that our studio, Knitty uses R Markdown. It uses Markdown, and so you don't directly write LaTeX. With Python, until something like Python 2.3, you wrote in LaTeX, and you generated the HTML as, so to speak, secondary output. But now you write in this new language, restructured text. So that's another point where they're doing the same thing. They've written their own language that supports the outputs they need, rather than choosing a language designed for a specific format. Well, perhaps HTML is designed specifically, perhaps Markdown is designed specifically for HTML, but I think I've got the point. Thank you.
Yeah, thank you for your addition. And indeed, I must also emphasize that what I did is I took LaTeX as the starting point, because yeah, for me personally, that's the holy grail in putting your IDs in really nicest way on paper in PDF for me. And then I started from this to integrate all the techniques into LaTeX. And of course, you can also do it the other way around when you want to achieve other goals. Let's see, I'm also doing two things at a time, also reading the chat, but perhaps Jeremy, you can also help me with that.
There is another question from that side. I think both for you and Jonathan.
Oh, I'll answer first. Restructured text won't help you produce general purpose documents. It's got language structures entirely devoted to programming. In a certain sense, that goes back to what I said before, that less is more, that it's a customized tool used for a specific purpose. You know, it's a screwdriver, but you can't use it to open a tin of paint.
Okay, thank you for answering. Because I'm not so much into Python, so that helps. I think in the chat it's nice remarks, not so much questions. So I look to the chairman. You always have to describe who you're looking at in Zoom.
I have a question about one of your examples, the one with maps, where you have circles on the maps. So you told that the maps themselves are bitmaps, are pixels.
Yes.
Are that taken automatically from OpenStreetMap or something? Is it a package that does that for you?
Yeah, indeed. So also there are some map packages in R, and I had to fiddle around because some of these map types did not work. But indeed, I think the one I showed you was OpenStreetMap. That one worked, and you can download the pixels for the area you want. And you can also store it, so you don't have to download it every time. It's also nicer for servers, etc. So yeah, in mapping, there's really lots of tools around. Also, the TMap package is really great in putting data on maps and doing everything with coordinates. And you must also realize I did not even show you very advanced examples or something. I mean, if you Google on ggplot2 examples, for example, you will see all kinds of fancy plots. There's really lots of possibilities. And that's also, of course, the caveat that you must think of what your aim is with showing your plots. What do you want the reader to realize, and what do you need for that? And do not put in too much fancy stuff, because it might also distract. I guess that was also the point Jonathan wanted to make.
Yes, that's the point of data visualization. Really help the reader and not overwhelm him or her with data.
No, I mean, it's not art that I try to make.
Matthias in the chat had a remark about compressing data.
Yes, I see. So yeah, perhaps he can tell himself about it if he's still here.
Matthias, if you're still here, you can, I guess you can still jump in, huh? Okay, we'll keep the URL and we'll have a look later, maybe.
Yeah, yeah. I clicked on the link. It's something with MathWorks, but yeah, it's I cannot do this this fast.
In your case, there was a technical issue with too many dots, so that made the plot unreadable for the human and unloadable for the computer. I've had the same case for several kind of data. For the human readability, you have also other technical ways of dealing with the data, with showing the density of the dots sometimes. And for the computer problem, usually when in PDF, when you have too many points, you should just go to PNG format. That's less satisfying, but
Yeah, indeed. Yeah. And I was also pushing the limits there. I also wanted to show the people what happens with too many data points, just for the educational point of view. But indeed, for typesetting this, I also had to increase the tag memory, because otherwise it would run out of memory. And of course, you're then a bit abusing the system. Yeah, of course, you can make also pixel exports like PNG or whatever if you want to, but I guess it is not needed. I mean, if you design your graphs carefully, then it will all be in the limits. And indeed, you can also make the decision to go to other kind of plots, like these density plots or whatever. And really in R, there is really lots and lots of options on all these plots. And if it's not in the package you're using, then it might be in another package. Yeah, there's lots to discover there.
yes, and what I understood in your case, using the moving average or something like that is probably the most meaningful way of dealing with the data and showing the cycle in the data.
Yeah, and it also depends on what you want to show. I mean, I will put in the link on my website. I put the total amount of graphs I made for this project. And you can also, what I found interesting is to make a cumulative view of these measurement data. And then you get this increasing line. And well, it's in the report there. And then you also could take the derivative of this. And then you get another kind of plot. Well, I'm not into this nitrogen dioxide science, or I'm not, and I'm also not so much a statistician, or whatever. But I found it nice to try around what's possible with R. Yeah. Okay.
We still have a few minutes for questions.
Yeah, people, is there something on the YouTube perhaps that we're missing right now? And otherwise, it's also no. I guess that's all. I found it nice presenting this and having some discussion, and also enjoy the rest of the conference very much. So it's really nice that this all is being organized. So everybody, many thanks. Well,
thanks to you for your very nice talk and really inspiring examples.
Yeah,
and about set your text, do you offer help for building graphics, or what kind of services do you provide?
Yeah. Well, it's my mission that more people who have used for LaTeX and R, that they will gonna start using this, because like I told before, I saw a lot of people who want the nice output of LaTeX, but they do not dare to start using this, because then they see all these code, and then they think, oh no, that's not for me, or they tried even and then they got stuck. And I think that's a pity because it's such a nice system. So what I try to offer is to offer some assistance that people can learn to use it with the focus on their applications. Because I think for many people it starts with the research work or other work they have to do, and it starts for them not so much in the interest in what LaTeX is. And I think the people who are interested in LaTeX itself, like many of the people here at this conference, they will manage. I mean, I don't think that I will be able to offer much support to them, but it's more the people that do not manage, that do want, they're resorting now to the other systems like Microsoft Word or whatever, and they, in essence, are not very happy with what they can do there, but they don't know how to get further along with LaTeX or whatever. So yeah, that's my mission, to help people with that, to give some courses, to offer some assistance to get them started. Yeah, and I think also my work is also now going more into the reproducible research area. I see that's now becoming of more importance, and the tools are there to do this. Yeah.
Okay, nice. Probably you will be contacted by people, by attendees of the conference.
Yeah, that would be great. And also if you have got other ideas, or you say, oh, Vic, you should look into this or that or whatever, that's really nice. Yeah. Okay.
Thank you again, Vic. Oh, the next speaker will be Jonathan, but we can still wait 3 minutes, I guess.
Hello.
Hi, Jonathan. Just announcing your talk on Zulip, and I'm here. Okay. So hello, Jonathan. I don't think I have to present you. First, because you spoke yesterday already. And second, because you've been part of the community since dozens of years, I think. And today, you told us that you would share your views about 21st century digital typography. So the mic is yours.
Yeah, thanks very much. The talk's a bit long. Can you start the video? There'll be questions and answers and a conclusion at the end of that. Thanks very much. So, welcome to this talk on 21st century digital typography. I'm pleased to have my friends Arthur Ogawa and Nelson Beebe as the studio audience, and so I feel supported and reassured by that. This talk has got an opening, which you're listening to, and a closing, which will come at the end, and 5 parts. I'll tell you what the parts are. The first is from fossils to the European Renaissance. The second is from 1865 to 1977. They're both important dates in the history of tech. The third is from 1982 to today. And 1982, an important day in the history of tech, and today is too, because we're all here together. The fourth part is emerging problems and solutions. And the fifth part is 21st century digital typography. So the goal of the talk is to get a sort of historical view of things, and from that, be able to understand better what might be coming in the future. So I'm restarting. So the first part is from fossils to the European Renaissance. That's a long period. A few billion years ago, life in the oceans made a big step. It started producing oxygen. The atmosphere became oxygenated, and that made an enormous change. So about 350 million years ago, there was life on land that was creating what we now know as fossil fuel, which is coal and gas and natural gas. And a few million years ago, the genus Homo, man, emerged. So when we emerged to the world, there had already been a long history. Now, at that time when we emerged, we almost certainly had song and dance, because birds and other animals have song and dance. About 250,000 years ago, the Neanderthals started making tools, and they were existing until about 40,000 years ago, and probably they became absorbed into the Homo sapiens that we know. And they probably had language. That's important for us, actually, as typesetters. We can't be anything without language. And human art and music probably arose about 40,000 years ago. So that's the time scale of human culture, if you like. And about 14,000 years ago, there was a really big change, which is that agriculture and settlement started to replace nomadic hunt and gather. So the ancient stories that were passed on through oral tradition, there's the Gilgamesh story in Mesopotamia about a flood. They probably go back to that sort of time of 14,000 or perhaps more years ago. And writing on tablet, which is where our game really starts, is about 5,000 years ago. So that's an enormous time span leading up to 5,000 years ago. There are some plants in the Namibian desert, I think they're called something like Welshia, that are very strange plants that have two leaves that keep growing, and they live to about 5,000 years old. So there are plants alive on Earth today that were alive when we started writing on tablets. I've read that ancient history, that's 3000 BC to 500 AD, has about 90 civilizations with written records. And that is a rich history, rich period that still influences our thought and culture. If we move on to the 1400s, there was something called the European Renaissance, which is people like Leonardo and Albrecht Dürer and all sorts of other people. And part of that was print. And the creation of printing by movable type was famous for Gutenberg and brought to the more modern form by Aldus Manutius. We'll come back to him later. So there, typography was born out of copying books by hand with pen and ink, and that's called calligraphy. And by the 20th century, there were massive printing presses producing millions of copies or more of each issue of a newspaper, which were then distributed on a national basis on the railways. So that's an enormous growth in the progress of dissemination of information. So that's taken us to the end of the Renaissance and perhaps a bit more. Start again. The next part of the talk is 1865 to 1977, two important dates. The first of them is John Clerk Maxwell's publication of his treatise on electromagnetism. And 1977 was Donald Knuth seeing high quality digital typesetter output, which inspired him, together with the problem, to make tech. But we want to have a bit of a historical view, so I'll do some of the intermediary stages. And the time difference between the two, a century, is approximately the difference between Don Knuth writing tech and towards the end of the 21st century. So it gives us an idea of what can happen to create 21st century digital typography. So as I said, in 1865, John Clerk Maxwell unified electricity and magnetism. He built on the work of Faraday. This was followed by Hertz, who proved experimentally the existence of radio waves that could be used to transmit information. And this was followed by the Italian Giuseppe Marconi, who pioneered electrical wireless telegraphy. Isn't that a wonderful word? Wireless telegraphy. It was telegraphy. It's like the things we call automobiles now. We used to be called horseless carriages, so we have wireless telegraphy. And by about 1900, electrification was taking place on a wide scale. It's interesting that it was at first only for lighting, and so it was only at the beginning of the day and at the end of the day, and it turned off during the office hours because there were no computers to run off electricity. But over time, all of this created relays for telephone exchanges, telephones, and radio valves. So everything was all set by the 1940s for electronic computers. And in the 1950s, I think, we got transistors. And in 1968, computer programming had then become quite an important business. And Donald Knuth was writing The Art of Computer Programming. So 1968 came the first volume of The Art of Computer Programming. In 1976, there was a major change in printing technology. It was called photo-optical typesetting. So it was a hybrid of photography and mechanical. And when Donald Knuth saw what his publisher was intending to do with the art of computer programming using this photo-optical typesetting, he was very disappointed and didn't know what to do. But in 1977, he saw high-quality digital typesetting output at 1,000 dots per inch. And that persuaded him that the problem could be solved using computers all the way through, except to the last moment of producing the printing plate. So he started work on tech, I think, in 1978. And by 1982, he'd produced Tech 82, which in its fundamentals is the same as the tech we use now, the Don Knuth's tech that we use now. And anything from 1982, I think, will continue to run on the tech that we have today, which is an important part of Don Knuth's goal, which is to create a system that would produce identical results a century from now. So the next part of our talk is from 1982 to today. And here, the main point is there's been an enormous technological revolution. So somewhere around 1993, PDF was introduced, which greatly simplified the production of printing plates. And in particular, it opened the door to printing plates being directly produced without going through photographic media at all. You have something a bit like a laser printer, but it produces printing plates rather than images on paper. About that time, as I recall, HTML started coming out, and I'll come back to HTML again. In 1996, we had Tech Live on CD and then DVD. The CDs were new media, they were digital media, they revolutionized the gramophone industry. Some more features. We have the Raspberry Pi come out, I don't know, that about 10 years ago. About the same sort of time, we had mobile phones coming out, actually a few years before the Raspberry Pi. We had mobile phones, 3G, 4G. We had flat screen digital TVs, and we had broadband, and we had Wi-Fi. So to use the Olympic motto a bit, everything was bigger and faster and stronger. And the capabilities of the technology, in some sense, vastly outstripped the capabilities of the hardware. In some sense, outstripped the capabilities of the software. And one sign of that is the hardware is considerably more reliable than the software is today. So if we look at 1982 and compare it today, we've got so much more technology and stuff available to us. Stuff that wasn't available when Don Knuth wrote tech. The fourth part of the talk is emerging problems and solutions. This will be a little bit longer. Just as Gutenberg emerged out of the problem of hand copying Bibles, and the electrical industry emerged out of all sorts of other problems, such as something better than hunting whales in order to get candles. So we've got emerging problems in the 21st century. The first of them goes back to the fossils, fossil fuels, more exactly. We're burning the fossil fuels and we have global warming. That is one of the biggest problems of the 21st century. The second problem we've got is the COVID pandemic. And that is a harbinger for all manner of problems if we're unable to sort things out. I mention them not because I've got solutions, but because I hope we find solutions. And it's, to a certain degree, a social matter. The Renaissance was a social matter because it greatly enlarged the power of the market and the power of the enterprises. So having said that, I'm going to specialize on a problem I had myself this week. So I've got a picture of my setup for an online math summer school seminar, summer school conducted by Zoom. And I've got two desks, one in front of the other. Where have I got that? Well, at the back of the two desks, there's a 40-inch 4K monitor, which is in fact a TV, that ordinarily I use as a computer monitor for my computer. And I sit at the back desk to do my computing work. But when I'm listening to the seminar talk, I find it easier to sit away from the monitor so I can see the whole monitor at a time. And so I put a table there as a workspace where I've got my papers and everything. And if you look back to the monitor, you can see in the top right corner, somebody is giving a talk. And on the monitor itself, you can perhaps see some writing. The talk is being handwritten on a tablet. And the computer in the front is my laptop, which is in fact a Chromebook, and that's connected to the TV with an HDMI cable. And I'm using the Chromebook because it's got a microphone and a camera, and I don't have those for my main computer. Now, the whole thing is being conducted on Zoom, which is poor for chat and has a rubbish whiteboard. So the sharing of mathematical content is fine by speech. The speech works really well. I have to say that speech is one of the great things about Zoom conferences and so forth. The handwriting is on a tablet, and that works okay for most people. But there's a problem now, which are the exercises that we do after the talk. They're typeset in tech, beautifully typeset, and they're provided as PDFs, but the exercises are confined to the PDF. it's the only way to get the exercises, and so to speak, everybody in the work group looking at the same exercise, is to do screen sharing. What you can't do is you can't copy a bit of the PDF and put it onto the whiteboard. So that's a sort of problem. And the nature of the collaborative environment provided by a whiteboard and chat and shared audio is, how do we say, a little bit limited. Whereas if you want a proper video conference because you're leaders of the free world or G7 or something like that, you want a considerably more sophisticated setup. Now, I was working in software in the 1990s, early 90s, when one of my company's customers was HM Customs and Excise. And they had a video conference room in London connected to their main office, a clerical office in the South End. It was fantastic. There was a camera and we could see the people at the other end. And if we wanted to communicate a written document, we could use fax. The meeting happened to be on my birthday, so one of the people faxed me a piece of birthday cake. So that sort of video conferencing has changed since then, but we're not really up there. And we certainly don't have in Zoom the great facilities we seem to have with the message board chats, the sort of the IRC chat sort of thing. So there's emerging technologies and there's problems here. And as far as typesetting of mathematics at an online mathematics summer school, it's confined to two things. The one is the exercises in PDF, and the second is that people use text notation in chat and on the whiteboard. There are other emerging problems that I haven't covered, and you probably know lots of them that I don't know. I hope that what I say will apply to other people's problems, to your problems, at least to some degree. The fourth part of the talk is emerging problems and solutions. This will be a little bit longer. Just as Gutenberg emerged out of the problem of hand copying Bibles, and the electrical industry emerged out of all sorts of other problems, such as something better than hunting whales in order to get candles. So we've got emerging problems in the 21st century. The first of them goes back to the fossils, fossil fuels, more exactly. We're burning the fossil fuels and we have global warming. That is one of the biggest problems of the 21st century. The second problem we've got is the COVID pandemic. And that is a harbinger for all manner of problems if we're unable to sort things out. I mention them not because I've got solutions, but because I hope we find solutions. And it's to a certain degree a social matter. The Renaissance was a social matter because it greatly enlarged the power of the market and the power of the enterprises. So having said that, I'm going to specialize on a problem I had myself this week. So I've got a picture of my setup for an online math summer school seminar, summer school conducted by Zoom. And I've got two desks, one in front of the other. Where have I got that? Well, at the back of the two desks, there's a 40-inch 4K monitor, which is in fact a TV, that ordinarily I use as a computer monitor for my computer. And I sit at the back desk to do my computing work. But when I'm listening to the seminar talk, I find it easier to sit away from the monitor so I can see the whole monitor at a time. And so I put a table there as a workspace where I've got my papers and everything. And if you look back to the monitor, you can see in the top right corner, somebody is giving a talk. And on the monitor itself, you can perhaps see some writing. The talk is being handwritten on a tablet. And the computer in the front is my laptop, which is in fact a Chromebook, and that's connected to the TV with an HDMI cable. And I'm using the Chromebook because it's got a microphone and a camera, and I don't have those for my main computer. Now, the whole thing is being conducted on Zoom, which is poor for chat and has a rubbish whiteboard. So the sharing of mathematical content is fine by speech. The speech works really well. I have to say that speech is one of the great things about Zoom conferences and so forth. The handwriting is on a tablet, and that works okay for most people. But there's a problem now, which are the exercises that we do after the talk. They're typeset in tech, beautifully typeset, and they're provided as PDFs, but the exercises are confined to the PDF. It's the only way to get the exercises, and so to speak, everybody in the work group looking at the same exercise, is to do screen sharing. What you can't do is you can't copy a bit of the PDF and put it onto the whiteboard. So that's a sort of problem. And the nature of the collaborative environment provided by a whiteboard and chat and shared audio is, how do we say, a little bit limited. Whereas if you want a proper video conference because you're leaders of the free world or G7 or something like that, you want a considerably more sophisticated setup. Now, I was working in software in the 1990s, early 90s, when one of my company's customers was HM Customs and Excise. And they had a video conference room in London connected to their main office, a clerical office in the South End. It was fantastic. There was a camera and we could see the people at the other end. And if we wanted to communicate a written document, we could use fax. The meeting happened to be on my birthday, so one of the people faxed me a piece of birthday cake. So that sort of video conferencing has changed since then, but we're not really up there. And we certainly don't have in Zoom the great facilities we seem to have with the message board chats, the sort of the IRC chat sort of thing. So there's emerging technologies and there's problems here. And as far as typesetting of mathematics at an online mathematics summer school, it's confined to two things. The one is the exercises in PDF, and the second is that people use tech notation in chat and on the whiteboard. There are other emerging problems that I haven't covered, and you probably know lots of them that I don't know. I hope that what I say will apply to other people's problems, to your problems, at least to some degree. The fifth and final part of our talk is a definition of 21st century digital typography. We'll start by looking at three events in 1494, 1982, and 1989 that are important to the history of typography. In 1494, the Venetian printer Aldus Manutius created what I regard as the first recognizable version of a modern printing house. How did he differ from Gutenberg? Well, he used basically the same technology, but the social side was very different. The emerging literate class of the Renaissance was his audience and financial backers. He produced the predecessor of the modern paperback, books that you could put in your pocket, no longer chained to libraries. He commissioned the first italic fonts and fonts for Greek and Latin. He produced accurate copies based upon multiple handwritten copies of Dante's Inferno. Aldus Manutius had an opportunity, the emerging wealthy classes of the Renaissance. He had a problem, bringing the classical Greek works to that audience using existing technology. And he found a solution, which was the establishment and great success of the Aldine Press. Don Knuth's opportunity arose from the emergence of transistorized electronic computers in the 1950s, followed by large-scale integration in semiconductor memory in the 1960s. It also arose from the social class of computer programmers and the importance to them of algorithms. His problem was retaining the typographic quality of his life work, The Art of Computer Programming. The output from the new photo-optical typesetting machines was inferior to the hot metal methods previously used. His solution was the creation of tech, which we all know and love. He took advantage of the opportunities presented to him in 1977 of the emerging high-quality digital typesetters. After Manutius in 1494 and Knuth in 1982, our third event was Tim Berners-Lee in 1989. His opportunity was based on the internet and the resulting social network of digitally connected scholars and researchers, particularly in mathematics and physics. The CERN particle accelerator was also part of his opportunity. At CERN, the inefficiency and difficulty of finding and obtaining information stored on different computers was a problem. It was an obstacle to the work of CERN and its worldwide collaborators. Tim Berners-Lee solved this problem in 1989 by inventing the web server, the web browser, and the HTTP protocol for communication between browser and server. The rest, as they say, is history. Thanks to his work and that of the organizers, the 2021 Tech Conference is taking place online, with many participating from their own homes. By the way, Aldous Manutius founded the New Academy, a group of Hellenistic scholars. Don Knuth and his colleagues founded the Tech Users Group, and Tim Berners-Lee founded the World Wide Web Consortium for Web Standards. We'll now give a definition of 21st century digital typography. It has three components, namely opportunity, problem, and solution. But first I give a definition of 20th century digital typography. Briefly, it's what Don Knuth pioneered. It is using computers to produce paginated output that can be previewed on screen and also turned into printing plates for the production of books. As in hot metal typography, the primary output is books and journals, but using a different process. The new process automatically generates an index and table of contents and provides an on-screen preview. PDF enhances preview and provides hyperlinks. Sometimes words evolve new meanings. Consider the word telescope, telegram, and wireless. From about 1600, we've had telescopes. It comes from the Greek for far seeing. Similarly, telegram means far writing. The electrical telegraph flourished from 1850 to 1950. Guglielmo Marconi in 1909 received a Nobel Prize for his development of wireless telegraphy. And now wireless means an audio variant of television. And it's also a way to connect to the internet. Here's my definition of 21st century digital typography. It already has opportunities and problems. The solution will have emerged by 2070. The social and technical opportunities are provided by the connected online social world pioneered by the World Wide Web and our many digital devices. These include broadband, streaming audio and video, 4K TVs, laptop and tablet PCs, mobile phones, and 4G networks, with 5G to come soon. One problem for us is that books and journals are now much more read and dealt with only online. Another is the visual output of web pages is inferior in important ways to the typesetting that Don Knuth provided. Accessibility is another problem. I see 21st century digital typography as part of a worldwide information management and distribution system, which includes indexing, linking, searching, and online interaction. I see it as a successor to 20th century digital typography. I see Tim Berners-Lee and those who created HTML5 as important pioneers of 21st century digital typography. I very much hope to see it with tech taking a central role in my own lifetime. Thank you very much. Can you hear me?
Yes, thank you, Jonathan.
Yeah. I'd like very much to apologize for repeating myself. I am not skilled with command line video editing, which is what I was doing, and I didn't have time yesterday to check everything. There's only one thing I want to say now, which is to thank Arthur Ogawa and Nelson Bieber for the great help they provided, both as the studio audience and for preliminary discussions that led up to the talk. Any mistakes and errors and flubs and everything else in the talk are all down to me. I'll now stop and ask for questions and contributions, if that's all right.
Thank you for this really impressional video, and there was no problem. Repeating is also a good thing.
You can say that again.
Are there any questions? I have one, a bit broad maybe.
Good.
In your talk, aren't you in fact interrogating the limit between hardware and software? A limit that appeared recently at the 20th century, but that now exists.
Sorry, I didn't understand what it is you say.
When you speak about your problems for video conference, you show us your hardware that is not completely suitable, so you use software to correct the limit. There is probably an interplay between things that you have to buy that are expensive, your screens, your various links between the computer and screens and everything, and the software that should be cheap, that just intellectual property, and that's really versatile, adaptable. And I think you're trying to adapt your hardware using software, and you're asking questions about what to adapt to correct your problems on.
I think what we've got is a bit of a sort of fragmented experience. So we've got the mobile phone, we've got the radio. So at the conference I went to, we had Zoom for the tutorials. We had Slack for chat and Gather for socializing, and we had PDF for the exercises. And the things didn't sort of fit together. There wasn't a sort of common timeline, and the inability to tech was isolated into being a way of producing PDF at the conference. It was just a way of PDF. And there was also a notation you could use on the whiteboard. So people would write tech formulas in the whiteboard. It was peculiar using typing. And I'm finding that things sort of don't work well together. I think Apple produced devices that are easy to use. and particularly the Apple phone, and that's the big selling point. And tech, the tech revolution, if you like, was part of home typesetting. You could typeset at home, but now we have home video studios and home broadcasting and home networking and everything else. And the whole medium of communication is really changing. Just as the wireless and television changed in the 20th century, so the internet is a big change to communication in the 21st. And in that setting where everything is so dynamic, the idea of pagination seems a bit strange. I think that in some sense, HTML has got the right idea of a page. A page is a piece of information you want to read, and not a long scroll that's been broken up into pieces, which is the tech view. And the ability now it should be possible now to view diverse parts of the same document at the same time, which is what an outliner does. But we can't do that with the printed documents, and we can't pull a bit of a document from one place and put it on our screen. Another example of this is at this conference, we have Beamer slides. Now, I can't think of a worse way to transmit a Beamer slide to an audience live than to do it by a video screen share. Why don't you just transmit the Beamer slide or the source for the Beamer slide to all the participants, and then have something that makes sure that all the participants see the same page at the same time, so that when the speaker moves forward one page, all the other pages move forward one. So it's a sort of synchronized reading, as you might do in a school where one person is reading out from a book and the other people are reading the book at the same time. So I think the gist of my talk is this: we can't repeat the same experiment and expect the same results. Knuth's experiment was improving digital typography for print, for PDF and that sort of stuff. We can't forever go improving our print output and expect to still be top of the pile. The whole world is changing, is continuing to change, and we have to look at the opportunities that exist, which are really very different. And we also have to look at the problems that exist, are also very different. And that's why I was saying at the end that the people that created and promoted HTML5, which is a really magnificent platform for displaying the information of typeset information as you would with PDF on screen. That's why I think we have to sort of look at things in a completely different way. And at the conference yesterday, there were two very, very good talks on accessibility by Alexei Kolesnikov, Almanaki, Michael Cantino, and Rob Bees of Olga Sorga on the one hand, and Michael Nolan, Tom Pagano, Suas Chiki, Langala, and Rahul Jajwal. And they were dealing with accessibility, which is really a new problem. And I see them as doing what was necessary to solve the problem with the opportunities that existed without being hidebound by tradition. And last year, Martin Ruckert gave a very, very nice talk about dynamic line breaking in a mobile device that uses text algorithms. So those are the sorts of things that I see a 21st century typography being. And I've no idea what the world will look like in 2050, and I won't see it in 2070. But if we don't lay the foundations now, then we have the risk of being isolated and the break, or there being a break of continuity. Sorry, I've given another talk. There must be somebody who has something to say here.
Are there any other questions? We still have several minutes, so that's a good opportunity to chat about problems. Past problems also that don't exist any longer and for which we keep the bad solutions.
Say that again.
I'm still thinking about everything you told them, and I think there are problems that don't exist any longer, but for which we keep bad solutions. For example, when you speak about the notion of page, that is a piece of information, that's a solution to lower the cost of books. Instead of having a big roll or something like that, we cut small pieces of paper and we bound them to make books. So we have pages. That's a solution to a problem that we had previously when books had to be hardware things. Now we are doing a lot of things online. And as you told, we don't need any longer to have pages, but we keep the physical pages on our screens.
I understand very much what you're saying.
And so I feel we're keeping a bad solution to a problem that doesn't exist any longer.
Yeah, let me take another example, which is printing was a solution to the problem of the high cost of scribes. And reproduction on paper was the way printing worked. But we don't need to print anymore if we've got perfectly good screens that we can look at. And here's another, here you've hit the nail there, because there was something called blockbuster videos, which are now dwindled to one store. And there was something called DVDs, which are now being replaced by streaming. So to see DVDs was a solution to the low quality of videos. But the videos were a solution to the problem of distribution of films. And now we've got the internet, we could just stream everything. So nowadays, computers don't have DVD players in them. I recently considered buying a new case for my next computer and discovered it didn't even have a bay in which you could put a DVD writer. So yes, I think you put it very nicely that we keep using old solutions to problems that are no longer there. There may be more to it as well, but that's a nice way of putting it. I really think I should re-record this talk, and I welcome any contributions people can make to us. It's time to stop now, isn't it? And go on to the next talk.
Yes, I can see that Andre and Peter are ready. But if we can still, if there are questions, it's still time to ask them, and maybe Jonathan can answer them during the break. Don't forget that we also have Topia and Zulip to interact. I put some links to your tech hour on Zulip. So hopefully,
oh, thank you very much.
Hopefully next Thursday you will have some more people coming. I watched some replays on YouTube, and that's really interesting. I think I will join at some point. Okay, if there are no more questions, thank you again, Jonathan. And I think we can slowly move on to the next speaker. Andre, Peter, can you hear me?
Yes, we can hear you. Can you hear us and see the presentation also?
Yes, we can see the presentation and I can hear you.
Perfect.
So let me introduce you. We will now have a father and son talk by Andre Soika and Peter Soika. Andre is a son that we can see now on screen. He's a bachelor student in informatics at Masaryk University in Czech Republic. And his father I'm sorry, I'm not sure how to pronounce your father's.
Right.
Peter?
Yes. Yes.
Okay. And so Peter is an associate professor in the same university. They presented some really interesting work 2 years ago at Palo Alto TUG meeting about hyphenation patterns. And they got a question from Donald Knuss about the similarities between Czech and Slovak languages. This question triggered a new project, and that's why you will speak about today, I think.
Yes. Yes. Okay. Thank you very much for the introduction, and welcome to all the listeners. My name, as Jeremy said, is Ondřej, and I will take you with my father Petr, who will also speak, on a journey that led to the new Czechoslovak hyphenation patterns. The first hyphenation patterns that covered 2 languages without any kind of compromise. The journey started in Palo Alto 2019 at TUG. You can see on your screen a photo of the attendees. In addition to me, my father and co-authors of this work, you can see also Don Bluth there. So Petr will start with the introduction to the topic of pattern generation with Patgen, which may be less familiar for most of you. And then I will show you some of the intricacies of the Czech and Slovak languages and walk you through how we actually went about the generation of these patterns. We'll conclude with an overview of how Czech and Slovak speakers can use the patterns and how we plan on including them in TechLive hopefully next year. So Petr, I think we can start.
Okay, hello, welcome. It's nice to meet some of you again. Frank, Marcel, Artur, Jeremy, and others. Let me introduce you to the esoteric world of hyphenation, patterns, and Patgen. It might be to some extent rather peculiar area, but I think still there are ways for improvement, and it tackled me with my computer science background, as this is programming parallel, and the data structures allow very nice and superb and congenial things. So patterns. 40 years ago, when Donald Knuss started his project, of course, the typesetting system needed hyphenation, and he started with algorithmic method for English, which covered only 40% of hyphenation points, and was only possible to be used for English. And his doctoral students, Frank Liang, strive for general language independent method that would cover all the exceptions and exceptions and of exceptions and exceptions of exceptions of exceptions that appear in the language. There is no single rule that or positive expression where to hyphenate, and one needs really level of exceptions to be handled. And his idea was to design patterns that are substring of characters of the word with the information about hyphenation between characters. So the pattern HY3BH tells that the number 3 tells that hyphenation is permitted, odd numbers permit, and even numbers forbid hyphenation. So with this context of characters on the left and the right, one tells the rule that one can hyphenate or not. And as patterns are as short as possible, it covers also generalization properties, as the compound words work here as well. And the patterns compete with each other, and one can have up to, I guess, 9 levels with PathGen. So this level of this number of exceptions is are possible. And patterns are also nice that they are very small compared to the standard dictionary problem, where one should store the words of the whole language. For Czech, there's 6 million words. With hyphenation patterns, the patterns are fraction of the size, less than 1%, are sufficient to cover the information of hyphenation points. Here you see how it works on a word hyphenation. Tag for each word in each paragraph in pass 2 or 3 finds hyphenation points for words, and it looks in the 3 data structures for all substrings of the word. And in the case of hyphenation, it founds 8 patterns. And you see that between E and N, there are actually 4 patterns. The first one permits hyphenation between NA, and the patterns generated on the level 2, HEN, forbids the hyphenation between N after HE. So finally, this algorithm, which is in constant time, which is the depth of the tree, finds that where hyphenation hyphenates after H, after Y, and after N on two points. So that clever solution to dictionary problem at the constant time finds all the hyphenation pattern hyphenation points for the given language. So that's pretty nice, but the question remains how to generate such patterns. Liang was tasked by Knut to generate as high coverage as possible with less than 5,000 patterns, with less than 30 kilobytes per language, which was related to their computer RAMs, which were in hundreds of kilobytes. So there were really demands on small data structures that cover the big language data. And at the end, and you find in each tech installation, the file -tech generates language 0 with almost 90% of coverage of hyphenation points that were generated in 5 levels from pocket-size Webster dictionary with less than 100,000 words. And it took 1 hour of CPU on PDP-11 these days. And the main result is this roughly 4,000 patterns. Nowadays, the possibilities are much bigger. And in my previous research, I have shown that exact lossless pattern minimalization is a non-polynomial problem, which was proved by a reduction to the minimum set cover problem. But luckily, strict pattern minimality with respect to the site is not an issue nowadays. It doesn't matter whether the patterns are of 30 or 33 kilobytes. And at TUG, we have shown that lossless pattern generation, that means we cover 100% of a big dictionary with 6 million words is feasible, and we get patterns that reach 100% coverage and no errors. So that was shown 2 years ago for Czech, and this work continues on that. As you know, we split it in 1993 with Slovaks, but still hold Czechoslovak tech users group. And our languages are very close, very similar. The transliteration or pronunciation and syllabification and grammar is very, very close. So the main outcome of today's lecture is our new Czechoslovak hyphenation patterns we have released just now and suggested to be included in tech-hyphen package for next tech leaf. And it's all up on Andrew's GitHub. And he will continue how we developed these patterns for you and for Czechoslovak community. So that's introduction to the pattern word, and I pass the journey to be followed to Andrew. Please.
Okay, thank you for the floor, Peter. So I will now speak in the section on Czech-Slovak and Czechoslovak, where I will show you why Czechoslovak hyphenation patterns are the perfect proof of concept for the idea of universal hyphenation patterns, why these two languages are just the perfect ones for a proof of concept for universal hyphenation patterns. So why hyphenate Czechoslovak? They're two separate but very similar languages. For example, 40+% of students at my faculty are Slovak. So you can imagine that in the discussion forum, for example, someone writes something in Czech, quotes someone in Slovak, continues in Czech, and someone replies to them in Slovak. This happens every day, and there's no way to break the words currently without butchering the Slovak ones. As I mentioned, it's also a proof of concept for universal hyphenation patterns. This is the main rule for whether we can create patterns that hyphenate two different languages. Is there no word that has different hyphenation in the covered languages? If there's none, we can cover multiple languages with one set of hyphenation patterns. Okay. This is an image of the lexical distance among the languages of Europe. So this is how close languages are to each other according to how they're written, not spoken. I would say that Czech and Slovak are even closer than this. In how they're spoken. Yeah, this is a zoom in on the Slavic languages. There are two main approaches to hyphenation. They, as is common in language, compete each other, but for example, American English prefers to hyphenate morphologically based on the etymology of the word, on the stem, prefix, and affix of the word. Whereas American English prefers a simpler, quicker, lazier, I would say, approach of hyphenating according to phonology, so according to syllables. For example, German prefers to hyphenate on the stem of compound words, but within, for example, long stems of words, it uses phonology for hyphenation. Regarding universal hyphenation patterns, we should note that current good patterns also must learn to hyphenate foreign words, for example, Google. Because imagine you're reading a document, the word break falls on Google, and you start reading it like go, and then you flip the page, and you should continue, and then you can't continue because you just pronounced the word wrong. So hyphenation must not disrupt reading. The correct hyphenation, even for Czech or Slovak patterns, is Google, the English one. So it's immediately clear to the speaker that this is not a Czech word. In Czech, hyphenation is primarily syllabic, according to pronunciation, and morphology is only secondary. So in compound words, we also hyphenate according to morphology. The Czech Language Institute publishes very precise rules on how hyphenation should work on their website. And in Slovak, morphology is officially primary. So not only in compound words, but the Slovaks officially prefer to hyphenate on the between stem, prefix, and affix. But pupils learn to hyphenate syllabically, and I have asked some Slovak speakers whether they know that the Slovak officially hyphenates morphologically, and they don't. Current Slovak patterns also hyphenate mostly syllabically. And yes, morphological boundaries also often syllabic boundaries. So the difference in practice is not so big, especially in Slovak. A few observations. It is a problem to tell apart the prefix ne from an e. This is what patterns basically solve very nicely. Slovak patterns hyphenate syllabically most of the time, even though the Slovak patterns does something, recommends something else. In the example below, you see the word that means painted, the adjective, and maľ, M-A-L, is the verb that means to paint. In Czech officially, you should hyphenate vymalovaných, but in Slovak, you should hyphenate the verb. We solved this problem partly by allowing both hyphenations because none of them disrupt reading in this case, but we prefer to hyphenate purely syllabically since in many words, you don't know whether they're in Czech and Slovak. So we prefer the lazier, the easier to read version of syllabic hyphenation. So these are the trade-offs, and we decided to hyphenate syllabically because that allows for easy reading. And it is a clear trend that Slovak is moving towards purely syllabic hyphenation as the lazier approach that usually wins with language users. Now I'll start the section on pattern generation. Well, I'll show you how we actually went to generate these patterns because we have good Czech patterns, mediocre Slovak patterns, Czech Slovak word lists, and a Czech hyphenated word list. We used the Czech hyphenated word list, which is official one from the Czech Institute of Linguistics. That should officially be like perfect. It is not, of course, but we used this one to obtain good Czech patterns. So, and of course, we also have human hyphenators who can look at any inconsistencies in both the word lists and the hyphenated word lists and fix them. We want to come up with a workflow that leads to patterns that miss very few hyphenation points and make nearly no mistakes in either language. How do we solve this? We start by having the intersection of words that are both in Czech and Slovak and the join of the words, then Czech and Slovak. Then we use Patken with as hyphenator with the Slovak patterns and with Czech patterns, and we compare the difference between how the Slovak patterns would hyphenate the words that are both in Czech and Slovak, and only in Slovak, and words that are hyphenated by the Czech patterns. We look at a difference manually and add any places where the Czech patterns were wrong to a file of corrections. So we try to have this file as kind of a compressed version of what is the difference, what is the difference of Slovak hyphenation compared to Czech hyphenation. We don't use this file, generate another version of CS hyphen patterns, so the Czech, as we progress, they become progressively more Czechoslovak patterns, and repeat this cycle. I think we repeated four times. This is an example of pattern generation with custom parameters. The parameters, for example, the first level shows that Patken would need to avoid missing 12 hyphenation points to add one good, and it would need to avoid 3 bad to get one good. It basically sets how aggressive should Patken be with setting parameters, with the generation of patterns. So you see, in the first level, we only generate 800 patterns, then add more. As Peter mentioned, the first level, odd numbers permit hyphenation, even numbers forbid hyphenation. These are the results of tenfold cross-validation, which is a process where we, patterns are generated from 9/10 of the word list, and performance is measured on the 1/10 of the word list that that Patken hasn't yet seen. This is repeated 10 times on each part of a tenfold word list, and the performance is averaged. So you can see with custom words, we let a few words slip, a few possible hyphenation points just slip. We checked all of the missed and bad hyphenation points, and I think I can say they're mostly very rare inconsistencies, often words that you wouldn't actually write because the word list came from the internet, and often words that just are such examples that you would have to create a pattern only for that word to hyphenate it correctly. This is a conversion of training results, not validation results. You can see it's pretty easy to set up the patterns to miss 0 once. They just create a pattern in the end for each word that is not hyphenated correctly, and you can very easily achieve 100% accuracy on this. So conclusions. We created new Czechoslovak patterns. We released, we built up a new Czech and Slovak hyphenated word list that are mostly correctly hyphenated, but still the language is used. It's a language is used, just so it's not an authoritative word list. And we came up with a workflow to acquire a mostly correctly hyphenated word list, and a workflow for pattern development and pattern generation that is very customizable. So we also came up with a way to just customize current, in this case, Czech patterns, and add on another language there. All of this is already on GitHub, as Peter already mentioned. Yes, in the paper from this slide. The next steps are inclusion is the inclusion to tag hyphen. There are 2 approaches to this. We can either add a new Czechoslovak language in Babel and Polyglossia, which I would say is a cleaner approach because the 2 languages also have I think, the same. I'm not 100% positive in that, but I believe most of the other rules around languages are very similar in Czech and Slavic. Or we can just release new patterns that replace both Czech and Slavic patterns. That's it. Thank you for your attention. Do you have any questions?
Thank you a lot, Andrei and Peter. Are there any questions?
I have a comment and a possible answer to the last slide, actually, that Andrei just showed. Okay, they're interested. Yes, thank you. So, as you know, I'm one of the two main people responsible for Tech Hyphen. The other person is Moritz Klavet, who is usually very busy. So I'm really only doing the administrative work, so to speak. It's really not up to me to decide whether the new patterns should replace the old patterns. It's really entirely up to Czech and Slovak users. But what I can recommend is that, because I'm also responsible for polyglossia, we could definitely create a new Czechoslovak language or some such name, and then recommend users to use it. And then, depending if they're happy with it, if they're happy with the new patterns, then it could progressively replace the old ones. So they could have sort of two levels. I mean, the patterns are at the bottom, of course. Babel and polyglossia, the macro support level. The Czechoslovak language could be there all the time and progressively replace the Czech and the current Czech and Slovak patterns. And I'm absolutely happy to spend the time necessary to make that happen. I'm sure we'll talk outside of this conference.
Great, thank you.
There is a comment from David in the Q&A. Can you see it? Well, do you want me to read it?
Yeah. The question is, could you set up the two languages at Babel levels, so different fixed language string, but share the same language, so patterns loaded only once? Yes, that's definitely the option, so that the languages are, the patterns are shared in between the languages. So it's a matter of setting up the generation of format file generation. But Arthur has more final word on it. Please.
Yes, it's not quite at the format file level. It's really at the language support level. But yes, we can absolutely do that. David, we already do that for many other languages. So yes, and we are aware, of course, of the problem. We don't want identical pattern files to be loaded several times, of course.
Okay, so if there are no more questions.
I have a naive question about the two languages, not about the hyphenation patterns, but two languages. You told that a lot of people can use both languages. Is it in everyday life? Is there also some literary form of the languages that are more separated?
So some what form?
Literary, for when people write novels, write proper language. Do they do more distinction between the two languages?
I would say yes. I mean, novels are written in either language, never in kind of both. There's not much expressive power that you get by switching from language to one language to the other. So people usually just pick the language that the recipients understand better. For example, at my faculty, we have many professors or lecturers who speak both. and when they speak to a Slavic student, they just switch to Slavic, and when they have a lecture, they speak Czech.
Okay, thank you. Apparently, Tom has a question. Tom, can you speak?
I think that was just a reaction to a comment to David's question earlier.
Yeah, well, it was more a reaction to Jeremy's question. Languages are this thing, but in the spoken form, basically, if you travel from Prague to Košice, you have a smooth transition of the way how the people speak. I mean, there is like no stream boundary where you would say, this is the place where Czech switches to Slovak, which is like completely crazy, but still the written languages, because they are sort of fixed by the authorities, are quite different. So the written languages cannot be mixed, but the spoken languages are mixed like on a daily basis, basically.
Yes, that was what I had in mind in my question. Yes, thank you also for the clarification.
You're welcome.
We still have time for questions, if there are.
The question Werner asks is, do you maintain a commented word list of the two languages? Yes, it's all in the repo, similarly to German, where they maintain even their versions for variants of German. We released, and it's up there together with makefiles that generates the patterns in the repo. So they are there. Andrew, what's the names of the file?
I think
it's in the directory src, I guess. So you will definitely.
I think
you may find it there.
I think it's CSAK all VLS, but it's very possible you don't find this you have to generate it, I think. So you have to run the makefile and then the file appears, I believe.
Yeah, and Arthur wants.
Arthur says he would like to answer. Yeah, okay.
No, I'm just doing housekeeping of the question.
Yeah, yeah.
Okay, okay.
Yeah. Okay, so that would pave the road to possibility to generate universal hyphenation patterns that are based on the pronunciation, and then use them, for instance, in browsers where in CSS3 there are possibility to hyphenate. And as people are not switching languages on web pages, typically one can use this universal syllabic hyphenation patterns for the web-based hyphenation browser. And there is no, once one has the word lists, it's no problem to kind of merging Cyrillic, Arabic, and other languages, given that one has a sufficiently big version of 3 that permits more than 1 byte alphabet encoding. But that feasible, and that one of the outcomes of our journey. And other questions?
Okay. Anyway, I'm really impressed by the amount of work you did on that. All the hyphenation patterns required a lot of work, and you managed to merge in a sensible way two sets of patterns. That's really impressive. Huh?
It's tedious work, especially when one wants to clean up the word list, as we have developed the custom patterns for that, so that it emits only bearable number of bad hyphenations on the borderline between adding or not adding the pattern. And once fixing that, we iterate on that process and generate fix the word list, generate new patterns with the custom setting, and you may repeat that more or less indefinitely with big word lists like we have with 7-figure word number. We also realized that in the case we want to have smaller patterns, we should mark all syllable-based hyphenation point in the word list, even those for left hyphen plus right hyphen equal 1, so close to the border of the list. And in the case one would do that in full, so coherently, the size of the patterns might even be smaller, as the patgen creates the sense of syllable, and the patterns generated are then smaller, and the hyphenation points near the border are then just filtered out with left hyphens and right hyphen parameter setting in the format generation. So that there are plenty of improvements on that level that would allow even smaller patterns, even more coherent word lists, and you may add more languages more or less indefinitely. But having the word list of a language definitely opens many new applications, especially for custom project, where you can filter all words used for a given project, encyclopedia, generate custom patterns, very small patterns for that project, and then use that on the web or on the typesetting system of your choice. Being that LibreOffice or Word, actually the Word version uses, at least for Czech and Slovak, pattern-based technology in the DLL, and I think most of other systems simply inherited patterns from tag hyphen and use that for the purposes of LibreOffice, tag-based systems, and the like.
Okay. Nice. Well, thank you again for this talk, for this huge work, Peter and Andrei. If there are no longer questions, we now have a break of a bit more than 1 hour. Here in Europe, it's lunchtime, so bon appetit. See you later.
Thank you.
Thank you very much, Peter and Andrei.
Hello, Jean-Michel.
Hello, do you hear me?
Yes, I can hear you. I can also see you. How many? 33%.
Fine. Okay. Normally, you should see the first page. Is that
Yes.
okay?
We have your
Okay.
title page. I can see still a few people are coming, so except if you're really tight regarding time, we can wait 1 or 2 minutes. Okay, let me introduce you, Jean-Michel Hufflen, from University of Franche-Comté in the east of France. He's a research fellow in software engineering with a deep interest in XML, in LaTeX, of course, and bibliographies. He's the author of re-implementation of BibTeX, and I guess that today, Jean-Michel, you will push again the limits of bibliographies. So the screen is yours, and we are listening.
Okay. The goal of this presentation is to express some idea about bibliographies. These last years, many progress have been made about bibliographies with LaTeX. BibTeX has been replaced by other tools, mainly by Biber and the BibTeX package. And I would like to express an original view about the present state of these tools. I will signal some important points for me. Maybe you remember that some years ago, I proposed myself a new implementation of BibTeX. I will give some news about that at the end of this presentation. So in fact, the basic idea of this view is, for example, a text processor runs a computer. That is, this is a program, but end users of these programs do not directly perceive what is done. That is, they don't know, they don't see the successive statements of this program. For example, if you consider an interactive processor such as Microsoft Word, it is customizable. You can change some setting, but the graphical interface just offers you the result, and the customization is possible mainly by interactive menus. If you consider LaTeX, there is a kind of programming more present. You perceive the process as a compilation, a compiler process, that is, a source file is transformed, is arranged into a printable or displayable file. Customization is possible too, but by means of a programming language. An interesting question could be, can a text, a source file processed by LaTeX, take advantage of programming features? For example, answer that some words are capitalized, or put in lowercase or uppercase. That is, some calculations performed on some parts of this text. For this example, that's okay. In fact, these features, capitalization, etc., are very easily programmable with the language of TeX. In theory, the language of TeX has the power of a Turing machine. So you should be able to express what is computable. In practice, that is quite different. Try to program a sort procedure using the command of TeX, that's worthwhile. For example, a counterexample, sort an array of numerical data before formatting it is tedious. So by this example, I will express that the power of a programming language is given to a LaTeX user, but in practice, quite limited. In fact, now this problem is solved because of Lua. That is, LuaTeX allows its user to use both programming features and formatting features. For example, here. If we consider a tool building a bibliography for a LaTeX document, what this tool has to do? First, searching bibliography database is containing resources, extract them. Very often, this bibliography should be sorted, and each resource should be formatted in a reference process LaTeX will process. So, in fact, the three steps were often done by BibTeX. Now, it's quite different. That is, the BibLaTeX package for people using it allows LaTeX to format each reference because the result is marked up by LaTeX command. In fact, a quite equivalent approach is used in context with the bibliographic module. So the first two steps can be done by BibTeX, and now Biber is preferred because it's more in synchronization with BibLaTeX. What is about programming features with BibTeX? let us recall that BibTeX remains used. For example, some conference submission tools only accept BibTeX and no other tools that such as Biber. BibTeX has a language for bibliography styles, which is old-fashioned, but this language expresses algorithm. That is, we have almost the expressive power of a programming language. Almost, because BibTeX cannot deal with numeric sort. The only way to sort in BibTeX is to define a sort key, which is always a string. BibTeX only performs lexicographic sorts. So, my point of view is okay for the availability of a programming language, but not powerful enough. So, for example, for sorting, that is clear. BibTeX is very limited. In BibTeX, this step is performed not by the tools of written using text language, but by the tools, for example, Biber. But in BibTeX allow many specific files for sorting. For example, sort title if the title information should be used for sorting. But we don't have really an access to a general sort procedures. BibTeX also sorts lexicographically. Many schemes are predefined. You can browse the section of the manual about, for example, sort by year, title, name, arrange as you like it. But that's strange. There is no way to use month information for sorting in BibTeX tools. Difficult case can be addressed if you are able to use declare sorting template command. That's a worthwhile exercise. In fact, I think that in practice, that is the last key, sort key, which allows end users to get familiar with some complicated situations. In practice, what is such complicated situations? Some years ago, I was in charge to prepare the bibliography reference of the publication of my institution. I had to sort this big list first with respect to research teams, second using names of peoples, and three, year and month, year being in reverse chronological order. That is possible to express in BibTeX, but very, very, very complicated. So I think that is access to programming tools with BibTeX is better than in BibTeX, but not really complete. That is strange. BibTeX uses type information. For example, year is a year of the Gregorian calendar. But this information cannot be used to numerical sort. That's very strange. There's some a kind of incomplete view from my position. Another point is very strange for an advanced tool. For example, if you have several authors or editor, or what is used to sorting references, Bibliotech has a maximum number of names it can use for sorting. You can not define a sort procedure able to deal with any number of authors. In the text, that was worst. But here also, I was quite disappointed by Bibliotech. As customizable, but not really unbound with respect to several author editors. Another point is illustrates, from my point of view, the need for accessing a real programming language. I don't explain in author style just for alpha styles, but in fact, suffixes are added in case of ambiguity, that is, author and year is not are not sufficient. For example, two references in the year 1964, so labeled by A or B. You can do that with BibTeX, with Bibliotech. That is quite accepted. There is another way to process. I confess you can find in very old books, but it is possible. You can use only the year for the first reference and add an extra label after. The second way, you cannot generate it with Bibliotech. In BibTeX, very, very difficult. If you are able to program, that should be very easy to choose between these two parts of an alternative. For example, a good example of good connection with bibliography and programming are given by the bibliographic module of context. That is, the format of references as they are parsed is known, and you can attack it with the programming features of the Lua language. That was the same with ML BibTeX, programmed in Scheme, and the next version, that is 1.4, will deal with encodings. About this subject, I mainly demonstrated the version 1.3 some years ago, and some people used it, and the file is no longer available. That's because the repository of my institution has been moved. Some parts have been discarded. version 1.3 is still working, but in practice, the problem is not compliant with Unicode UTF-8. That is, at this time, it was designed for encoding Latin 1 or Latin 2. So 3 years ago, I announced a new version. Good news, I personally escaped COVID-19, but I have an additional amount of work. For example, translate all my lectures in video conference, and I skip the other details. So that's why my work on MLB Tech 1.4 has been slowed down these 2 last years. In fact, the only lacking part is to install it. That is, the program is ready, but I have to decide about installation procedure. I hope to do that at the end of this year, that is to be ready in the winter. If I hope to be able to do that. In fact, I summarize what can be provided by MLB Tech. The same that for the bibliography module of context. That is an open format for bibliographies. That is a clear specification. So I program can deal for arranging this resource into references. That can be done in a scheme or in tools related to XML. A better interface with scheme for some important procedure. For example, if you are able to write a sort procedure in scheme, you could use it to sort your bibliography. For example, as another example, if you are able to write a program generating disambiguation labels, you can use it to generate your own labels. The same if you use an author date system or author number system. And which may be of interest for bibliotech users, compatibility for some additional fields. I explain. If you use bibliotech, you know that you can use year or month fields, but now it's preferred to use a date field. Okay, some additional fields are interesting, but if you have to revert to old BibTeX, for example, because of a submission tool for a conference, in practice you cannot use the additional fields. But in MLBibTeX, they are recognized. That is, if you use a date field, it will be automatically converted into year, month, and other information. The same for some additional fields like issue or editor A, editor B. So that is, you can use some BibTeX style, but with the file of MLB of bibliotech. Maybe you notice that in previous demonstrations. The difference between BibTeX and Viber and MLBibTeX, BibTeX and Viber are quite permissive when they parse bib files. Some error can occur when the formatting holds. That is quite different in MLBibTeX. That is, it's not as permissive. For example, if you specify a year field, which is not a number, you got an error. If you specify an author field, not format in 4 parts of names separated by the keyword and, the process stops. I recognize that it's difficult for people, but that for me, it's like a kind of compilations. If you compile a program and you get errors, you must correct, you must fix them, but you can think that some errors have been detected. That's the same for MLBibTeX. The type checking is stronger than in BibTeX and Viber, but it allows you to use more powerful procedures. In fact, what is planned is MLBibTeX analogous to BibTeX, but as I explained, with some additional fields recognized. MLBibTeX is analogous to Viber in the sense that it generates files suitable for the BibTeX package. Analogous to Viber, but not identical. That is, you can use some your own procedure in Scheme or some predefined to sort. That is, you have the power, full power, expressive power of the tool. The problem is sometimes the interface lines may be long. We will see. So, in fact, from a philosophical point of view, I prefer this view. I'm a programmer, and for example, I'm frustrated if I cannot use a tools with my knowledge of programming. For example, I enormously appreciate a tool like Emacs. Emacs, you can use it as an end user, and you can add some your function. You can customize it. That is, it is an open system. And personally, my ambition is to make MLBibTeX something comparable with Emacs. When the first version has been diffused, some people told me that MLBibTeX was a wild animal, only recognizing its master. That was true. That was true. I recognize that it was difficult for beginners to use MLBibTeX. I try to fix that for the new version. We will see. The only thing I can see now is the new version should recognize any master, provided it expresses its his order in Scheme. thank you for your attention and be ready for the new version. In the printed version of this article, I will more develop some point more in about impossibilities of programming in 1 week.
We lost your sound, Jean-Michel. We missed the last few sentences, I think. Can you hear me?
Yes.
Okay. I thought something was muted. Thank you a lot for your nice talk and your project. You pointed out a lot of problems with existing tools. And I must admit, the first time I heard one of your talks, it was about sorting the production of your lab for the evaluation agency, and I was really impressed by what you did. It's nice to see the progresses. Are there any questions? So please feel free to raise the hand or ask question in the chat or take the mic. I have a few questions. So you chose ML BibTeX not to be a drop-in replacement of BibTeX. So you're changing the format of the files.
What you mean by format?
You cannot just reuse your bib files and run ML BibTeX instead of BibTeX. You have to change the format.
Yes. Yes, in fact, about format, you have two solutions. You can run a bibliography style file of BibTeX, and you can run some direct file that is completely written in Scheme. As an example of a direct style, ML BibTeX is completely written in Scheme. It uses the convention of a bib file, but it's completely different.
I'm quite curious about the format you chose, because you spoke also about description language based on XML. XML is not really popular among LaTeX users because we prefer the expressiveness of LaTeX. And personally, I think that XML is a very good tool to have computers communicate between each other, but not for human.
Can you repeat, because I bad internet connection. I miss the end.
Yes, because regarding the format you chose, I'm quite curious about what it looks like. Because you spoke about language based on XML. And XML is not really popular among LaTeX users. Huh?
Yes.
Most of us prefer the expressiveness of LaTeX and consider that XML is just a way for computers to communicate between each other.
In fact, the reference to XML is because the result of parsing a BIP file can be viewed as an XML file. In fact, there is a scheme representation of this structure, but this is exactly one-to-one correspondence. That is, that's the SXML format, but you have the same kind of information as in XML file. For example, namespace, attribute, element, exactly the same.
Okay.
So, for example, I can parse an XML file. I got the XML representation. Do in the other things. I can generate XML file. That is exactly one-to-one correspondence.
Okay, so that's easy to write a converter.
Yeah.
Okay. There is a question from Ulrike in the chat. Can you read it? Or do you want me to read it? Or Ulrike, you can also take your mic.
I wanted to know if ME BibTeX can start Unicode and different language rules. Did you hear me?
Badly. I'm looking about
it in the chat, Jean-Michel, if you can
yes,
access
chat,
it.
yes.
I can see you're struggling with all your windows as everyone. Huh?
Okay. Yeah, and chat. Okay. Okay. Can MLB text sort Unicode and according different language rules? Yes. That is about all European languages, some Asian languages, and printing was not popular with owner of manuscript libraries. What do you mean?
No, that's a comment. That's a discussion about the comparison between LaTeX and XML.
Yeah. I'm the owner of the Alpha Persian style in BibTeX. Can I have? Okay. So I think it's all. May I? Still other questions, preferably by conversation, because the internet connection here is bad. I'm located presently in the south of France.
Ah, you're on holidays.
Advantage, I'm quite close to the sea. Drawback, internet is not what it is anywhere else. JSON has beaten LaTeX in many situations. JSON with I mean you see JSON versus XML. I disagree because from my point of view, JSON is preferable for small size applications, but a bibliography is not a small size application. You have to manage many informations. You have to use many attributes for annotating some kind of information. In JSON, you can do that, but from my point of view, less naturally.
We still have a few minutes for questions if you want, so do not hesitate. At the beginning of your talk, you spoke about the advantages of Lua.
For me?
Yeah, at the beginning of your talk, you spoke about the advantages of Lua. Of course, it's a thing, but is it usable from MLBibTeX?
It could be usable, but from my point of view, it's not. I'm not really interesting. I explain. I recognize that a good version of a bibliographic module has been done using Lua for context, but I think that a functional programming language is better for a bibliography generation, because in a functional programming language, you can use function as arguments or results. A bibliography style is exactly the same. That is, you have data, that is resources, the specification of a book, the specification of an article in a journal, that is, you have the data, and what is abstracted is the processing, that is, function are arguments. And MLBibTeX has been written using this paradigm. So mix a functional programming language and an object-oriented language where only callbacks can simulate a function in the argument. Why not? But honestly, to be honest, that's not my priority.
It's too dirty for you. Okay, thank you very much, Jean-Michel, for your nice talk. I'm eager to see MLBibTeX and to have a look at all the work you did.
Thank you.
And now we can move on to the next speaker, I think. I can see that Nicolas is connected. Hello, Nicolas.
Hello. Hello. So I think Arthur's got my talk.
I'm ready to play it whenever you are. Would you like to say some words before I start?
Yes, I will introduce Nicolas to everyone. Probably all of you know some of the numerous packages that you wrote, like datetime, datetime2, data tools. but you have even more skills than that, as you graduated in mathematics, then did a PhD in electronic system engineering. You wrote a novel, you told me that, wrote several books for children. Of course, we heard of your books about LaTeX. And even more, you founded your own publishing house to produce your books.
Yeah.
That's really, really impressive, really a busy life. And today, from what I understood, you will present a solution to properly sort non-alphabetical symbols. So Nicola recorded a video, but I think you will stay with us to answer a question at the end.
Yes, I will. Yeah. Thank you.
Hello, I'm Nicola Talbot. I'm going to talk about Bib2GLS, specifically looking at glossary entries where the name is a symbol such as a mathematical constant or a pictograph. Bib2GLS is a command line tool that's incorporated into the document build. It's designed to work with the glossary's extra package, but you will need the record package option. Entries are defined in one or more bib files. Bib2GLS essentially selects entries according to records found in the auxiliary file in a similar way to BibTeX, and hierarchically sorts entries and collates location lists in a similar way to MakeIndex. The development of Bib2GLS was discussed in Tugboat Volume 40, Issue 1. Selections, cross-references and locations were discussed in Volume 41, Issue 3. Let's first look at a MakeIndex example using the base glossaries package. In this case, we need to use the command \makeglossaries in the preamble. This opens the indexing files and sets up the internal indexing commands. Where you want your glossary to appear in the document, you use \print_glossary. All my entries are defined in an external file called constants.tex, which I have input using \loadglsentries. In my constants.tex file, I define the entries using \new glossary entry. The first argument is the label. It's important not to use special characters in the label. UTF-8 characters should only be used with the native Unicode engines Xlink or LaTeX. The second argument is a comma-separated key-value list. In this case, each name is a symbol representing a mathematical constant. I also have an associated description. Here I've used the symbol key to store the approximate numerical value. You may prefer a different field, but this is convenient for my examples, as the tree group style will show the value in parentheses. The document build is best performed using the Make Glossaries Perl script. This involves a LaTeX run. In this case I'm using PDF LaTeX, but it could also be the DVI version, or Xlink or LaTeX. This is followed by the Make Glossaries invocation, and then another LaTeX run. If you don't have Perl installed, you can use the Lua script instead. Or you can call MakeIndex explicitly, but this is a bit fiddly as it requires remembering all the switches and you need one call per glossary. In my example, I haven't used the sort key, so the sort value is obtained from the name. MakeIndex doesn't recognize LaTeX commands such as \ensureMath or \pi. All sort values are therefore treated as literal strings. Here's my example. All four entries have the sort value obtained from the name key, but from MakeIndex's point of view, we have arrays of literal characters starting with a \, followed by a lowercase e and so on. The first 12 characters are the same in this particular example. So the order is determined by the 13th character onwards. \ comes before e, which puts the \pi and \third first. P comes before S, which puts pi before third. And backslash comes before closing curly brace. So the final order is pi root 2 e to the pi e. The first character of all the sort values is a symbol, the backslash, so they are all placed in the symbols group. Here's the final document. If I switch to using Xindi, I need to add the Xindi package option. The document build is the same if I'm using the Make Glossaries Perl script. Alternatively, I can call Xindi explicitly, but that's again quite fiddly as there are a lot of switches to remember, and again you need a Xindi call per glossary. Let's look at how Xindi orders these 4 entries. Again, we have the sort value obtained from the name key, as the sort key wasn't explicitly set. Xindi strips commands and braces, so in the first case we end up with an empty value. For the root 2, we end up with just the digit 2. And for the final 2 entries, we end up with just the letter E for both cases. Xindi forbids empty sort values, so the first entry will cause an error. Xindi merges entries that have duplicate sort values. This means that this example won't work with Xindi as it is. The recommendation is that if you use make index or Xindi and the name value contains commands, then you should use the sort key. In this example, I have set the sort key to pi. The reverse advice applies if you are using bib2gls. Typically, you should not set the sort field in the bib file. Instead, either make use of the different entry types and their fallbacks, or use field aliasing or the sort field resource option. The text parser library that is incorporated into bib2gls can be used to interpret common commands. This provides a flexible system that allows bib files to be shared across multiple documents that have different sorting requirements. I need to make some modifications to my document to make it work with bib2gls. The first thing I need to do is to replace the base glossaries package with the glossaries -extra package. This internally loads the base glossaries package and modifies and extends the base commands. You may notice some differences when you switch to glossaries extra, particularly if you have abbreviations. You will also need the record package option if you want to use bib2gls. Instead of \make glossaries and \load gls entries, you need to use \gls xdr load resources, which for simplicity I'm going to refer to as the resource command. In the optional argument, I can specify one or more bib files. If this argument is omitted, the bib file is assumed to have the same base name as the job name. I have also switched off the locations as they're not relevant for the examples. The other change I have had to make is to replace \print glossary with \print unsrt glossary to display the glossary. I now have to create a file called constants.bib, which bears a similarity to constants.tech. But the first thing to notice is that I replace \new glossary entry with @entry. The bib format requires the label first, followed by a comma, and then the key equal value list of fields. These are the same as the text file, but remember that the values must be delimited in the bib file, whereas in some cases they can be omitted in \new glossary entry. bib2gls comes with a tool that can convert a text file to a bib file. The document build is fairly similar, but instead of using make glossaries, I use bib2gls. You may prefer to use the verbose switch, which will provide additional information in the transcript file, such as the results from using the text parser library. If you want to have letter groups, then you need to use the group switch. This isn't on by default because there are plenty of glossaries that don't require grouping. Bib2GLS has a concept of fallbacks. A fallback is used when Bib2GLS requires a value from a field that hasn't been set. If the field has been set, then the fallback isn't required. The Bib2GLS fallback isn't necessarily the same as the default value used when a key hasn't been supplied to /new glossary entry or /new abbreviation, but quite often it is. The designated fallback for a particular field varies according to the entry type. For example, if Bib2GLS tries to look up the value of the sort field, but that field hasn't been set, then Bib2GLS will try the sort fallback instead. In the case of @entry or @index, the sort fallback is the value of the name field. For @abbreviation and @acronym, the sort fallback is the short field. For @symbol and @number, the sort fallback is the label. If the sort field is set, then there's no need to use the fallback. Let's consider constants.bib file, which uses @entry. The sort value needs to be obtained from the sort field, but that field hasn't been set. So the fallback is used, which for @entry is the value of the name field. This gives us the same sort values that we originally had in the first make index example. These values all contain a /, which means that Bib2GLS will use the text parser library. This will ignore unrecognized commands, but known symbol commands will be converted to the nearest Unicode equivalent. So in the case of pi, we will end up with a mathematical italic small pi. In the case of e, we end up with just the basic Latin small e. With √2, we end up with a square root symbol followed by the digit 2. Fonts and similar markup are stripped, so the superscript marking is lost. This means the final entry ends up with the sort value consisting of basic Latin small e followed by mathematical italic small pi. There are some cases where the text parser library will use a character from the Unicode subscript and superscript block, but that doesn't happen in this example. The sort method determines the actual ordering. In this case, where we are only dealing with symbols, non-locale letter or letter number sort methods are best, as the locale alphabetical sort methods strip certain characters, since they are designed for words or phrases. In this example, I have used the letter -no case sort method, which is a case-sensitive Unicode ordering. So the final order is e to the pi, √2, pi. Here's the document. The keen-eyed may notice that there's no final full stop after the description. This can be added back with the post-dot package option. There's no group title, even though the tree group style has been used. This is because Bib2GLS was invoked with the default no group setting. What happens if I instead invoke Bib2GLS with the group switch? The build process fails on that final LaTeX run with an error from the input-enc package. It's complaining about the Unicode character mathematical italic small pi, which isn't available for this document. The reason why LaTeX has encountered this character is because Bib2GLS recognizes it as a letter which it uses as the group title. We can get the document build to work by switching to Xlink or Lua LaTeX and using a font that supports this character. In this case, I've used Xlink with Deja Vu Math Tech Jar, and I can say thank you starts with a character that's not a letter. And finally, we have the pi letter group that has the entry where the final sort value starts with the mathematical italic pi. We can force all the entries into a specific group using the group option. The value of this option must be a label. In this case, I've used GLS symbols, which is a predefined group label provided by the base glossaries package and used internally by both MakeIndex and Xindi. So I can now switch back to PDF LaTeX. This is the result. There is now a single group in the glossary that has the title Symbols, because that is the title associated with the GLS Symbols group label. It's language sensitive, so if you switch the document language, you will get a translated version provided that the language is supported. Now let's try replacing @entry with @number in my bib file, since that's semantically a better entry type for mathematical constants. @number and @symbol entries fall back on the label, not the name field, if the sort field is missing. So the sort values are now the labels pi, e, root2 and Gelfons cons. As mentioned before, labels shouldn't contain UTF-8 characters with PDF LaTeX, but may with Xlink or Lua LaTeX. So you may in this case prefer to use a locale alphabetical sort method. In this case, I've switched to using the English alphabet. This is the result now if I invoke bib2GLS with the group switch. There are now 4 letter groups, E, G, P and R, each with a single entry where the first character of the sort value corresponds to the group title. I can specify a different field to use for the sort value. For example, I could use the symbol field, which I have used to store the approximate numerical value. So instead of looking up the value of the sort field, bib2GLS will now look up the value of the symbol field in order to determine the value used for sorting. If the given field isn't set, it's the fallback for that field, not for the sort field, that is used. In this case, none of the entry types have a fallback for the symbol field, so the sort value will end up as empty if the symbol field hasn't been set. Since all my symbol fields contain numeric values, it's more appropriate to use a numeric sort method. In this case, I've used sort equals double, which uses a double precision decimal comparator. Numeric sort methods always assign entries to the GLS numbers group, provided the group switch is used, but again you can override this with the group resource option. So now I have a glossary where all constants are ordered according to their approximate value, and they are all placed in the numbers group. As with GLS symbols, the GLS numbers group label is predefined by the base glossaries package and is language sensitive. But group titles can also be changed. The method used with the base glossaries package is to redefine the command where the control sequence name is obtained from the group label followed by group name. But the glossaries extra package provides a group title command where the first argument is the group label and the second argument is the title. But remember that if you are using a language package such as Babel, this may need to go in a language hook. I'm now going to add a second bib file to my example document. This file is called pictographs.bib and contains entries where the name is a pictograph. That is a symbol that's a little picture or icon. In this case, I've used @symbol as it's the most appropriate entry type. Multiple bib files can be specified as a comma-separated list in the value of the src resource option. Remember that if an option value contains a comma, then you must use grouping. The same sort method is applied to all entries within the same resource set. Here's my modified document. I've had to add the package marvosim, since I now have entries that use commands defined in that package. I also need to add pictographs to the list of bib files. Note that I've removed the sort-field option and switched the sort method back to letter-no case. Again, I haven't set the sort field for any of the entries in the new bib file. As I mentioned earlier, the fallback for the missing sort field is the label for both @symbol and @number. So the final order is the case-sensitive letter order of the labels: club suit, diamond suit, email, envelope, Gelfonscons, heart suit, landline, phone, pie, route to, spade suit. I haven't used the group switch, so there's no grouping. The resulting glossary is a bit of a mixture, and the order isn't particularly intuitive to the reader. For example, telephone comes between heart and mobile phone. It's possible to change the sort field fallback used for particular types of entries. There are resource options associated with particular classifications of entry types. For example, both @symbol and @number have their sort field fallback determined by the resource option symbol-sort-fallback. This is a far more flexible way of changing the sort value that won't affect other types of entries. In this example, I've changed the fallback to the name field. This means I once again have sort values that contain LaTeX commands, so the text parser library is used. The current version doesn't recognize marvosim commands, although it's possible support may be added later. Unknown commands are ignored, so the marvosim commands will expand to nothing when the sort value is pre-processed. But BibToGLS doesn't mind empty sort values. However, it's important to remember that fallbacks are only used if the required field isn't set, not if the value ends up empty after pre-processing. Duplicate sort values are ordered relative to each other according to the identical-sort-action option. The default is a non-locale case-sensitive letter ordering of the entry label. Since labels must be unique, this ensures an exact final order. Here are my constants and pictographs, where the sort value has been obtained by falling back on the name field. The constants are all as they were in the earlier example. The card suit commands are all recognized by the text parser library and have been replaced by the most appropriate Unicode characters. The marvosim entries have all ended up with empty sort values. The letter-no case sort method puts empty sort values at the start. Other methods may treat empty values differently. For example, the numerical sort methods treat an empty value as 0. So email, envelope, phone and landline will all go at the start of the list, but their relative order is determined by the label, so we end up with email, envelope, landline, phone. This is how the document ends up, with email, letter, telephone and mobile phone right at the start, followed by 3 of the constants, the card suits, and finally the mathematical italic small pi, which has the highest Unicode value. The symbol-sort-fallback option governs both @symbol and @number, since they belong to the same class of entry used to represent symbols. But what if I want to separate my examples out so that I have the pictographs ordered by the description and constants ordered by their name? I can still use simple -sort -fallback for @ symbol, but I can override this setting for @ number with the custom -sort -fallbacks resource option. This option takes a key value list where the key part is the entry type without the leading @ symbol, and the value part is the field to use as a sort field fallback. So here I have used number equals name to indicate that @ number entries should fall back on the name field. Since descriptions contains words or phrases, the non-locale case-sensitive letter sort is no longer appropriate, so I'm going to use the English alphabet sort method instead. Now my pictographs are ordered by their description, but the constants are ordered by their name. It might look better to have the pictographs ordered by their descriptions in one group and the constants ordered numerically by their approximate value in another. This can be achieved by using multiple resource commands. The entries will all be placed in the same glossary, but the glossary will be split up into groups, each group corresponding to each resource command. I've used the group option to assign the group label for that particular resource set. The groups will be in the same order as the resource commands. Remember that bib2gls needs to be invoked with the group switch. Now I have a glossary split up into a symbols group and a numbers group, where the symbols are ordered by description and the numbers are ordered numerically according to their approximate value. There are other approaches. For example, you could use separate glossaries, or you could use hierarchical entries, which would require defining parent entries. There are some additional examples that can be found in the Dickymore Books Gallery at dickymore-books.com/gallery.
Thank you for this very interesting and detailed tutorial. Does anyone ask questions?
Yeah, I've got a question. If I was writing it in Python, which is a language I'm used to, I'd expect the whole process to have two parameters. One is a function that from an entry computes the corresponding sort key. And then the other would be a function that from an entry computes the corresponding rendering, which might be LaTeX. So the package itself, the management tool, could be customized by providing sort key and rendering. Now, if you focus on the sort key, all the various things that you put on the command line are different ways of specifying what the sort key is. Oh, by the way, the result of the sort key should possibly be passed to the rendering function along with the entry, which would allow grouping to take place. Now, I'm just wondering why this architecture, which seems to me obvious from a point of view of a Python programmer, isn't adopted in the world that you're working in.
Or no, I mean, bib2gls doesn't know how things are going to be rendered, because some things can be rendered in a fairly complicated manner. Not everything, not every sort of pictograph has something that's intuitively in a sort of alphabetical sense. It is actually possible to define your own custom command that you can put in your bib file that only bib2jls sees. So bib2jls can obtain a different sort value. So one example would be if you have entries where you want to sort, where the entry starts with an article such as the or a. So for example, let's say your bib entry is book titles. So one of them could be The Lord of the Ring or The Hobbit, let's say The Hobbit. You might want that to be sorted under H, but you would actually want it to appear in the list as The Hobbit rather than Hobbit the. So what you could do is create a command that takes two arguments, the article and the rest of it. And you can present BibTeX with a definition of the command that puts the article last. But LaTeX will see a different version of the command where the article comes first. So you can do it that way.
I think we might be looking at things in slightly different ways. What I'm thinking is that instead of having lots of options to the big function, you have a sort function, and that might have lots of options.
Oh.
And that's important because if you're able to pass the function, you're, so to speak, making the API as simple as possible as far as the thing that you're writing. And I think it's coming down to some sort of architectural forces and habits. But let me take a different view of this, which is that in an online setting, think of shopping. So I might say, I'm interested in potatoes and I want the key to be the price and I want the cheapest first. And there it's clear that the user is actually creating its own key, a custom key. When you do that, you're creating a custom function that determines what the key should be. And it seems that your approach and the widespread approach is to add another field to the data.
Well, in this case, you're not particularly adding another field because you're not setting the sort field. You're trying to determine the most appropriate sort value from all the fields that are actually present that will need to be there in order to typeset the document. But I think it's also important to remember that a lot of LaTeX users aren't actually programmers, so they're not really used to the idea of creating functions in order to sort things. So I did try and go with a sort of more intuitive option list for non-programmers, sort of the sort of average LaTeX user. I hope I've managed that, but it's always difficult to tell what the average user of any software is.
I'd like to thank you for your talk. I'd like to thank you for your talk, Nicola. I found it very interesting.
Thank you.
Frank has a question.
Yeah, quick question on a technical side. Very early on, you said something like, not sure exactly, I think on the label, that you cannot use UTF-8 characters if you're running with PDF tech. Is that because you're putting those at some point in your code into CS names? Because since, I don't know, 1 or 2 releases back, PDF text should behave pretty if you do this. For example, these days you can put UTF-8 characters into reference label and ref commands without any problem. So my guess is this would work with your code as well, if that's the reason.
It might do now. I haven't really investigated since the LaTeX kernel changed. I do know that beforehand, and I suppose there are a lot of people who are still using old versions of LaTeX.
I just wanted to point that out, that this is nowadays a possibility.
Yeah, it's something I've been meaning to sort of investigate to see if it does work or not. So I always sort of fall back on saying that, because that's all I used to have to say in the past.
I know it takes a couple of years to get used to, but I mean, on labels, it was so many people wanted to have sort of their language being represented in labels, so we tried hard to make that possible, and I think that is exactly the same problem you have there. And so it should work nowadays.
The only thing I think to be careful is special characters, so like putting a tilde in or something, or a hash or something like that. I think that I would.
Yeah, those, if it is syntax character, it will still be a problem, but normal UTF-8 should work, I would assume.
I'll give it a try. I mean, obviously special characters will be a problem for Z-LaTeX and Lua LaTeX as well. But yes, that's a very good point to bring up. And I will investigate that.
Okay.
Thank you.
Are there other questions? I'm really impressed about the flexibility of Bib2GLS and the way you sort things. But is it usual to have, in, for example, mathematical books, to have a lot of symbols in the index?
I don't know. There are some where you can have basically a huge list of tables of functions, sort of like an enormous compendium. So I suppose that might do. But to be honest, I don't really use that very much these days. I don't really do too many typesetting of mathematical documents anymore.
I'm asking because as a naive reader, I expect an index to help me find things, and having an index with symbol, when I can have a look at all the symbols at a glance, that's okay. But if it's on 2 or 3 or 7 pages, it's useless.
Yeah, but the other thing I was sort of thinking about in terms of the pictographs is if, for example, you have a map with symbols on it, you might want to have a key. So you could use it for that as well. Sort of, it's quite flexible.
It's very flexible, yes.
Can I show you a couple of maths books? This one is notation, and there's a lot of it. Sorry.
Stay like that for a few seconds so people can zoom on your screen.
It's 2 pages, 2 columns. A lot of notation. And I think this is another book.
Could you show it again, Jonathan? So people can zoom on your screen while you're holding the book.
Oh, sorry, I've only got one pair of hands.
Yes.
I've no idea what the sort order is. Fortunately, I'll just go up a bit. Fortunately, it only spans 2 pages.
That's already a lot. Huh?
It's already a lot. I'm glad that I'm sighted rather than blind, because if I was blind, I'd find it really quite difficult. And it gives page references, presumably to the area, and it breaks it into 2 groups: algebraic geometry and intersection theory. And here's the book if you want. It's the Bible of the subject.
Yeah, well, if you want to have the back references, the location numbers, then you can do that. I switched them off for all the examples because all the examples would have just had page 1 as the location, but it is possible.
Yeah, I was just sort of showing how it's used in practice.
Yeah.
I've also seen papers that have an index of notation at the beginning.
Yeah, I think my PhD thesis had one as well, but that was just used. I think that was back with the old LaTeX 209, so I think that was just a tabular environment or something like that. That was a long time ago.
My PhD was typed up by technical typists on IBM golf ball typewriters, so any mathematical symbol was a great luxury. Thank you again for your talk.
Thank you.
We still have a few minutes for comments or questions for Nicolas. Okay, if no question, we have a very short break of 5 minutes. Nicolas, thank you for your tutorial. I will look at your work and try it. I will also try to sort colors, for example.
That's great, thank you.
Okay, so 4-minute break. Hello, Enrique.
Hello.
How are you?
I'm fine.
can see your slide, we can hear you.
Yes. Can you hear me?
Yes, perfectly.
Okay.
Actually, you're very loud. Maybe you're a bit too close to the microphone.
Okay, better now?
Yeah, good.
If you have a webcam, you can show us your face. That's always more friendly.
Yes, sure. Let's see where I.
Yes,
there I am.
Hello.
Hello.
So I'm very pleased to welcome Heinrich Stammer-Johans. I hope I've not butchered
Yes.
his name. So Heinrich Stammer-Johans from Germany. He did a PhD in physics at Oldenburg University. He taught computer science in Bremen. And now, if I understood well, you're a software developer.
Yes.
You worked on the ArchiveML project. You will tell a few words about it, but that's not the main focus of your talk. You will mostly speak about TechML bus that is supported by Overleaf. I will paste the URL of your GitHub repository in the chat, and now we can listen to you.
Okay. Thank you. Okay, now you should see my screen, I think. And yes, so I'll talk about TechML bus, which is a build system for tech. So first, I will shortly talk about LaTeX and XML, and then I'll demonstrate quickly the build system. So why do we need XML anyway? Because LaTeX is the format to write math, and millions of publications have already been written in LaTeX. And as we all know, it's still the best way to produce high quality math. But there are some drawbacks with LaTeX. It mixes form and content. There are no real semantics with it. And something that we have faced in our ArchiveML project, which I will shortly talk about, style files change over time, and that is a problem. There is no formal validation for LaTeX, and if you want to recompile all these maths in 30, 50 years, it is not really clear whether this will still work. So on the other hand, there is XML. XML is, of course, something you do not want to directly edit, as you can do it with LaTeX. But there are some advantages. Such a document can be validated, so it can be used as a possible archive format. And one format is, for example, JATS, the Journal Article Text Suite. There are some other dialects of XML, MathML, for example, or XHTML. And with these dialects, you are able to directly render documents in a web browser, for example. And for searching and indexing tools, and as we have seen for screen readers, it is a lot easier to work with XML instead of LaTeX source code or PDF, for example. So some years ago, we did this ArchiveML build system. at the Jacobs University Bremen. There we try to convert documents from the archive preprint server into XML, and we used LaTeX ML to create XML with that. And for that, we needed some kind of build system to do mass conversions into XHTML. At that time, we converted approximately 500,000 documents. And the reason to do this was to have some real-world MathML documents. And another reason was to improve LaTeX ML, which was under development and is still under development. LaTeX ML is some software which is written by Bruce Miller and Dejan Djinev. And Dejan Djinev also has the successor of the Archive ML build system. It's named Cortex. That system is being used to do mass conversion to XHTML. So the system we have written at that time at Jacobs University was written in PHP. It used SQL database to store some state and distributes jobs on several hosts. You also need to set timeouts for each host or for each job, because there are possibilities where some conversion jobs can run indefinitely. So what the build system then does is it checks the files that have been created. It parses the result files, for example, stdr.log, and then it tries to classify results and stores information in the database. So what I'm talking about now is TechML bus, which is based on Archive ML, but TechML bus changed the focus a little bit. This Archive ML tool was free software, but it was like not really easy to install on any other machine. And you had to have some knowledge to actually work with it. So one of the changed focuses is to ease installation, to provide more interactivity, and also to be able to produce other formats than just XHTML. One possibility to produce other XML text, but actually to support any other format which you can run through a converter using LaTeX as a source code. And you should also be able to create the same target, for example, PDF, using different systems. So you could use an older TechLive, like TechLive 2019 against TechLive 2021 or something. So to ease installation, I switched to Docker images, which allows to install this on any main machine like Apple's, Unix, or Windows. More interactivity. First, it was run just by some commands. So now it should be possible to upload files via a browser or import files directly from Overleaf, or just provide a directory and scan all the files in that directory. And it should be possible to schedule conversion jobs via browser, for example. So other targets than XHTML, that was a little bit more complicated because now it was needed to have result tables and store a lot of more state for each possible target. and then create same target using different systems. For this, I introduced stages, and that is actually a target combined with a specific image that is being used. Image is in the term from Docker, so you could see this like as a system. So a target that is combined with a specific system that is called a stage on TechML bus. And for this, you need to have subdirectories for each stage. This was implemented by using hard links, so you do not need to copy all the data again and again, but by using hard links on the directory, you kind of create copies, but you do not need space or additional space for this. So this is a simple overview of the system. It consists of several different parts. On one hand, you have the document files, which is just basically a big directory with subdirectories for specific sets or for specific articles. Each article needs its own subdirectory, and these files are shared among the build manager that I will talk about a little bit later on, and the converters that are being used. Then there is the SQL database, which stores state. So it can also create statistics about everything. And then there is the interactive usage via browser. So typical things, you can add and remove documents, you can queue conversion jobs, and you can manage document files. So provide style files and things like that. So then there's a build manager, which operates on the work queue, and this build manager schedules then make jobs on so-called worker containers. The worker containers are the like systems that do the actual conversion of files. And later on, this build manager analyzes log files that have been created. And then we have worker containers. These containers are like a full system that run some specific converter. So typically, as we use LaTeX ML, we call LaTeX ML and LaTeX ML post to do conversion commands, but we can actually add any other converter that should be used for this conversion. So what happens in this system, the typical way is you add documents to the system, you queue a conversion job, and then these documents are added to the database, not full documents, but rather like metadata about the documents. Like, where is it located? When was it added, and stuff like that. So the build manager then reads this work queue and queues conversions then, and invokes, for example, make, because we're using make files to do the actual conversions. And then on these worker containers, LaTeX ML, for example, is being called. The conversion takes place, creates result files and log files. So result documents are being created. And then this build manager reads these log files and tries to analyze the result. for normal makefiles, this is just like success or failure, and we have different steps in between. So we could like create the document, but there might have been problems in the conversion. And so these log files are analyzed, and common errors are like parsed and found and put into the database. So a possibility is to like that there are missing macros, and this can be analyzed and stored there as well. So to put this or to convert the whole system into a Docker system, you can analyze what is responsible for what. So we have like a MySQL database, a web server running with PHP and converters. So you actually need to have 3 Docker containers and a shared volume. And if you're interested in Docker, this looks like this. Then you have Docker Compose, which coordinates all these containers. There's a MySQL database, the build system, and one or several workers which do the actual conversion. And they all use the shared volume where the articles are located. So now I just give like a simple introduction into the build system, how it looks like in the browser. On one hand, you have an overview over the statistics, or you can see, can you see my mouse button?
Yes, we can see it.
Yeah, okay. So you can see here like different targets which I want to create, like PDF, XML, XHTML. And for each target, I can see the statistics. So in this like simple example, which is like the sample set, which can be easily created using create sample set, there are just 5 documents. And you can see if you do the conversion to XML, 4 documents are okay, 1 document has an error. And you could also like click, and you can see like the detailed return values. And so this document has a missing macro, for example, and you could click on this link and find directly the error message that that has been produced for that. So the typical things would be, first you need to get files into the system. So you can upload and import articles. You can import simple articles or typically zip files containing multiple articles, and you would just drop them here and import them into the system. You can specify a set because to make it easier, you can like organize articles to specific sets, make it more easy. Another option would be to directly import articles from Overleaf. So you could again specify a set where you want to add the article to. For Overleaf, each project has an ID. You would need to specify the numerical ID, and then you can provide an own project name for the article, because you probably would not want to use the numerical ID for that. Then you need to provide your username that you have there, and then in a pop-up, you need to provide your credentials to import articles. So here's like one simple article. This is actually the presentation that I have done. There are some missing macros when I use the tugboat style file, and I could change my article using Overleaf, and I could update this article again and export this again into XHTML, for example. Here you can have like an alphabetic overview over all these articles. You can see here on the left, I have several sets, an overall set which combines all sets together, samples, like all the samples I'm using right now to test the system. And again, I can see all the possible targets that I have right now, and can see the current state of these articles. And what is helpful with the build system is by just clicking on the links that you can see right here, I can directly get to the source code of the document. So it's probably not readable, but I hope you can identify this as, you can see this is text source code. So I can just go back, click on a link dest file, click on the XML dest file, for example, and you can see the XML document that you have just created, that has been created. Or I can click on the PDF dest file and see the PDF document, which is now a sample document. And this is how I can like quickly go through all these different things I want to see. So let's see whether I can change to this screen. And now you can see like this is like the live document, the live system now. You can see localhost. It's just several containers running on my local system. And there I can quickly get to the destination and error codes. So I do not need to use comments to get there and to see any problem. I can quickly find problems by just clicking on the documents. And this is really helpful if you have 50, 100, or 1,000 documents that you would like to convert. So let's see. So here I have some sample documents, and you can directly see the created XHTML, which is being rendered then in the browser. And you can see here that this all is actually XML code that renders the math. This is MathML, which works quite well in any typical browser right now. So Firefox, for example, directly supports MathML, and some other browsers like Google Chrome use JavaScript to actually display the documents in a browser. So what else can I show here? So yeah, here you can see the different possibilities. I could upload files, or I could scan directories for documents. I can upload class files, or I can install class files. Some typical style files that are being used can be directly imported, which are not typically available in TechLive systems. And let's see. So one other possibility is if I want to change documents and create XHTML out of this, here you can see my presentation for as it is supposed to be written. Then you can see here like the document, and you can see right here there's some missing macro right now. So one possibility is to change this document directly in Overleaf, for example. I just write hello XXX, recompile, and so it has been automatically added to Git. So if I go back here, I can update this document in my system. So this has been updated. Now I need to queue this file again for conversion. So it takes some time. And if I click on the dest file now, you can see right here, now there's the new hello XXX, for example. So it's a really easy and quick way to create new XHTML, for example. So let's go back to my talk. So I can also like collect statistics. You've seen this already in the one slides. Here you can see like general classes. So there's exception, error, success for some documents, and I can also find out about detailed return value. This can be also displayed graphically, so you can have an overview how some document collection is actually doing if you do conversions. And these errors typically happen because LaTeX ML also needs to have like some semantics. You need to have special LaTeX ML binding files to do the conversion to XHTML. And it is always possible that some style files that are being used are not fully supported. And therefore it happens that you get errors there. So the TechML bus system allows you to convert documents, and you can gather statistics about the conversion. And it is really helpful if you want to do, if you do comparisons, for example, between some older system and newer system, because you can then easily detect regressions with real world documents. And these stages that are being used allow you to have the same targets using different systems. You can, in this example, I've not demonstrated this, but you could have like 2 PDF stages, for example, where one PDF normal, for example, would use TechLive 2019, and PDF Edge or something would use TechLive 2021. And you can also run hundreds, thousands of documents and gather statistics how well this is being done. For this system, we typically use LaTeX ML because it seems to be, or not, it seems it is a really good converter to XHTML, but actually you can support any converter. What you need to do is you need to have some Docker container which understands some comments that you can send to. Currently, this is all being done via some HTTP API. And you also need to write a simple analyzer that analyzes the log files, which is not too difficult. And then you can plug in actually any converter that you would like to use. Yeah, I have some time, so I can talk about like this one example you might have seen here. Here you can see there's one stage called page limit. There was an article like 1 year ago about people trying to sneak some page limits if they submit papers to journals. And some typical comments have been identified that are being used to do that. And so this page limit stage is actually a just simple stage that looks for these comments and then tries to find out whether some circumvention comments have been used or not. Okay, so yeah, any converter is can be used. So what needs to be done currently? Converters should be added more easily. It used to be like that you could just use any container, and what needed to be done was to be able to SSH into the container and run some command. But I took this, I changed this because you always need to have some private keys for that, which is actually not a real problem because you have just limited access to these containers. But typical automatic parsers that parse such Docker containers, they always give some warnings. So I have switched completely to HTTP to externally run these containers. So this needs to be added if there's like some container that can be used for conversion. And what also needs to be done is to help to improve LaTeX ML, to have sooner or later full coverage of all LaTeX comments and style files. Yes, that's it.
Thank you a lot, Enrico. That's really conversion at an industrial scale. Huh? That's impressive. Huh? Are there questions? Huh? You can raise your hand or put a comment in the chat. Huh? To start, I have a naive question. Did you detect some unexpected bottlenecks when you compiled or converted 500,000 of documents? Sometime when you start such a big computation, you detect that the file systems are not add a bottleneck to the process, for example, or the network. Or
when we did this conversion with 500,000 documents, that was actually like a bigger machine. I think at that time it had 16 CPUs. So that was not a problem. The bottleneck or the biggest bottleneck was time. So LaTeX is not like a super fast converter. So to convert that many documents just needs some time to do the conversion.
Okay, it was mostly CPU power and no other resources.
No, like
okay.
At that, like for that system, we had like one bigger machine, but we actually also used some other hosts where we shared the file system via NFS, and that was also not a problem at all. It's not typically a problem.
Okay.
And now all this, like this system right now hasn't been used for 500,000 documents or so, but currently it just, or you can, like if you use Docker Compose, you can only use your local machine. But if you have like several processors, you can easily start several converters, and that runs well.
Okay. I have another question. In your process, you're carefully checking for conversion errors, but errors that are signaled by the converter. When you convert things, do you also do you have another process checking the results that the result is consistent?
Yes. What happens is they share the file system. So the file system is also being used to do some simple signaling on the file system. So there's one file that when the conversion is finished, that file is just being touched, and the queue manager can automatically determine that some change is happening on that file.
Okay.
It's like a file system event that you can use for that. So watch that single file, and you can see the queue manager knows then, okay, something happened, and then the queue manager actually parses the log files. So the converters just do conversions, nothing else.
Okay.
Thank you very much for your talk, Heinrich. I found it very interesting. I learned a lot about cloud computing, which is new to me in concrete terms, and also about how Overleaf fits into the tech community and the tech ecosystem. The thing that strikes me is that your focus in some sense is not on doing things in the cloud necessarily, but on being reproducible. And what excites me about what you've done is that Don Knuth's ambition and success was to get identical outputs from identical inputs across space and across time. And the big problem we have is ensuring that things are identical, and the controlled environment provided by containers seems to be really, really good for that. So what's going through my mind is rather than sending the results of computations, we can send the thing to be computed. And that means we don't have to send large amounts of data about, we just have to send a formula. And the formula is the text source plus the secure hash for the environment in which it's run. And I wonder how well that fits in with your thinking and ambitions, if I've been clear enough to explain it.
So you mean the result document would be like the hash, like a hash of the result document to compare?
Yeah, rather than saying, here's this big PDF, you say, here's this small document, And when you typeset it, you should get this hash.
But what I don't really understand what would be the use for that. You can you could if you just want to know whether the result of one conversion is different to the other, you can of course convert. You can of course compare these hashes to find out that they are different. But in this system, you also want to find out where are the problems. So where are the error messages? So what is actually also being done in the system is that each error message is being like classified and added up. So you can, for example, convert 100,000 documents, and then you automatically find out about the top fatal errors. So if you, for example, change something in a newer tech version, and you convert these 100,000 documents with a newer tech version, you might find out, okay, now 1,000 of these documents have this particular PGF ABC problem, which seems to be unknown right now. I don't know. And you can easily find out where the problems are if you switch from one version to another version, for example. And a hash would not be helpful for this.
The hash would be very helpful for telling you that there is a problem. It won't tell you what the problem is.
Yes.
And so if all I wanted to do was to check that my compilation of the document is the same as the author's compilation of the document,
then you can just use a hash, yes.
Yeah, and if there was a problem, then I could get from the author or elsewhere, presumably via a hash, a formula for constructing the document. And then I can have another go. Yeah, I think you've got a very definite purpose, which is supporting thousands of users on Overleaf. I've got a slightly different purpose, which is keeping things exactly the same. But I think the tool sets are, in some senses, got a large overlap. And so I found your talk very interesting and very useful. And well done for using cloud computing.
Are there any questions? Andrea just answered a remark from Ross in the chat about the hash.
Yeah, that is of course a problem because some dates are different there. So you need to have like not a simple hash function which just hashes the file, but needs to know that this is a PDF file and there are these dates which I need to take out.
Yes, it would be a hash based on the content of the pages and not the file itself. Yes, I guess.
There's a movement afoot for reproducible computing in all sorts of places. The most recent place I saw it is what's called the Squash FS, which is a read-only file system. And ordinarily it generates the Squash FS, which is a file system image, as quickly as possible. You can, but in recent versions, its default is to always give the same output from the same input. And anything such as putting the date into the document, of course, destroys that.
Well, not in the sense that the date is an input. If you put the same data, you will have the same output.
Yeah, and part of the input is the reading of the system clock. That's That's the problem. With tech on the command line, you can say, here's the date on which it is compiled. You can set the time variable in tech on the command line, and that's a way of getting reproducible outputs. That's a straightforward conflict between two needs. The one is reproducible computing, and the other is you want the document to say when it was made.
Okay, so thank you again, Henrik, for your really nice work and the clear explanation you gave about it. I hope you will stay around if there are some more questions, but for now we will have to move on to the next speaker, Michal.
Hello.
Hi, Michal.
Hi. Can you see me? Hear me?
Yes, I can see you. I can hear you.
Okay.
And Arthur is doing a wonderful work in the back office to put the videos and everything. So.
Yeah, thank you, Arthur. Okay, so
this is the last talk of the session before the break. It will be given by Michal Ovtir from Czech Republic, who is the current developer of Tech4HT. In life, Michal works at the library of Charles University in Prague, where basically you told me you apply LaTeX to everything you can, from publication list to book labels, posters and everything, so that's nice. In addition to Tech4HT, you wrote several other packages, and the good thing is that you are really active on Stack Exchange, so people can contact you on Stack Exchange if they met problems with your packages. And now I think we can listen to you about Tech4HT.
Yeah, this chart. Yeah, I think I will make a quick introduction and then we can start the video.
Sure.
So Tech4HT is LaTeX to HTML and XML converter. It's based on direct conversion from LaTeX. It's used tech for the conversion, so it supports all commands and packages, but it has a catch because in order to insert XML commands, it needs to redefine a lot of internal commands of LaTeX and packages. So sometimes it can clash. So in my talk, I will show some common issues. I will show how to modify output, because the Tech4HT is highly configurable, so you can configure almost everything. And I will also show how to fix some basic clashes caused by some package options or by package clashes. I will post links to the chat because you will not see them in the video. So watch the chat for the links. I will post links to a new Tech4HT documentation, which is work in progress, but it already contains some useful information. And now I think we can start my video. This chart describes basic Tech4HT workflow. First of all, we need to compile our tech file using tech engine. It could be PDF tech, LuaTeX, or ZTech. The important thing is to compile it to the DVI format, which can be then processed by the Tech4HT command. This command can extract HTML files and prepare some special files for the next step that creates CSS files and images. Usually, we use some helper scripts to run this workflow, but in this example, I will show you how to run Tech4HT directly. As you can see, we use package Tech4HT in this example, and it will load all the necessary commands that will produce HTML file. Now I can compile this file to DVI using LaTeX. As you can see from the log file, it throws a lot of files that have 4HT extension. We need to convert this DVI file to HTML using Tech4HT. This was really fast. To get CSS file, we need to run the last command, which is T4HT. And now we can show the resulting HTML file. So you can see that direct font commands works. So we have a large bold hello world. We have diacritics. When we see the source code, things are not so nice because accented characters are presented as HTML entities, and you can see that these entities are broken into several elements, which is not really nice. To get HTML file document in Unicode charset, we need to pass some options to Tech4HT package. This is the basic form how these options should look. On the first position, you should always use XHTML. HTML file is for HTML support and charset UTF-8 character set in the HTML document. We can convert it to DVI file again, and we need to pass some options to Tech4HT command in order to support Unicode. So this command and again T4HT again without any options. You can see the resulting document. It looks the same, but it looks differently in the source code. So you can see that we are now in HTML format, and that characters looks much better, and this word is not broken into several parts. There are two main issues with this manual workflow that I just showed you. First of all, we don't want to add Tech4HT package to the document because it will break the completion to the PDF format, and second is that it is really tedious. So we have some helper scripts that will make our life easier. In this example, I removed the Tech4HT package, and we can now compile it directly using HTLatex script. It was fast, and as you can see from the source code, it creates the same result as the first example. If we want to create HTML file in the Unicode encoding, we need to pass options to Tech4HT. We can pass the same options that we passed in the second example. We need to also pass options to Tech4HT commands, and this can be done in the third parameter, and now it looks much better. But there are still some issues. The main issue is that HTLatex run LaTeX 3 times, which can be really slow if you have big document, and it's not usually necessary. Tech4HT compiles document 3 times in order to support cross references and similar stuff, but it's not necessary in every occasion, so we may want to run it just once to save some time. Tech4HT supports several output file formats. The basic one is HTML that is used by default, but it supports also open document format for LibreOffice and Microsoft Word, DocBook, and some other formats. The best support is for HTML and open document because we have the most user requests for them. For example, to make file in open document format, we would need to pass a lot of options to HTLatex, and it will be really hard to use it. For this reason, we have one helper script, MK4HT, that can do the hard work for us. This is the basic form. OO-LaTeX means that we are compiling to open document format. When I wanted to add EPUB support, I found that these scripts are not really citable for this task. So I created a new tool, which is named Tech for ebook. As you can see, it behaves a little bit different than H2LaTeX. It hides the terminal output by default, but you can show it using options. It has classic options that are common for Unix scripts. So if we want to see the terminal output, we can use option A debug, and it will show the same output as H2LaTeX. One difference is when your document contains errors. We can show some basic example. Here we have one unknown command, and we can see how we'll react H2LaTeX and Tech for ebook. Yeah, as you can see, H2LaTeX stopped on the first error, and it will not make any output. Tech for ebook will run the compilation, but it will highlight the errors. If we run it with the debug options, it runs crazy LaTeX, so you can assume compilation, stop, which will stop the compilation as in the case of H2LaTeX. Another feature is that it can run just one LaTeX run, which is done by like mode draft options. We will use the debug option as well to show that LaTeX is run only once. For ebook supports only EPUB and Kindle formats, but when I made it, I found that it could be used also for the other formats, and so I made a new tool that is used for all the older formats like HTML or Open Document, and this tool is named Make4HT. It supports the same options as Tech for ebook. To select a different format, we can use the F option. So for example, if I want to make Open Document format, I can use the FODT option. And here we are. Make4HT supports a lot of other options, as you can see from the help option. I already showed you the A option and mode options. Other useful options are L, that will use LaTeX for the compilation, or X for ZTeX. We want to compile our document using LaTeX. We can just use L option. Yeah, we use LaTeX in this compilation. One important distinction from H2LaTeX command is that Make4HT uses HTML5 and Unicode support by default. So this is HTML5, and you can see that we have Unicode characters, and also that this word that used to be broken over several elements is now connected into one word. This is enabled by the Make4HT extension support, because Make4HT post-process the HTML files by default. It uses LoXML library to fix some common errors, such as this one with broken characters. If we want to disable this post-processing, we need to disable it on the command line. Extensions can be enabled or disabled using the F option. We can use HTML5-, which will disable the command DOM filters extension that is used by default, and it will make similar document to our Unicode H2 example. As you see, the characters are broken again. Make4HT supports several extensions, as you can see from the documentation. I already showed you the command DOM filters, which are used by default, but there are other interesting extensions. First of them is preprocess input, because it enables Make4HT to process Markdown documents or R documents. I created an example for RTech. This document mixes R code and tech code, and we can compile it using the process input extension. We can pass options to Make4HT like to H3tech. There is a difference that we don't need to pass XHTML as the first option. We can just use options that we want. SVG means that we will use SVG graphics for the generated pictures. But now we can just run our example. This is the resulting document. Another Make4HT feature that I want to show you is the build file support. We use the iMakeIDX package and we create two indexes. One is main and the other is secondary. The build file is written in raw, and the mode variable contains the mode option of Make4HT. So if we want to support the fast compilation, we need to support it in the build file. So if we use the draft mode, we just run one htLatex, which is one LaTeX run. But when we want to produce the index, we need to run LaTeX first to produce the necessary IDX files. Then xindex, which runs the xindex command. It supports the split index syntax, so we can use just one xindex and it will create both the main index and the secondary index. Because the indexing commands produce hyperlinks, we need to run htLatex 2 times in order to make the hyperlinks work. So the build files can be requested using the E option. So we can run it now. This is the resulting HTML file, and in the below we have our main and secondary index. Click on the index numbers, it will take you to the index position. We do most of Make4HT features, and now it's the time to switch to Tech4HT Tech configuration. In this example, I have a document that creates several sections, and I will show you how to change the document look and structure. Compile this document using just Make4HT without any options. It will look like this. This is just really basic page, and as you can see, the document, the footnote creates separate file, so you need to click on it to see what's in the footnote. If we have a long document, we may want to split it into split pages. It can be easily browsed. Tech4HT has a built-in option for this feature. It will look like this. Our sections are now in separate pages, so they are easier to digest. Now these sections are named by the titles, so we have first section and second section. There is still the issue with the footnote, which is on the separate page. So we may want to insert it in the page, which can be done using FN option. Now the footnote is inserted directly in the page, and it's much more useful than the default footnotes top. List of supported Tech4HT options is in the documentation. It doesn't contain all of them because there are hundreds of options, but the most important ones are here. Tech4HT produces pretty plain document by default. If you want to change the design, we need to use some CSS code. For this, we need a private configuration file. There is documentation about private configuration file, the new Tech4HT documentation, and now we can take a look at some simple examples. So this is a basic example of configuration file. There are three commands that are necessary to use in the configuration file. It's preamble, which can have some Tech4HT option as an argument. So we pass the options that we use with Make4HT, and as you can see, we need to use XHTML again. Then there is a begin document. It means that commands that you put after this command will be executed after begin document in your LaTeX file, and we need to close the configuration file using int preamble. There is another command, and it is CSS. This command is used to put short-term CSS code in your text document, so we can try it. The private configuration file can be loaded using C option. The HTML file is now narrower and it is more readable. You may want to use some more advanced CSS code, and it will be pretty tedious to use the CSS commands in the configurations files, so it's possible to link directly to the CSS files in the configurations file. I use the configuration file to link the HTML file to this downloaded CSS file. I can use the configure editor CSS command for this. The configure command is most used command in the configurations files. The configurations are declared in Tech4HT configurations files for packages, and the editor CSS configuration is used to link to internal CSS files. So we can try it now. Yeah, so now you can see that this page now looks totally different and I guess modern. You can also link to the external CSS files that are located somewhere on the web. This example uses LaTeX CSS that tries to mimic the default LaTeX look, and as you can see, you should put this line to your document head. Here is another example of configuration file. We use different configure command. The head configuration put code into the HTML head element. There are some new commands. Hcode is used to put HTML or XML elements in your document. It is necessary because otherwise these special characters will be escaped and it wouldn't work. And hnewline puts newline into the HTML file. And now this HTML page looks a bit like LaTeX document in the PDF mode. There are several places where you can find documentation for the configurations. First of all, this is the new documentation. Incrementally put documentation from the all sources, and also documentations for the new configurations that we add. But there is also a lot of information in the old documentation, especially in the configurations section. Some information is obsolete, but it is still useful. You can click on these numbers and it will show you some example usage. Another source of documentation which is not well known and it's quite hidden is produced by the info option. It puts some documentation in the log file, so you need to open the log file and there will be some information that is neither in the new documentation and in the old documentation. This one is still really useful. TouchForHT supports several ways how to output math. By default, it creates mixture of pictures and HTML documents, but it also supports MathML and MathJax. I will show you all of these methods on this sample document, and we will discuss some issues of all these methods. So the default method will create something like this. As you can see, it doesn't look really nice. The equation is output as image, as well as this square root, but some simpler elements are output as HTML. We can request all maths to be in pictures using become option. Now all math is in pictures, but as you can see there are some issues, namely that the inline math is not correctly vertically aligned and it looks really bad. But as we already know, we can use SVG option to output in SVG format and it will look a bit better. But the compression is a bit longer. Yeah, so this looks much better. We may want to make the compilation faster, and we can use one extension that is suitable for that. The DVSG meshes compares just math elements that changed from the previous compilation, and it uses multiple processors for the compilation, so it's much faster. Another option is the MathML, which looks better, but it has another issues. It is that it works correctly only in Firefox, and if we show our document in Chrome, you can see that we lost all subscripts and square root and stuff like this. For this reason, it's better to use the MathJax library to render MathML. It looks much better also in Firefox because it uses different fonts and it looks correctly even in Chrome. We can also use just MathJax for math. There is a catch that it doesn't support custom commands and the referencing. We need to provide some configuration for Majax. Configure Majax config that passes the configuration for Majax, and we need to put definition of our custom command here. We also can redefine the eqref command to output the eqref into the HTML output, and Majax will support that. So we can try this configuration file. Yeah, and as you can see, it now works correctly. Another common issue is related to images. Tech4HD doesn't have access to image dimensions, so we need to create a special file with image dimensions in order to support them correctly. This is the default output, and as you can see, the image is square, and this is not correct. We need to use ebbx command to create XBB file. It now contains the image dimensions, and now Tech4HD can correctly calculate image dimensions. Yeah, so it looks correctly now. Another common source of issues is package clashes. This one is one that I found recently, so I haven't fixed it in the sources yet, so we can try this innocently looking document, how it will compile. Yeah, you can see that it produces fatal error. In cases like this, it is best to find the package that caused Tech4HD to fall and to edit your Tech file to ignore this package, or to use different options that will not cause these issues. In general, Tech4HD tries to avoid need to edit your document, but in cases like this, it's really necessary. I found that the fatal errors is caused by PDF Tech option for graphics package, so we can use the if-defined hcode. Hcode is command defined by Tech4HD, and it's not used by default in LaTeX. We can use it to detect if Tech4HD is active, and if it is, we can use graphics package without any options, and else we can use the PDF Tech option. You can see how it will work, and it compiles without errors. So this was my last example. If you have any questions and suggestions, you can contact us at Tech4HD mailing list. We have also issue tracker where you can submit bugs, or if you use text exchange, you can ask questions with Tech4HD tag, and I will find it and I will try to answer it. Thank you for watching, and see you.
Thank you so much, Michal, for this very rich tutorial.
Yeah, thanks. It was a bit fast because I made it too long, so I had to cut it down, and maybe I was a bit too aggressive, but
it was faster, but we will have the video afterwards, so we can replay it and try your examples. So
yes, I will put my examples on my GitHub, so it will be possible to run them also for other people.
Okay, I can see that Boris has a question.
First, it's absolutely great work. I have been using Tech4HD for a long time, and what you are doing is absolutely heroic. It's great. I have two questions. First, the documentation you cite a little bit balkanized. It's somewhere here, somewhere there. Are you going to put everything on C10, so we can just say TechDoc something and get your documentation? And my second, and my second question is about tables. To get accessible HTML, I need to put some information about tables. Where is the heading? Where is the normal cell? Is it possible for Tech4HT? Whether you have a solution for this right now?
Mm-hmm. Yeah, for your first question, it's definitely the plan. Once I have the new documentation that I showed, once I migrate all the old information and add a new documentation, yeah, I will put it on C10 and it will be available in TextDoc. So yeah, it's definitely a plan. Yeah, the issue is that I'm really slow in the writing of the documentation, so I can't say when it will happen because I'm working on this for, I think, maybe 4 years already. So yeah, so there is no deadline, I think, or maybe I can use some help because it's the sources of the documentations are on GitHub, so everyone can migrate some bit of the old documentation to the new one. And regarding the second question, yeah, tables are quite different because because they are one of the most difficult stuff in Tech4HT sources, and there are also many packages that changes tables handling, like Taboo and Excel Taboo and all this. So yeah, it's quite hard. I think I fix some table issues using Make4HT extensions. Yeah, because I can use raw XML to post-process the HTML files. So I think this is the best thing to do. So if you have an example, you can post it to the mailing list or to my mail, and yeah, I can try to add support for your needs.
Thank you. Thank you very much. Actually, I was thinking whether to contribute some code rather than ask you to write it. And my question was rather a way to ask whether it's already written. Okay, thank you very much.
Yeah.
There is a question from Rajesh in the Q&A, and Rajesh, you can speak now.
Yeah, I can read it. I have read your answer on Stack Exchange that Tech4HT supports full Unicode using the Tech engine. It is still post-process XDVI. Yeah, there is issue with Tech4HT command, the command that post-process the DVI files, that it doesn't support OpenType fonts. When it finds OpenType font in the DVI file, it will fail with fatal errors. So we actually need to suppress OpenType fonts. So in LaTeX, we use raw callbacks to output Unicode, to output special commands that contains Unicode characters. And in ZTech, we use macros. So we just redefine all Latin characters by default, but you can load redefinitions for other scripts. So you need to load definitions for Cyrillic and Greek and Indian scripts. I can post a link to the chat because this is actually described in the new documentation. But yeah, but this is one thing that is hard to do. There is alternative version of tech4ht command that supports open type fonts, but it's still in development. It's developed by VTech company from Lithuania. So I hope we will be able to use it one day and be able to just forget about these hacks for ZTech and RuaTech.
Thank you. There is Martin, you raised your hand.
Yeah. I have a question. This is very impressive stuff you did there. Congratulations. Thanks. You did a very good job. I have a question regarding the output routines. That's a problem that I always face, that the output routines do things that I don't want to have in my end format. And I think with HTML, you might have a similar problem. How did you deal with all the things that the output routines insert in the DVI file? Part of that you don't want to have in your XML file, and others you want to have, like floats or things like that.
Yes, this is this stuff was written by the original author, by Aitan Gurari. So yeah, this is a bit like black box, I would say. So yeah, there is definitely some redefinitions in the output routine, and therefore HT disables, for example, hyphenation, and it changes documents the dimensions in order to fit everything on one line. And yeah, so I think floats are supported because it patches LaTeX internal code to get them, and with stuff you put to the output routine is not supported.
And how do you handle floating images?
Yeah,
because the output routine might move the float around someplace.
Yeah, I think they are just output at the place they are used. They don't float anymore.
They don't float.
Yes.
But when you process the DVI file, you might find the float at a different position where it is in the original text file.
Yeah, I think this is handled on the LaTeX side.
Yeah.
So it doesn't float anymore.
So it stays where it is, where LaTeX puts it in the output.
Yes.
Okay. And you make the pages wide to avoid floating. Do you make the pages high to avoid floating? Or
No. They are just slightly bigger. And I think the main stuff is that hyphenation is disabled because you don't want hyphenated words in HTML.
Yeah. Okay. Thank you. Very good.
There is a question from Dejan in the chat. And Dejan, you can speak if you want.
Yeah, I don't see new questions in the chat. I see only from Rajesh.
Yes, in the Q&A, only from Rajesh, but in the chat where there are all the messages and the URLs.
Okay. Yeah, can you read it, please? Because I don't. Yes. In chat. Yeah, sorry. Yes. So I'm curious. Does Tech4ht have a fixed schema for the HTML directed image? Penduk has its own HTML, has its own tracks, has yet another. Do you think we can get most projects closer to consistent technical document dialect of HTML? Yeah, the thing is that the most of the configurations that we use are have been collected for the last almost 25 years, I think. So some of them are really old. So in the I put some new stuff in HTML5 output, but for most stuff we still use HTML4, and yeah, we don't really have any dialect because at the moment we have so many bug reports about package support that I don't have a lot of energy to rewrite hundreds of configurations to be put together. So in general, it will be nice, but I don't have capacity for that.
Is it possible that the owners of the packages could provide the support for their packages in Tech4HT? I know that's not something that's in your power, but you're providing them a service. Perhaps the owners of the package should have a responsibility for supporting Tech4HT. That's just a suggestion. I don't think it will get anywhere.
Yeah, it will be nice, but yeah, because there is still missing documentation about package support writing. Yeah, we cannot expect package writers to make support. So at the moment, I do most of the package support. Yeah, but yeah, definitely I should put package support documentation together and attract more input from other people, because yeah, it's a lot of work and it can be quite hard. So so some coordination with package writers will be really nice. But yeah, I think because of new development in LaTeX accessibility, especially the hooks, they already enable to quite easily put XML, put Tech4HT code to LaTeX internals. So I think in the future it will be much easier to add support. And in general, you don't need support for packages because Tech4HT can detect font changes, so the basic stuff works. You only need support if you want to make, I don't know, for example, some frame boxes, or if you want to output some semantic HTML, you need support. But by default, if the package doesn't clash with Tech4HT because it defines the same macros as Tech4HT, it doesn't read any support for the basic work.
Frank has a question, I think.
Well, more comment, but you already made it in some sense. Part of why we have the hook system being set up is to enable these kind of alterations that are necessary for something like Tech2HT to become smooth, in the sense that the right kind of places for doing alterations is actually there. So in some sense, what would be really helpful is to get help in the sense of where are the points where you need these kind of hooks to be available in various places, because if we are able to put them in the right places, then that will ripple down to additional support packages, in the sense that they will pick up these kind of things as being part of their alteration for, say, for table or stuff like that. And so getting where we are trying, obviously, to get the right things in the right places by ourselves in some sense, but we are not always being aware of the need that there is a hook necessary in a certain place. So if you come across these kind of things, feeding that back to the LaTeX team will actually benefit both sides in some sense, because then we can make sure that this fits with our sort of additional support for the for conversions, as well as for accessibility, as well as for tagging, etc., etc. So just as a general comment here, that's really part of why the hook system has been set up, and over time will grow.
Yes, thank you, Frank. Yes, yeah, this is definitely good comment. Yeah, actually, I already use the hooks system for environment, and this is it is really great because there are so many points where you can put some code, and in general, every basic commands that just change fonts. You need some hook before this command and after the command to put starting tag and stop tag. But for example, some frames or tables, they are much more complicated.
It's now the end of the session, but I don't see any inconvenience if people want to stay here during the break to chat about technical points. I can see the discussion is going on nicely. I will just thank everyone, all the speakers, for the great talks that we had during this session. Also for Arthur, that is doing a wonderful job in the back office, managing the video and everything. And I will leave you for the next session that will start in 53 minutes. But again, people can stay here to chat during the break.
Okay, thanks.
Hello, everyone.
So Hugh should be around. So Hugh, do you want to say a few words before you start?
Good morning. Yes, thank you. Andy and I both are linguists, and Andy's a programmer, and we met working with minority languages and linguistics at the University of North Dakota, where he was faculty and I was a student doing my master's degree. So that brought us together to do this paper.
And you're from the USA, I think.
Yes, we are both from the USA. I'm in Ohio right now, and Andy is in Arizona.
Okay, cool. So you have recorded a video, so we'll play it, and you will have questions at the end.
Welcome to our presentation. Our talk today is about Xlink paper and its use of technologies. Presenting will be Andrew Black and myself, Hugh Patterson. I will be narrating. So a little bit about us. Andy is the developer of Xlink paper since 2001, and I am a bug reporter, feature requester, advocate, and user of Xlink paper since at least 2014. And my work my use of Xlink paper has brought me closer in connection with Andy and the discussions that ensue out of that. So we bring this together as Andy's the developer and myself as a user. So our goals for this presentation is first and off to say thank you to the developers of technology packages which we use. And second, then, to inform the tech community of our project and to use technology. And then finally, as we present, we also want to open ourselves up to receive and consider suggestions from the tech community on the infrastructure design of Xlink paper. And so if people in the tech community and developer community have contributions or suggestions for Xlink paper, we are open to receiving those. So a little bit about Xlink paper. So Xlink paper is a plugin to XML-Mind. XML-Mind is a commercially available software for creating XML-based documents and is broadly focused on the production of technical documents. It's and Xlink paper then is a plugin to that software. XML-Mind is written in Java and is cross-platform. Xlink paper follows in these software choices, and so it works on Windows, Mac, and Linux. Now, XML-Mind allows for the creation of specific document types. Think of these maybe as a template in your structure design of your document. And so Xlink paper avails itself of these options and has different preformed templates for papers and books and edited volumes or specific kinds of books or papers. So there's about 6 or 7 of those. In addition to that, then there are reusable document components. So if you're working as an author across several documents and you want to reuse your glossary terms, or if you want to reuse your references section and in a similar format to what BibTeX does, if you have a database of format of references, you can use document components as well in Xlink paper. And finally, a final type of document that is in Xlink paper is a publisher style sheet, which is an XML set of values for creating a style sheet to meet publisher specifications. To look at XML Mind's interface, this is for those who might not be aware of the software. This is what it looks like. In the main screen is where the author will compose their document. And then there are two auxiliary screens to the right, which one is for the one with the yellow in it is for reports after processes are completed in the main document. So after you save or do a print to PDF or something like this, then you get some feedback. Maybe it might be all clear, or you might have some specific errors or some things are unresolved that the user can then take actions on. There's also things there from the XML Mind interface and other little tabs in that Windows section, which allow you to insert special characters or do searches, things like that. And then the window above that, on the right-hand side, it allows for the selection of the next document component. So by component, I mean like a header or a complete section. So, you know, section 1 or section 1.1 or the abstract. So in the document structure, there's, you know, you have the header of the document, and then you have the main core part of the document, and you have the footer of the document. And you might have specific things like a acknowledgement section or an abstract in the header of the document, or, you know, front matter versus or back matter, or other terms that that could be used. So what's really unique from what I've seen in different software types is that to produce a valid output document, Xlink paper restricts the input. So if you have your cursor somewhere in the software compose window, the options to the right where the green arrow is only are dynamically generated and are only allowed on the basis of a valid document type. So, and this is controlled through XML languages such as DTT or the schematron parts of XML Xlink paper. So the document type is then controlled and is validated with XML technologies. So basically then you can insert what needs to be or what's possible, and depending on what particular document type you're working with, different things might be possible. And this is all done through the Xlink paper schema and uses the power of XML Mind's interface to deliver that. So this is in contrast to a free text editor. It reduces the compose errors when one goes to compose a PDF from the source by limiting what one can put in the document in which places. So I think that's a great advantage over using a standard text editor. Of course, because it's based on XML, one can use the XML editing features of XML Mind. And this next screen shows that the XML view, one can also use XSL technologies to edit documents en masse or to do document-wide edits of various kinds. So the power of XML is available to authors as well if they wish to avail themselves of those tools. So to talk a little bit about Xlink paper and its design goals over the history of its development, 2001, we're approaching 20 years of development. So a first design goal was to be as free as possible, so both in distribution and licensing. So that's really important to the developers, Andy, primary among those, but also should be important to the user base as well. Content separated from styles, with publishers having unique style sheets expressed in XML. So when I talked about a few screens ago about the different document types, publisher style sheet is one of those, and a core idea in Xlink paper has been to keep the content independent of the final publisher style, and to differentiate those and allow the abstraction of publisher styles so that one can take a document from one publisher style to another, and give the author some flexibility in that regard. Now, of course, that is mostly typographical style choices and not so much content style choices. Different publishers have different content requirements, and no one's going to be able to automate Oxford commas. I mean, maybe Wikipedia does, but at any point, that's the goal and separation of presentation style and through publisher style sheets. But another important aspect of the Xlink paper's development path has been the low bandwidth target user group. So many of the users of Xlink paper work with minority languages in parts of the world where the internet access is either really expensive for the gigabytes or megabytes of download capacity, or there just doesn't exist internet there. And so what this has meant for development and using technologies is that Tech Live is not a viable option due to its size. And as a result, what Andy has done has been to pre-select specific packages and to package those in the Xlink paper and distribute them as a single download, so that the end users for Xlink paper only need to download Xlink paper plugin and XML Mind. Those are both available through the Xlink paper website, which there'll be a link at the end of the presentation. Now, to discuss PDF creation, Xlink paper has a couple of options. It has several different document type outputs. Among those are EPUB and XHTML and CSS. So Xlink paper directly exports to XHTML and CSS. Then there's a secondary process to convert those to EPUBs. Xlink paper also has the ability to use XML Minds .doc and .odt, which is the Open Office format. So you can use those export processes within XML Mind, and those are based off of XSLFO. So working with Xlink paper's XML to convert it then to XSLFO, and then using the XML Mind processes for working from XSLFO. Back in 2009, Andy began to think about adding a zLaTeX-based output to Xlink paper. And before 2009, the XSLFO process was able to be connected to RenderX and RenderX PDF output process. And that had a watermark in it. So Andy was looking for a different option than the PDF production process through RenderX. The current path that the information travels through is that Xlink paper's native XML format then processes to a TeXML-like XML, and then that gets processed down to a zLaTeX file, and that gets processed then to a PDF. and those create really nice PDFs, and there's quite a few options in there. And I can say that with confidence as I wrote my MA thesis in this software. So the TeXML, why didn't the Xlink paper project go with TeXML? And here's the disadvantages and the design considerations that we, or primarily Andy, looked at. And that TeXML required Python, and the design requirements then would require users to install an additional copy of Python or to connect to a Python version that was compatible with the TeXML project. And so it was decided to, rather than add complexity to the install process, that it wasn't the right project or the right components for the Xlink paper project. And in addition to that, there were some technical issues. The Xlink paper needed some extensions for formatting white space more finely than what appeared to be available through the TeXML options. So Andy did implement certain mapping of using Java, because so XML mind is written in Java and the core of the plugin is written in Java. So using some Java code, Andy did create some custom actions inside the plugin to implement text characters and some things like that. So there was some tweaking using Java for that, but TeXML wasn't the right solution for us, at least us at this time, or us in our knowledge at this time. Another big area, so Xlink paper is targeted to users who are writing linguistic documents where the subject matter is of a linguistic nature. And often these are dissertation writers, theses writers, and grammar writers of books that are on languages and things like this. So languages or linguistics. And there is a well-established community within the tech community of linguists using tech technologies, and LingTech is one of those groups. And so it was decided that some of the capabilities that had been developed prior to 2009 to work with the RenderX components were easier to bring to a PDF without adding additional packages from LingTech or the linguistic community. So most of what exists inside of the packages that are used for Xlink paper are not from the linguistic community of authors and publishers who use tech technology. That is to say, we're fairly generic. But these are the 20 packages that we do use in the Xlink paper distribution. So attach file 2, book tabs, calc, color table, e-toolbox, fancy header, font spec, footnote miscellaneous or hyperref, lineo, long table, landscape, MD frame, the multi-row, normal, EM, polyglossia, set space, tabular X, and XLT extra. So occasionally other packages are considered and tested when specific features require them, or a use case can be developed saying that it's necessary, and another way of figuring out how to typeset it isn't figured out. One kind of looking back, there's a package called Memoir, which is really nice and powerful. And that, if Andy had known about that before, he said that he might have implemented that instead of some of the custom tech commands that he developed. And these are some of the custom tech commands that he's developed. And some for the table of contents, lists, examples, indices, such as in the back matter, interlinear examples, block quotes, and table headers. So these are some of the things that are custom tech commands connected in the Xlink paper software. And I think what's one of the important things to discuss and present is the typesetting tasks that Xlink paper users often encounter. So that is, are we doing formulas? Are we doing language trees? Are we doing, what's the common kind of tasks? And the common tasks that are supported by Xlink paper are lists of words and their glosses, interlinear clauses, headings for an example, automatically wrapping in interlinear texts, abbreviations used in glosses and interlinears, hyperlinks between example numbers and their inline in the texts, the example numbers and their examples, so you can click between those, abbreviations used in interlinear glosses and their definitions of those those abbreviations and some linkage between those. Those are quite common in the types of documents that Xlink paper users author. So by way of an example, here's an interlinear example. So you can see the example XQN, and then we have 2 tiers of that. And that's just inside of a section. So section 2.11. And we then, that's what it looks like in the user interface. And then we'll see in a few minutes what it renders to be. Here's a little bit more of a more complex example. You can see that in these 2 interlinear lines, the first text, there are 2 lines of text. The first one is like a practical orthography. The second one is an IPA rendering, which linguists use this for phonetic description or a rough phonological description. Then you have some grammatical annotations, and then the yellow there is the green and yellow. What the yellow specifically are abbreviations, and then you have a translation into Spanish, and you have a note there as well. So these backgrounds in the user interface help you navigate where you're at. With the if you're in an example might show up as a particular color, or end note shows up as a particular color. So there's some support for that in the and that comes from Xlink paper and XML-Mind. But when we look at these examples in an output, here's section 2.11, and you can see you can choose the color of your text and the output and your styles and such like that. But it's often the case that you can see that examples might have 2 components. So we have example number 2 in this document, and then we have example A and example B, and you can see how there's some alignment in between the green tier and the red tier in 2B. And then we have a practice of, in linguistics, for on the right hand side, the blue link, like Samjin 6 or FC 5.1. These are basically references to another text that would have where these would be sourced from. So this keeping those references automated, not just for the references at the end of a document to like other published materials, but also to texts and corpora is also important within linguistics as well. And then obviously then we have several lists going on too, like a list of A and B, and section 2.1, 2.11, and then example 2. So keeping track of those things is, for me as an author, has been really beneficial to let the software automate that. So here's an example of the output of several abbreviations. You can see this Xlink text produced PDF. Let's see. Yeah, so if a reader of the PDF abbreviation reference. It wants to, let's say it was in the text. Let's go back. So if it were in the EST right here, if I wanted to see what the EST in section 2. In example 2B was, I could click that, and then it would take me to a section like this that would then show what that was. And I could see my abbreviations. And there's different ways of formatting this. You can do it linear like this, or you can do it as a table, and both are supported. So here's another example of a text inside the user interface of XMLMind. And then here's how it would look when rendered. And this is a story that's told and separated by clause for grammatical parts and things like this. So this is fairly typical for what a linguist might want to read it and understand how the grammar is working. Some other typesetting tasks that Xlink paper users often encounter are tables and font rendering. Using the Unicode fonts is highly encouraged. Hyphenation for non-English languages is an issue that several users have encountered and avail themselves of those tools. Authors' contact information is often important and is important when you're doing stuff across different documents. It makes it easy to do that. Vertical fill and blank page. Those are all important tasks. Here's an example of using a font and to do the IPA pitch. So on the left side, we see from an African language, Mbo. And this one is, you can see that the blue area is the root word, and then they have a frame, and they're looking at the pitch, the tonal pitch, and they're going to write the pitch there on the right hand side, and you can see that in the gray. And let's render this for you. So here's the example in 11 in that paper, and you can see that there's sub examples, I guess, enumerated A through I, and then you can see with the pitch trace lines across the on the right hand side. So you have on the left you have the word and the frame, and then on the right side you have the pitch. So that's the type of typesetting that's often done with Xlink paper and using ZLaTeX to do that. So thank you for listening to our presentation today about Xlink paper. We are available for questions. You can check out the software at Xlink paper's website, https://software.sil.org/xlinkpaper. But then you can also, let's see, contact me or Andy Black, and here's our emails. Let's see. Yeah. There we go.
Thank you.
So
thank you a lot.
blackhandrew@gmail.com or I@hp3.me. And we'd love to hear your comments and feedbacks. And thank you for listening to our presentation.
Thank you a lot, Jürgen. It was a bit too quick. I have forgotten it was a video.
You can hear me, right?
Are there any questions?
I have a question.
Sure, Arthur.
Yes, you mentioned that you had some authors had problems with hyphenation for non-English languages.
Well, the hyphenation patterns are different in different languages, how they match to syllables or accepted typographical practice. And so what Xlink paper does is allows you to set the language that hyphenation will occur in, and passes that through to the ZLaTeX parsing. But it also allows you to establish a list of custom hyphenization patterns. And so you can keep that as a document module and then pass that in. And whenever the PDF production happens, then it'll go through and basically use the custom thing and then fall back onto the language of choice.
Thank you. What I wanted to say is that, hyphenation patterns are currently available for at least 60 different languages, 80 if you convert dialects and variants. And I am actually responsible for maintaining all of them in TechLive. So if you encounter, obviously we can't invent hyphenation patterns for languages that currently don't have them, but I'm well connected in the community and I can try. And if you actually have a long book in some language to typeset, I can try and find someone who would be. We literally have hobbyists, amateur hyphenation pattern developers.
Right. I should connect with you then. I'm writing a different paper on using hyphenation in different languages or hyphens in languages where they are not using the hyphen as a hyphen. So it creates typesetting challenges when you do that. But yeah, I would love to connect further on that.
Yeah, let's do that.
Oh, hi. Sorry, there's a. Oh, it's gone now. Sorry, I'm being distracted by the echo. So, echo's gone. Good. I think there's a really interesting overlap between yourselves and pretextbook.org that is creating accessible math books using an XML language called MathBook XML. And their focus has been on getting the outputs right because accessibility is hard. And to solve that problem, they've insisted on having XML inputs. I think your situation is a bit different, but you've created a plugin that allows the use of XML Mind, which I wasn't aware of. They've been agnostic about the input. They just said, you've got to create XML to use this, and they don't have a particular system with components for it. But you've both taken the route of XML and DDT or schema in order to tightly specify what goes in. And I think you could have an interesting conversation. Rob Beezer is the technical person there, and I'm happy to put you in touch with him because I know him a little bit. Is what I've said of interest to you?
Yes, certainly. If you can pass me his information, then yes, please make a connection.
I'll be delighted to do that. I really like what you're doing.
Are there other questions? I have one completely naive. In which context do you use Xlink paper? Is it in your office when you're studying corpus, when you're interviewing people? I'm not at all in linguistics. Just naive question.
Right. I use it after my linguistic elicitation. I use it when I'm writing papers that I would send off to a journal. So in the composition process, I use Xlink paper. If I'm collaborating with another author, I might use Google Docs initially to get some basic content. But then when I go to typeset my first draft for submission, I throw it into Xlink paper and use it there.
Okay. Because I understood that you were carefully picking a few packages, a few LaTeX packages, because you didn't want Xlink paper to become a big blob. but at the same time, you could import everything and work comfortably.
We could import everything, like once and use on. Are you saying we could use TeX-Live?
Yes, you could use TeX-Live. You could also you are reluctant to use Python, but in fact that's not a big deal to have Python on your computer.
Right. No, the issue with the TeX-ML and Python is mostly how do you get non-technical users to install and have a smooth install process. And fewer moving parts or fewer technology components, you have less to troubleshoot.
Well, maybe something like Docker will be a solution in. You're muted, I think.
Thank you. Yeah, Docker is an interesting solution. I'm not sure that it solves all the problems we're working across 3 OSs. I mean, Docker does help solve that kind of problem. So it's an interesting thing to think about for sure.
But that's nice to see people develop tools, specialized tools for their job, and use LaTeX inside those tools.
Yeah, I've used TeX-Live. I've created the so when Xlink paper compiles down to TeX or ZTeX document before it produces a PDF, I've actually taken that and then taken that TeX document and then moved over and used TeX-Live. Done a few tweaks when I wanted to use a package that wasn't part of the Xlink paper. I think I was playing around with right to left scripts. So that's still not well implemented in Xlink paper, the whole right to left component of various writing systems. So there's not a lot of users that are in using those sorts of languages in Xlink paper's user community at the moment. But I was citing somebody that had published in that, and I wanted to use that instead of a romanization. So so we moved it over and did that. Used a TeX-Live and some Arabic scripts for that. But yeah, you can still use TeX-Live and take your document after it's compiled to the ZTeX format and then add or tweak or whatnot to it.
Nice. Thank you.
Thank you. I support your choosing to use a subset of TeX-Live, and that's based on what I know about something called TinyTeX, which is part of the R language. I don't know if you've heard of it before. No, you haven't.
Well, I've definitely heard of R, but not TinyTeX.
Okay, so with R, you can pull in packages, and TinyTeX appears to the R user as just another resource you can get from the usual R locations. And it works with R Markdown. So you write a Markdown document, and you may not even know that you're using TeX. There's a great phrase somewhere: people don't want to use your software, they want to have used your software. So people don't want to use TeX, they want to have typeset their document. And I think there's a great mileage for package distributions of TeX that are suitable for special purposes for people that just want to get something done. I'm also really interested in XML editors. Where I used to work, the Open University, we have a big VLE, and we use, I think, Oxygen as the XML editor. And it's expensive and it's got a steep training curve, but it allows the great benefits post-authoring. Now, XML structured documents don't have to be complicated. Anybody that's filled in a form in Google has created a structured document. And in fact, anybody that's created a Google survey form has created a structured document. So a system whereby simple structured documents can be created simply, which means there are no buttons to press that allow you to do anything else. I think we've got a great mileage for special purposes. And if you need a small back end comprising of tech and a few style files and a few fonts to produce the PDF, just provide those, and then it's all under your control and you get uniform outputs. You don't have to worry about hidden dependencies and things changing under your feet. So I think what you've done is really, what you and Andrew have done is really interesting and an opportunity for the tech community to get more people using tech and liking it without even knowing they're using it. I think you're muted again.
Thank you. Yes, totally. That's been the goal. Thank you for articulating that well.
Are there any other comments or questions for Hugo? Apparently not. So let me thank you again for your nice talk. Nice work, nice interface. And we have a few minutes of break before the next talk in 3 minutes. Thank you, Hugo. Hello, Nicolas.
Hello, Jeremy. How are you?
Fine, and you?
I'm okay, thank you.
So you're from Bogota in Colombia?
Yes, I am.
What time is it over there?
It's 10:45 in the morning.
Okay, cool. And from what else you told me, you're an associate professor in medieval literature. You're doing digital humanities at the Universidad de los Andes.
Yes, I am. Yeah, I teach everything related to Latin and Latin literature and mostly medieval literature. And I also teach in the master's program in digital humanities.
Okay. Well, I guess we can listen your talk. It's about Tech and Coding Initiative XML, I think.
Yeah, it is.
Okay, you have the screen.
Okay, thank you. Okay, you are seeing my screen?
Yes, perfect. We can see your screen and hear you.
Great. Well, thank you for coming to my talk. I wish to speak about the workflow I'm using in working with TI XML documents to transform them to LaTeX and to produce from that result print-ready PDF for publishing. This is the background of this work is my Spanish annotated translation of a late medieval work called Salomon and Marcolfos. It's a work dating at least to the 11th century, and there are several translations into modern languages, but none to Spanish. So I decided to create, since I work in digital humanities and work with the Text Encoding Initiative, TEI, and I work with LaTeX and related technologies. I wanted to create a Spanish annotated translation, digitally born, not produced from other sources. This is an image of one of the printed editions. This is a 1514 printed edition, but I'm working also with the manuscripts. So as I said, it's born digital. I'm using TI XML with a custom ODD and relaxing schemas to ensure consistency and validity of all sources. And the results of this work should be, well, a web page, a web application indeed, using HTML and cascading style sheets, and a print-ready PDF. In this moment, I'm only going to speak about the print-ready PDF. There are several ways of producing a PDF output from XML. I chose here the possibility. I chose here to use XSLT transformations to produce a LaTeX or Lua LaTeX indeed output, and therein produce a print-ready PDF. I'm going to speak about that. So the original plan of this work, the translation is ready. The TI document is finished. Is for almost every type of TI element, say a quotation, a paragraph, a chapter division, create an XSLT template which transforms it into a Lua LaTeX text. I'm using Lua LaTeX because I need full Unicode support. I'm using several scripts, not only Latin scripts, but ancient Greek and Hebrew in some cases. So I needed full Unicode support, and with LaTeX you can do that with Xlink, or I don't know how you pronounce it, Xlink, and Lua LaTeX, and I'm very familiar with Lua. And as I will mention in a moment, I thought I could use some Lua code in my LaTeX sources to do some processing. So the idea is, if I have, for instance, this text in the original source, in the TI XML source, some text which is in the content of a highlight element, which should be rendered as an italic text in italics. The idea is to transform this into something like this in LaTeX, an emphasis or env or text IT with some text. And that's not very difficult to do with XSLT. For instance, this is a simple XSLT template to do that. It selects the highlight elements which have a rend attribute whose value is italic, and will produce this text env and open braces, then the content of the element, and it close the braces. Of course, it can be a little bit more interesting and more complex, because there are several kinds of highlighting, and thus I would have to take care of, for instance, small caps, boldface, text in superscript, text in upshed, which is I don't know how to say it. It's not italicized but straight, and in the ultimate case, just emphasize. So this is a very simple XSLT template. All processing, so to speak, is done in the XSLT. I mean by that that the XSLT template, the XSLT transformations, select the appropriate LaTeX commands depending on the value of this attribute. So everything is done in the XSLT. But there are more complex problems, more complex cases, and thus I bumped into several problems, several issues, some small ones easy to fix, but other more difficult ones, and I can reduce them to two kind of problems. One is the white space problem, and the other is the processing problem, and I'm going to talk about them here. So the white space problem is a very common problem you have when working with XML. Sorry. Even though XML swallows, so to speak, multiple white spaces and multiple line breaks, you have to deal with the line breaks in this case in order to avoid unnecessary introduction of unwanted spaces. So for instance, this is a paragraph with some text, and this is a note, and this should be rendered as an end note in my edition. And I want to stress here that since I'm working with the source file, it's an XML, a TI XML document, I need that code to be readable. Let me show you an example. I don't know. Let me have to share this another screen here. Bear with me a minute. I always lose my. Well, I couldn't change. I lost my my original way of well, never mind. So of course, as I was saying, I want my source file to be human readable. If I eliminate the indentations and line breaks, of course the XSLT can process it without a problem, but it won't be readable for me or easily readable, because I need to easily see and detect the structure. So there's a compromise between readability in the source XML files and the white space problem that you will be creating unnecessary space, and you have to deal with that. XSLT has some ways of dealing with that, but there are other ways. There are some problems you cannot solve with the XSLT rules. So this would be rendered without further processing, just using my XSLT transformations as this line which is the second line of this paragraph, and it would be introducing a white space before the footnote anchor here, the end note. Sorry. So how do you deal with that? You can manually edit the output LaTeX text, but the idea is to automate as much as possible. So the way I use and the way many people use is to apply regular expressions using set, for instance, or another language. I chose to use Python for this, which I'm a little bit familiar with. And I created a Python script that removes all unwanted white space. And as I said before, this cannot be done only with XSLT. And this cannot be done only with the LaTeX or the Lua LaTeX. At least I couldn't do that. So I introduced a further step here. So we have the TI XML sources, the transformations I use, and I produce a Lua LaTeX output. Then I use a Python script, and here are some examples of the regular expressions. This is the search string, and this is the replace string. There are more or less 30 different search and replacement. This is just a Python list, and then you obtain a cleaner Lua LaTeX output. So this was the way I use and other people use to remove that redundant space, or to remove that unnecessary space. Of course, not all spaces are removable. You know, if you remove a line break in a LaTeX file, well, you can just get only one line, and you don't want to do that. So you must be very careful of where to do those removals. Okay, the processing problem is the following. I need to do some processing of the text I have in the sources, in the TI XML sources. And the problem is where to do it. Ideally, you should do it either in the XSLT transformations. All processing should be done like that, as I showed in this example before. You have an element with some attributes and some values of those attributes, and all processing is done here, and you just get the LaTeX output, the LaTeX commands. But the LaTeX document isn't processing further this. So that's one place. Or you could simplify as much as possible the XSLT transformations, and all the transformation can be done in LaTeX or in Lua LaTeX. The idea is that well, it's not just only one of those places to do all the processing. It's simpler code, and it's more easily to maintain. So that's what I was looking for, but I couldn't do that. I can tell you that. I had to do some processing in the XSLT, and some processes, by which I mean I had to design some commands in LaTeX and the LaTeX source to further process what was the output of the XSLT. And that might be because I don't know too much about the XSLT, or I don't know too much about Lua, because for some cases I tried to use Lua code. There are some discussions in the Stack Exchange website. You can look for them, where I try to ask questions about how to do some processing in Lua to avoid doing it in XSLT. But I couldn't, so I had to do in both of these worlds, which isn't, in my perspective, the best solution. So let me show you an example. This is, we have one quotation embedded in another one. This foreign element is used in TI just to mark out a text which is supposed to be in another language from the main language. I'm using it here in my definition of my document as a foreign quote, and it should be used as a quote, and it has another quote inside. The XML :lang attribute contains the language used, of whose content must be specified. In this case, it's Latin. Well, what's the problem? The problem is that the XML lang takes as a value an ISO standard of language names, from Latin, ENM, as I show you in a moment, for Middle English and so on. And those Latin languages, those XML languages, those language codes do not match, of course, Babel's, latex Babel's language codes. So there has to be some processing of that. I tried to do that in Lua code, and I found some problems with that, with the compilation of the document, the typesetting of the document rather. So I decided to do that processing in XSLT. I'll show you right now. So just to make clear what I'm talking about, these language codes are the language code for XML, or that's the standard. You could use other ones, but this is standard, and I want to be follow the standard, so other people can use and reuse my work. But these language codes aren't the same as used by Babel, which is the language and hyphenation, how to call it, library using LaTeX. So we must transform it. This is what I mean by a further processing of the text. The problem is where should I do it? In the XSLT transformations or in the Lua LaTeX document? Well, as I told you, I resorted only in this case to XSLT transformation. So I created a simple template and a simple function used in my XSLT style sheets, and selects according to the value of XML, the XML lang, which you can find here in single quotes. This is Anglo-Saxon, Old English, Middle English, Modern English language, Spanish, Old French, Middle French, Modern French, Ancient Greek, Welsh, and German. According to this value, select and produce this language code, which can be used by Babel. As you can notice, and this has, I think, reverberates the previous discussion, the previous talk. We have, well, at least as I know, we don't have Old English or Anglo-Saxon or Middle English languages and hyphenation rules in Babel. I might be wrong, but I just resorted to choose English for that, and it worked fine. Latin, Spanish, French, the same problem here. Greek, Welsh, and German. This is the transformation, the template, and it matches foreign quotes mentioned. For instance, if I'm mentioning and not using an expression which should be quoted, clauses, which are the explanation of those quotes, for instance, and quotes, this Q, sorry, which do not belong to citations. As I define citations in my ODD and in my RelaxNG schemas, citations are more complex elements containing a quote in an original text, and you use the quote element in TEI, followed by a translation. If it's not, in my case, if it's not Spanish, well, it should have a translation. If it's in Old French, for instance, I included the translation, and lastly, a citation, which for which I use in the LaTeX document, BibLaTeX, which I love and which I found very useful for my purpose. So this template concerns all quotes not belonging to a citation. And what do I do here? Well, I create, and I previously defined, and I'll show you the definition, original quote, a quote command, which I'll show you the definition in a moment in LaTeX, which has the language code as its first argument, and this is here. It selects using the previous function I showed you here, the appropriate Babel language, and this is here. If it doesn't include an XML lang attribute value, then it simply, as a default, chooses Spanish because it's a Spanish translation. Then includes a label taken from the XML ID. That's for me to be able to cross-reference every citation and every quote, and to create an index of that. And lastly, I insert the text, the content, which is the third argument of this this command. This is only this last quote here. Just there are some quotes which have a linguistic signification, and I chose to represent them in another way because they are what linguists call lexemes, and so I chose another kind of rendering of those quotes. But this just inserts the text. So as I said, this template selects the appropriate language, the label, and inserts the text in a command which I defined in the preamble of my LaTeX document. I'll show you about this. Its definition is here. So what does it do? And I'm finishing just in a bit. It checks for, this is the definition of my quote. It checks if it's an empty, if this value is empty. Otherwise, it inserts the label. Here I said this is the second argument. Then it checks for language. By default, it selects Spanish if it's empty. If it's not empty, it selects another language, and it uses I think this is Babel's other language environment. And this is important because if it's in Spanish, I enclose it in quotes, and I use the CS quotes for that. Otherwise, I use simply I italiced it. I put it in italics if it's just an expression in another language. For Greek, I just decided not to italize because I don't like. I don't think I need italicized Greek script when writing in Greek. Some people like italicized Greek, but I don't think it's needed. So yeah, that's what I'm doing. And well, the conclusion is that I couldn't do all processing either on the XSLT transformation or on the Lua LaTeX or LaTeX document, but I had to do transformation in both processing, sorry, in both places. Well, thank you very much. I don't know if we have further time for questions or.
Thank you, Nicolas. We have plenty of time for questions.
I have a question.
Yeah, sure.
Yeah. How much of TEI do you implement? Because I had to work with it myself a few years ago, and I was really scared by how thick the documentation is. It was more than 1,000 PDF pages back then, and I just checked, and now it's 2007. So how many of the TEI elements and attributes do you support?
Well, for this kind of edition, which is not a critical edition, and I don't have to include, for example, lemmas or readings, and it wasn't. I didn't want to create a facsimile edition. It was, I think, a very reduced subset of the TEI, the P5 version. So it's not very much which the elements which I needed really.
Thank you. So I chose a similar approach back then. I mean, I didn't need very complex formatting either, or semantic markup. And I also have a comment, which is that Babel now supports standard language tags. So I think you should look into that, because it may make a lot of your processing easier.
Oh, that's good. I didn't know about that.
Yes, it's pretty recent. So it's 2 years ago approximately. And I also have a note that the language tag that you wrote for Welsh is incorrect. You wrote CYN, and it's CYM. I don't know if that's in your code.
It should be, yeah, it should be a mistake of mine. Yeah, thank you. CYM?
CYM, Camry
okay.
in Welsh.
Yeah, that's a mistake in my code. Thank you.
You're welcome.
I think Frank has a question or remark.
Yeah, well, both in some sense. First of all, thank you for the talk. It was really interesting, and I love seeing TEI, and reminds me of Sebastian Ratz. And yeah, anyway, one small remark. Being a German, we have 2 hyphenation patterns, and in Babel that is by 2 language names. One is German, that's the old hyphenation, and there's N German for new hyphenation. I don't know which hyphenation you wanted, but just to say that. My question is about the early part where you showed your problems with spaces, and you showed input, which was a paragraph, a tag paragraph followed by a note. Now, if I see this as input, it is a paragraph followed by a note. It is not a note at the end of the paragraph. So I was a bit surprised, first of all, to see that the note happens on the same line. But I wonder if you want to comment about this, because to me, that note sits separately from the paragraph as far as the XML is concerned.
Yeah, I understand what you mean. Another way of doing this would be to include the note element within the P element.
Exactly. That's what I would expect to see, and then it should, from the transformation, in some sense, be more natural, and the note could actually, from a tech perspective, take away the space or something. But this year is really after the paragraph comes a note, so it shouldn't even be on the same line.
Yeah, okay, I understand. Yeah, but yeah, I can try that. I thought initially that this should be a quote, not on this last word, but on the whole paragraph. So that's why I thought about that. But I could try the other way you are mentioning it.
Yeah, I was just trying to understand what you were trying to express here, because I mean it's a bit of a complicated situation. As you said, you might want to have a note on the whole paragraph, and it's not quite clear how to express that in structural terms. But anyway, that was sort of my first impression. I thought, well, why is it even on the same line if it is coded like this? Concerning your in some degree, I mean, you translate XML into LaTeX, and the translation of your tags, the language tags, is not, in my view, not different to translating something like emphasis into \emph or into text BF or something. I find it rather natural to see that in the XLT, whereas formatting, which you showed at the end, is actually sort of a task of text. So I think it is quite natural to me that you have these these two sides. One is translating to LaTeX, and one is LaTeX translating to output format. So I wouldn't worry about the fact that you have to do both in some sense. It's just my feeling that this is actually sort of natural, and that you do one at one end and the other at the other. But just my impression to that. So I wouldn't worry about this considered as because translating to LaTeX, like the Babel names and those kind of things, this is the translation that happens before you do the final formatting, and the final formatting is then another step in some sense. My thoughts, but I love your thought, your talk, really nice.
Well, thank you very much.
You should have shown some pictures of the output in the end.
I can show you, but let me see if
can I? I'm worried we'll run out of time. I want to make some comments, if I may, about your. I think it's the previous slide.
Sure, this one.
No, it's the one that has the large sequence of XSL wens. Is that the one?
I think this is the one.
That's the one. That's the one. Yeah. I've come across this sort of thing before, and you've effectively got a table there.
Yeah.
Lookup table, and you could store that table in an external XML file. Load that XML file as one of the additional documents used in the transformation, and then index into that XML file to select the value of the language. So you can have a function that is the same all the time, and you simply have a table that does the translation. It's the feature of XML that you can have several input documents, and you can use data in the first input document to extract an element from the second. And that considerably reduces the complexity of the XSLT code, because it's always the same, always making that choice. And the complexity then is the lookup table.
Okay, but what would the benefit be of separating the XML files?
It means that your code base becomes smaller, that you are, what's the word? You have a simple piece of data that tells you what the translation table is. That's the benefit.
Okay.
And
yeah.
If I was writing that in Python, what I would create a dictionary. I'd look up in the dictionary.
Okay.
Essentially, what you're doing is looking up a key in a dictionary.
Yeah. I understand.
And
key value
with the default value.
Mm-hmm.
Yeah. So why not have a file that is the dictionary?
And well, how can I do that in XSLT? I don't really know.
Okay, and in XSLT, you can load several XML documents.
Yeah.
And you can say, give me this element of that document. So you can use data in the first document as a key to find an element in the second.
Okay. Do you remember the XSLT
command? I think it's called. I think it's just called document. It just says some.
Okay.
You define a variable whose value is a document, and you specify the resource where to get the document.
Okay. Okay. I'll try that. Thank you.
I'll show off a little bit. Charles Goldfarb, the founder of the sort of father of HTML, there's a law named after him which says that if a text processing system has a bug, one of them is to do with line endings. there's some work on XSLT that I've promised to share with Rob Beezer of the Pretext project, Pretext book project, and I think you'd be interested in sharing that too. So it's time for me to be prodding me with sticks until I do that, if possible.
Oh, great. Okay, thank you so much.
Can I go off topic? Which is, I read a obituary recently of Robert Hollander, who I've not heard of, and found he did this magnificent Dartmouth Dante project. And I wondered if you've come across it and had any comments on it.
Dante project? No, I don't know about that.
He produced an online compendium of all the translations of Dante's Inferno.
Yeah, I think I've the Dartmouth, yeah.
Yeah, the Dartmouth one, yeah.
Yeah. Well, I don't recall very much. I don't have an opinion on it. Sorry, but I've seen the project. Yeah.
Yeah. If I have an opinion of it, it's not an expert opinion. I'm just impressed.
Well, there are a lot of very interesting TEI XML projects in the web. There's one which I like very much is the I think it's the women's writer project. I don't know where it is. Which is an excellent project, and there are hundreds right now, which are very technically advanced and also very nuanced in the way they deal with the texts.
The sort of creation of editions. Print was a great sort of incentive to understanding all the different editions and versions of documents. I think that must have been the starting. But you're encoding a manuscript, aren't you?
Yeah, that's one of the idea of this project, but in the moment I'm encoding an annotated translation of a manuscript, or of a critical edition of a set of manuscripts.
So are you making the translation, or does it already exist?
No, the translation is mine.
Okay. So is it one of these side-by-side translations?
It's an interesting thing because it has the original Latin from the manuscripts, but it also has the Spanish translation, and it also has a Middle English translation which exists, which has been edited today, and my idea is to create an edition of a critical edition of the printed editions, the first printed editions of this work, and that hasn't been done.
This is a bit like the way in which they determine when a species came into being by looking at the DNA.
Yeah, of course, that's exactly the same way.
I am very impressed by the way in which linguists can peer deeply into the past.
There's a whole debate on the philologists about how how can you do that? And if it's entirely possible. There are some philologists who claim that that's not possible, that you cannot reconstruct the ideal archetype of a lost work, but you can only deal with existing versions of it. Some philologists are very skeptical about that.
I think it's good to have skeptics in a community.
Of course, yeah.
Keeps the rest of us honest.
If there are some more questions, we have time. We are looking for the next speaker. He hasn't shown up yet, so we have time. Huh?
I can show you the resulting PDF.
Yes, with pleasure.
Yeah, sure. Share screen again. This is the resulting PDF. This is one version, and let me show you the text. See if I can. All these are the footnote anchors, and if you click to them, you have all the cross references. This is the bibliography, which, as I mentioned before, everything was done with BibLaTeX. These are reference to the printed editions. As I'm showing this, these are all the endnotes, the commentaries, and as I mentioned, all processing. I didn't have to do any manual processing after I transformed the TEI XML into Lua LaTeX. Besides the elimination of the white space, I can show you the bibliography. I liked very much this. How do they call it in BibLaTeX? The back references, wherever a work is cited, you can determine which page was cited, in which page it was cited. That's very interesting. I really enjoyed that functionality of Lua LaTeX. Of BibLaTeX. I don't know if you want to see any specific part of the translation.
I just remembered one more thing that I sort of noted when you were giving the talk. Just as a remark, you have encoded in the TEI course various emphasis in how they should be rendered, right? And you use the italic to translate to the \env command in LaTeX. I wonder whether you should actually use text IT at this point, simply because env in the LaTeX tries to do what you, in some sense, don't want to have, namely that it changes depending on context, and you have already encoded how it should be rendered in the source. So using env might suddenly get you upright text because you have nested stuff or so. So I think the translation to LaTeX here should probably be just text italic.
Yeah, you're right, Frank. As a side note, I must say that I don't know why sometimes env doesn't change to upright text in appropriate context. I don't know. I have that problem sometimes. I don't know if other people also have that. An emphasized passage inside an emphasized passage should be rendered as upright text, but sometimes it just keeps. I don't know why in the italicized text.
If you come across an example, I would be interested to see it. Just to understand what is happening. I mean, if you're working with NuaTag and you're using the font spec commands to get your font that has an extended version of the implementation, and it might be that there is a bug in a certain situation. So I would be interested to get an example if you see that.
Okay,
just mail it to me or something.
Yeah, of course, I'll do that. Thank you.
I've got a genuine question this time. Would you be interested in a one-day conference, online of course, on XML to TeX to PDF?
No, of course. That would be great.
Is anybody else here interested in that? You can reply or you can send me an email. One-day conference, online, XML to TeX to PDF.
Great. I know some people who might be interested.
You can be my co-organizer.
Great. Thank you.
We got this here. Uwe Ziegenhagen. So I mustn't lose that email address.
Great.
That's three of us anyway.
Yeah, hi. Greetings from Germany.
Oh, hi. I've just made a note of.
I'll copy also my email here if you want it.
And that's me.
Great.
With the Troika.
I will send you an email, Jonathan.
Thanks.
I guess that if anyone has regrets and want to send email to each other, you can contact the organizer of the conference, and we will distribute the emails of people. I think that from one person to another person, we know each other, so we can communicate. And
so we'll copy the organizers. We're the child of the conference.
Great. Thank you.
So thank you again, Nicolas. That's really nice work, both in the process with XSLT and the results. That is beautiful.
Thank you so much, Jeremy.
Now, the next speaker is supposed to be Nicolas, another Nicolas Jimenez, but we don't have any news from him. So if anyone is in contact with him, that would be great to have some news. And if he's definitely missing, we will take a break and wait for the next next talk. That is an interview of John Hammersley by Paolo. So maybe we can stay here a bit. If people have announcement, that's the moment to do them. And then we can have a break of a bit less than 1 hour. Of 3/4 of an hour.
So I just put the preprint that Nicholas sent for people who are interested into looking into it.
Jeremy.
Yes, Paulo.
I need to do a little bit a little test on my sound system to make sure that it's working fine. Can you tell me how well you hear me?
I can hear you clearly.
Very good. Thank you. Thank you.
I'm announcing the interview.
Hi, Pablo.
Hey, Jennifer. So this is mic number 1. I just want to find out which one is work best.
Okay, this is mic number 1, you said?
Yes. And now I have switched to mic number 2. Do you see much of a difference?
There is a difference. This one sounds like deeper and a little bit richer. Can you switch back to number 1?
Okay. So this is back to number 1.
Yeah, I think number 2 is better.
Number
And
2
then
is
Tom agrees.
definitely better.
Okay. Thank you, guys. Thank you. So this is the best one. Is that right?
Yeah, that's better.
Thank you. Thank you. Thank you for the test. I had some changes on my local machine and I needed, to sort of find out how they work together. Hello,
John. Can you hear me okay?
I can hear you very well.
Brilliant.
There is some echo, isn't it?
So let's try this out.
Better now.
That's still okay.
John, can you say something else? Just to
Sure.
test the echo.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Boris, do you hear the echo still?
There's no echo anymore.
Okay.
Not at my end. Boris, do you have an echo still?
Probably not anymore.
Cool. Cool. Now we should be on in about 4 minutes.
Cool.
Hello, everyone. Good morning or good afternoon, John. And I'd like to introduce you all to John Hammersley. He's a founder and currently CEO of Overleaf. And I'd like also to invite all of you for a conversation. Overleaf is new to most of us that have used tech in other forms, in other ways. And so you're welcome to join and make this interview a joint conversation and with everybody. The first thing I would like to say is that Overleaf is a financial support of TUG conferences. They don't have any editorial relation to us. And John has not seen any of the questions that I'm going to ask him here today. Is that correct, John?
That's correct, yes. Flying blind.
So welcome to our conference, and hope you can join us here and in the future. I'd like to ask you first, how did you get interested in tech? Was it through mathematics? Was through something else?
Yeah. So I did a mathematics and physics undergrad degree, and that was where I first came across tech. I think we used it for one of our group projects in like the third or fourth year. That was kind of how I first came across LaTeX, and at the time it was just a nice, I think someone else had used it, and so we just used it. It was just a nice way to write up the report that we were using, and I didn't really think much more of it in a way. But then I did go on to do a PhD in mathematics at Durham in the UK, and it's just what everyone uses in mathematics, and so just got used it for my papers and thesis, and it was very much just picked up from I installed MikTeX, got going. My supervisor, I think, probably shared some files, and so I had some templates to go on and stuff, and really I used LaTeX for writing my papers, and I did my CV in it as well then, after leaving, deciding to leave academia, and I kind of had used it for things slightly outside of the papers, and I was lucky enough to go into a job then, working for a company that was working on driverless taxis, where we were in a research group, and the company itself had sort of spun out the University of Bristol's engineering mathematics department, and so again we were still using LaTeX internally, and kind of in a way I'm running ahead in a way. This is kind of where Overleaf came out of, in a way, that research group then. I got into it at university.
So you were involved with other technology projects before Overleaf?
And yeah, so I guess in terms of my career, as it were, so I left my PhD and decided after that I kind of wanted to move into industry, because I didn't really feel like staying in academia. I actually felt there was lots of other people doing really great stuff in academia and so many papers coming out. I guess I didn't really feel like I could maybe make much of a difference there. And so my now wife was moving to Bath in the UK to do a teacher training course. So I moved with her and looked for jobs in the area. And there was this company doing driverless taxis. And they were building the world's first system at Heathrow Airport. I see someone spotted the Lego sets in the background. I guess I'll get onto that in a second. But yes, so I was working at a company doing driverless taxis, and it was kind of, in a way, before driverless cars became cool. It was, a few years ago, and the group there, we were doing a lot of research into empty vehicle management. There was a lot of queuing theory involved, and just vehicle redistribution, and how you, in a network, make sure that you don't have a surplus of empty vehicles where you don't need them, and how you can reroute them as needed without making too many trips. Because a lot of the ideas behind sort of driverless vehicles was to minimize sort of wasted journeys and sort of try and optimize the network and things. So we were doing a lot of research and publishing it, and actually, we were starting to work. So when I'd written my papers at uni, I was just working either with myself or with other mathematicians, and so everyone knew LaTeX to a reasonable level. Whereas we were now writing papers with people from other fields and other disciplines that were more used to Word, and also writing for conferences or for journals where Word was the requirement to submit, there perhaps wasn't an opportunity to submit in LaTeX. And so we were then, both, like I say, trying to work with people who hadn't used LaTeX before. And I think, as we all know, like if you email someone a LaTeX file and they've not used it before, like there's quite a barrier then for them to be able to collaborate. And so that was really, I think, where the original motivation for Write LaTeX, as we were called back then, came from. And it was John Lees-Miller. So, he was the guy, he is far more a programmer than I am. We're both mathematicians by background, but John is a computer scientist as well and systems engineer. And he, over one weekend, sort of developed the prototype for Write LaTeX. Basically because Etherpad had recently come out and we were using it. And Etherpad was this great way to collaboratively write notes. And we'd actually used it for writing LaTeX documents, but the problem was you couldn't compile it. And so you had to then take it to, move it locally or do a compile. And so really the first version of Write LaTeX was taking that idea of just a collaborative notebook and adding a button to compile a PDF. And things obviously grew on and out from there. I guess I might just take a tangent to pick up on Sam's comment in the chat about the Lego sets, just because, I do quite like having this background, and clearly the resolution is good enough that you can see lots of classic space Lego. You can see classic space Lego there as well, and then some M-Tron and Blacktron and bits and bobs around. You can't see over there where there's Star Wars Lego and many other things. And I blame lockdown for this. Wow. And going over to my parents' house and digging up my old Lego sets, and then coupled with eBay, which is a source of cheap old Lego. This room is a tip. I could try and turn the camera a bit without breaking things. Let me see if we can show it over there. So you've got the Death Star up at the top, the International Space Station, Saturn V. That's about it. Yeah, there's a load of Lego. A load of Lego up there.
A hardcore technologist.
Something like that. I mean, I guess, so you probably saw the Saturn V, actually. I think it was actually the space race that got me into science and innovation and stuff, because it happens that my sister was born on the day that Neil Armstrong and Buzz Aldrin set foot on the moon. And so every year, obviously with my sister's birthday, we also had the anecdote in the family that it was the same day, back in 1969 when man had first set foot on the moon. And so growing up, I was very much sort of into space and space exploration, and got to go, luckily with my parents, we took a trip over to Cape Canaveral and saw the Kennedy Space Center and saw they've got a Saturn V rocket on its side, I think, or the part of the section. But yeah, we should definitely have a Lego Tix Legos package. I think that's an excellent idea.
Don't give ideas to Sam Carter, or she'll get to work.
But yeah, I kind of grew up being interested in technology in general, and I think the idea, like the pioneering nature of sort of what they'd done on the space race. And I think that's one reason why working on driverless cars was quite attractive, like after uni, because it really felt like it was something that was, yeah, like something that could change the world.
Yeah.
And then actually, yeah, like with the Write LaTeX prototype, one day John Lees-Miller sort of came round and we were chatting, and he was saying, people were using Write LaTeX, starting to cost a bit of money with the servers. And so, maybe it would be a good idea if we sort of maybe looked at it more seriously and decided whether we could sort of turn this into something, because we neither of us had kids at that point, and so we could actually consider doing a startup and consider sort of doing this crazy thing of quitting our jobs, on driverless taxis and sort of working on LaTeX stuff full time, at least for a bit. But I think, I've always been interested in new things. I think, I guess not in the, oh, it's shiny and new. But, I've kind of got a book on my desk, the recent one, Lift Off, about SpaceX and what they've been doing, which is amazing. And, it's sort of, I think it's amazing, all of this inspirational stuff that's happening right now.
So that was about what? That was about 10 years ago, John, when you guys got out of the...
it was about 8 or 9 or 10 years ago. I think we first, I think the very first prototypes that John put together were in like 2011, and then 2012, late 2012 was when me and him sort of decided to quit our jobs at the time and then sort of go for it full time. So, yeah, I know, it's crazy. I feel like it makes me start to feel old now, 10 years ago.
So your other job now is kids. You guys have kids now. How do you balance those two things? Pre-pandemic, post-pandemic, if there will ever be a time, and how do you find time?
Yeah, I mean, I love. So I've got 2 daughters, Julia, who's 5 3/4, and Annabelle, who's 3 3/4. And obviously the 3/4 is quite important when you're in single digits. And I found it amazing. So, first of all, I think we never would have started Write LaTeX if we had young children around. I think, it would have seemed like a crazy idea. But so I think it was good that we started Write LaTeX, which is now Overleaf. And in many ways that has been described as like the first child in a sense, because you are looking after this startup, in many ways in a similar way to a kid. And it kind of, it's very dependent on you in its early days. It needs looking after, it needs a lot of attention. And so now, having had kids, I can now see that like the amount of hours that John and I put into Write LaTeX in the early days, it's not in the same way by kids, but you certainly have to have that time free to dedicate to it. But no, I think it's been brilliant. It's given me a legitimate reason to have Lego all around the house, because kids like Lego. That's why we have Lego there, and pre-pandemic, I think that we're lucky in that our kids are young enough, and John's is young as well, in that they don't, that they didn't really notice too much. They have a bit, but they're too young to have had like secondary school kids, I think, have had it much harder in sense of not being at school and things. Whereas, we were okay. And with Liz Liz, my wife, is a teacher, or was previously a teacher, and so when it came to homeschooling, we did all right there as well, because Liz was able to pick that up.
Cool. So, I guess when I if we could switch a little bit to Overleaf, and some technical things. When people look at it, they see a lot of different things. The ability to work with it without having to do installations, the ability to work anywhere, the ability to share a file with somebody or even a large group all over the world is just superb. Something that we've been looking for this everywhere over the last 30 years. I guess since WebDAV started in the mid-90s, people start sharing LaTeX files and doing development together and so forth, and it's just great that this now has formed into a solid solution for all of us. But then there's a couple of things that people don't see it right away, and I was recently told by people, how much they like that. One of them is the automated processing. The automated processing is just like fantastic. You don't have to worry about what kind of indexes are you using, how you're post-processing them, or if you're using BibTeX, or if you're using BiblaTeX, or if this paper is in this framework or this other paper in this framework, and everything is taken care for you. And I think that can make that has made a few of my co-authors lazy. they no longer take care of their own indexes, and so forth. They just wait for the thing to be ready for them. And the other one is one that I have met, about 4 years ago, which is a continuous submission process into a journal. In which ways you can not just submit, but you can let the author work with you as it's going through the processing within the journal production, as it's going through the book production. And they just love that. And my question is, how much up the sleeve you have, what are we going to see? It's this many features. I mean, we mathematicians are waking up now to the fact that that they can do submissions via Overleaf, and they're just discovering that. It's 99% of the mathematicians you talk with them, and they don't know about that feature. They don't know about the journals which are in and the journals which are not in yet. But tell us, what is it coming our way?
Yeah, no, so that's great. And it's great lead in to things. And I think, certainly sort of taking it back to sort of the main benefits, I think certainly the one that it was built for was collaboration, and I think actually lowering the barrier by meaning you didn't have to install anything was a sort of a slight byproduct of that. It was, the main reason for us to use it was to collaborate. But then, of course, as soon as it's there as an online compiler, like if you are a student who's just been told we need to use LaTeX, and you search for trying to install LaTeX, or you can just try it out in the browser without installing anything. I think for a lot of students who are very new to it, I think that that really let them try it out for the first time, and I think that's where what I think having an online accessible through the browser, tech compiler has done is it just meant that people who have never used this before can sort of immediately see the results. And, I think we've done a lot to try and lower the barriers for new users, while still keeping I'll say the full power of LaTeX. It's not, clearly there are things you can't do on Overleaf, but it's still, it's still a LaTeX editor. It's you can edit like the full source and everything. It's not sort of, it's very much focused on providing a really great LaTeX editor as far as we can within the boundaries of like what we can do, with online compiling. I should say, I mean, there's hundreds and hundreds of things on the wish list, I think, and I think having now, Overleaf's usage has grown, and that we have, quite a lot of time is spent on actually just maintaining that level of service and trying to, keep improving it. We did the big integration with Share LaTeX a few years ago now. And I think that was one where we tried to definitely keep it as smooth as possible for the users who are sort of using both platforms, like the original Overleaf and the new Share LaTeX, and tried to sort of make that merge happen with the minimum number of road bumps for the users, which has meant that behind the scenes we've had to do quite a bit of cleaning up work then to sort of tidy up the systems and to sort of make it all bring it all back together again into something that we can take on. But yeah, I think we've got a few things that we're trying to do. I guess picking up on the question of publishers, like a few years ago, I think we have put a lot of effort in with various publishers, and I don't think we got it actually as far as we hoped. I think we had hoped that by this point we would have you submit to a journal, it then your editors and reviewers can then leave comments or, you know, propose changes or however, you know, depending on the journal and the particular sort of process, and then take it all the way through. And then the journal could then take the LaTeX on, or you could run the LaTeX through an XML compiler and get the XML out for the website. And I think where we ran into some challenges there is just that it is a very complicated process, and all of the different journals use a lot of different systems. And also they do often, you know, most journals accept LaTeX and Word, and so are looking ideally for a solution which works for both. And I think for us, as being very focused on the LaTeX world, it was then difficult to sort of take it all that way. So where we got to with a lot of them was trying to actually help make sure that the templates that they had, you know, LaTeX templates they had were up to date. Trying to provide a good way for authors to get going, and then actually just trying to make sure authors had the files they needed to sort of take into the submission systems. I think we've done a few notable exceptions where it did actually work really nicely. Like the best integration we had for a long time was with F1000 Research, where their editorial team did leave comments and track changes for the authors in Overleaf, who then could come in and you know, accept those or make further changes, and then the editor could go through that editorial process as needed. And even that integration was a very early one. It was one of the first ones we did, I think. And you know, even with that, there is many things we could have improved on it. And so yeah, I think with the publishing world, I think where we struggle a bit is trying to not add an extra complication, you know, not somehow make the workflow more complicated in a route to making it less complicated. And so actually now, like I say, we generally focus on trying to make it as easy as possible, you know, on the authoring side, and then on the submitting side. There was a talk from Heinrich earlier on who talked about the LaTeX to XML conversion, you know, that we looked into as well. And again, ideally, it was something that we were hoping to incorporate into Overleaf, so that you could sort of hit a button and get an XML output as well as getting the PDF output. And I think we made a lot of progress, and Heinrich has made a lot of progress there with that. And you know, and obviously, you know, with LaTeX ML as well, and all of the other work in the ecosystem that's improved that there. We've not, again, it's still something that we haven't quite, you know, worked out how it best sort of fits in a way. And I think one of the challenges we have sometimes is that, you know, Overleaf is being used by a lot of people for a lot of different things. And, you know, in the publishing world, like getting the XML output out is useful, and it's useful in certain workflows. For others of our users, let's say students writing group projects, like they have no need for the XML, and it's something that's almost, you know, unnecessary. And so we sort of have to try and, you know, with the development team we have and the product team, sort of work out where can we try and add the most value to the most users, or, you know, which bugs do we need to prioritize fixing, or, you know, how do we keep keep Overleaf up to date with the, you know, the new tech live releases that come out and the new developments there. And so I see there's a question in the chat about why is there still no Overleaf app for mobile devices? And this is a good question, because we first looked at it.
I'd like to precede that question with a preamble. You know, it's a question that I have asked the other two interviewers in this conference. You know, right now, Overleaf is the only decent tech that we can run on just about 80% of machines out there in the world. You know, and a lot of people say, you know, I do not need to run LaTeX on my car player, or, you know, my car dash, or whatever. But there is a lot of very powerful tablets which are, you know, being straightly replacing desktops right now. And Chrome OS is the dominant operating system distributed in the world right now. And the only way that we have to achieve a decent and complete distribution of LaTeX is with Overleaf. I even go as far as saying that, it's important for me to have it on my phone. Sometimes I am at, not during the pandemic, but, with people that the only thing I have in my hands is my phone, and I wanted to be able to share a result, to be able to share a display of a PDF that has been just produced by Overleaf. And I think that that's very important. But the problem is the controls of a web browser within a phone are very difficult. So when are these apps coming? Are these apps ever coming?
No, it's a great question. I was going to say, I think we first looked into doing an app probably in 2013, which was a long time ago now. In the sort of first year that we were really getting going. And I think for a long time, for a good few years, because a lot, like you say, because tablets were used and people would use the browser, like really it became a question of, for an app, there's either two use cases. There's either, like you say, I want to be able to get maybe the PDF or get projects, see my list of projects, but not necessarily edit, but be able to have access to certain things. Or there is the wanting to be able to edit whilst offline, because if you're on a tablet and you're online, then using a decent web browser has generally been okay. And so what the kind of Overleaf app sort of to us needed to coincide with was being able to use Overleaf offline in some sense, a sort of offline mode. And we looked at this ages ago, and I think it was something that we were considering in 2016, 2017. And then that was when we sort of merged with Share LaTeX, and we kind of moved into the sort of integration project that was bringing the two platforms together. And like I say, we're still unpicking some of the stuff there, and we're very close to actually having sort of completed a lot of that work. And then that does unlock making a sort of offline mode of Overleaf available, and it's still very much in the realm of, to be determined exactly what that means, but the ability to sort of, see projects, and at that point, an app starts to make sense, because then at that point you have things that you could usefully use an app for. So I guess that was a little bit of a waffly answer, in that it's certainly not going to be in 2021. I think, looking at an offline mode for Overleaf in some sort is something that we might want to look at next year, and whether that involves an app as well. That's the kind of related question, but it becomes much more realistic, next year. And I guess whilst I'm looking at the questions, so Vitz asked about Git and continuous integration, and the fact that makes it easy to collaborate. And does this diminish the value of Overleaf as a service? And actually the Git and sort of, it is interesting, because, I remember in the early days when Write LaTeX first came around, there was quite a few people that said, why do you need Overleaf or Write LaTeX? Like, you've got Subversion, or you've got Git, like you can use a local editor and you can collaborate with others, and it works. And I think that's true, like for people who are familiar with that, like it is very possible. And certainly, GitHub and has made it easier to collaborate on that kind of repository style way. I think Overleaf just offers it in a different way, I think, and for people who are just getting into this, and not necessarily computer science getting into this, just anyone getting into writing, a sort of technical document online, Overleaf and just that going to a browser and being able to use LaTeX, I think, helps more, or is an easier path in than perhaps if you've never used Git, or GitHub before. If you've used Git or Git before, then I agree, like some of the, then that workflow works for you. But yeah, like if you've never used Git or GitHub before, I think Overleaf probably offers a lower barrier you in. I should say actually, like this, I went to a talk given by Vince Knight, who actually recorded loads of Overleaf videos ages ago, before we actually ever got around to making some intro videos. He did a load of nice snippets. He's at Cardiff University. He's been sort of heavily involved in the open science work there, and he gave a nice talk about Overleaf, and the way he put it was actually this nice sort of triangle of sort of ways of using Overleaf. So you could either edit, online in Overleaf in the LaTeX source mode. If you've never used LaTeX before and you don't necessarily really want to use it, you have the rich text mode, which is still in beta on Overleaf. It's been in beta for a long time, but you can hide some of the code away and just edit the text if you're not looking to do that. But equally, if you have a preferred editor offline, and if you're already set up with all of that, then you can collaborate using Git, using the Git bridge or GitHub to then push and pull things and sort of sync with people who are using the online interfaces. And I know none of these are perfect. Like there's things we'd like to improve in the LaTeX source editor. There's definitely things we'd like to improve in rich text, and there's stuff we'd like to improve with the Git bridge. But it does mean that it makes collaboration easy between people with different levels of experience and different levels of comfort with technology and comfort with sort of different different collaborations.
Wow. Any other questions for John? I mean, do you want to join the conversation? You can unmute yourself and join us. It's for me, it's we just recently had an experience, John, with the editorial services at IMPA, a math institute down in Rio de Janeiro, and we did the International Congress of Mathematicians about 3 years ago, and we have been working on this continuous submission process for a long time, because mathematicians are not acquainted in having their proceedings ready at the first day of the conference, like the physicists and the astronomers and so forth. And so we're trying to coach them into be able to work before the proceedings and have it ready for the first day, so you can walk into the meeting and have it in your hands. And that requires a lot of work and fast work. And during the ICM 3 years ago, we had about I would say about 80% of the people sharing their files on Dropbox and participating in the development, and only about 10% of them on Overleaf. This year for the Brazilian Congress, we had 51 authors, out of which 45 chose to do their sharing on Overleaf. It was a tremendous change within this 2-year time frame. And people are enjoying a lot to learn about quality tech from the editorial and production staff. When the editorial production staff tells them, you don't use EQN array anymore. And authors are very glad, to ask why and see their files changed in that way and see how it's better in that way. So I think it's a very positive change, and this has been really, really great.
No, that is fantastic. I see Boris has his hands up. I just want to use Paolo's comment there just to highlight something else, which I think really helped Overleaf over the years, and it's the fact that we have an in-house support team. So it started off with, obviously as you have a software as a service, you have users writing in with issues or bugs or just problems using it, and which is fantastic actually. Like, it meant that we always had a lot of feedback from people, but John and I were answering those initially, and very quickly it becomes a big part of what you're doing. And Lianci, and who I'm sure many people here know, Lianci from the LaTeX community, we put out an ad for a sort of techspert to join the team, and Lianci, was just amazing, and still, she's still working with us now, and it's been fantastic. And we've grown that support team over the years, and we now have really a broad range of skills and backgrounds, you know, from engineers, teachers to, you know, like, you know, people who've done lots of different things. But because we have the support team in-house, it means that if you write into Overleaf with a problem, like you get hold of someone at Overleaf, and you know, most of this, well, in fact, all the support team are really great with LaTeX as well, you know, different, again, coming at it from different backgrounds, but often can help the users and solve their problem. And I think this was an indirect, you know, benefit of having, you know, LaTeX compiling in the cloud, is that it's not just the authors that can see it, but if someone needs support on it, you know, they can get it. And so a lot of authors who write to us and ask us for help, you know, and are happy for us to look at their project to see if we can help, we can fix something really quickly, and that gives them a really positive experience, not only of Overleaf, but of LaTeX as well, and it lets them keep going. And I think we've had a lot of, you know, like Overleaf has grown a lot, and I think, you know, it's helped people get past some of the, you know, the initial issues that you have with LaTeX, and where you get stuck on something and you maybe have to spend hours and hours fixing it, with the fact that you could either either ask someone from Overleaf to try and fix it, or I'm sure what happens out there, you know, with classes being taught and everything is people, you know, asking their teacher for help, or asking their like fellow students for help, and being able to sort of fix and spot, you know, each other's issues. And that was very much, if you like, a side effect of the collaboration, is that it really lets someone else help you get unstuck, in a way that if you're working locally on your machine and it's just you, and you aren't in, you know, in a classroom with other people, or you don't have someone else just come and look over your shoulder, you know, you've got someone there that can fix it, and you know that it's fixed because you know, it's the same, it's compiling on the same machine in the cloud, rather than, you know, I could send you my LaTeX file and you could try and fix it, but then if you've got a different LaTeX installation running and stuff,
Right.
Quite the same.
Right.
And so, Boris, you've had your hand up for a while. I should.
Thank you. Thank you. I actually said this exactly a year ago at our last online conference, but I would like to repeat it now. That as a old-time tech users, I was completely, I was sure I never would need an Overleaf, so I never looked at it. And in the last couple of years, I found that it so much enhanced my collaboration that I now can work with people who would not go through the task of installing LaTeX on their computers, and they became, or installing version control, something like Git on their computers. And now they are very productive collaborators. And the nice thing that with Git, I can just work on my computer and just use Overleaf as a big Git repository, and they can use it for editor. I am now convinced that what you did was one of the several most important changes in the tech worlds for the last years. You probably revolutionized the way that a lot of people are using tech, and I just wanted to say that what you have done and what you are doing is absolutely amazing.
Well, it's hard to quite know what to say to that other than thank you. And I think other than, you know, it's certainly, you know, well, it's certainly not just me. I mean, so John Lees-Miller, you know, from a technical perspective, is very much the person thing, but also James Allen and Henry Oswald, who launched LaTeX. And actually, though, everyone, you know, along the way that has contributed. I mean, one of the brilliant things, for me personally, is we have such a great team at Overleaf now, and we have had, even, you know, we've had people who've come and gone over the years, but it's been a really nice environment. And I think, you know, in a way, like, I think, you know, like the whole like tech community is very friendly. I think, you know, there's a lot of support given for new users, and there's a lot of time put into the packages which help people, in different disciplines. And it has always been open and collaborative, I think. And I it's nice to see, I think, Overleaf and this sort of cloud-based LaTeX, like helping to sort of continue it on, and I think helping LaTeX, be more accessible to people in the distribution sense of accessible. And I also think, we were also just lucky with the timing, I think in many ways, and they say this a lot, Dropbox had recently come out, and there was a lot of other things that people were starting to do through the browser rather than installing directly. Like, I can't remember off the top of my head, but like, things like Google Docs then came out after Etherpad, and people just became a lot more comfortable or a lot more used to using the browser as the entry point for programs, like rather than, the directory of locally installed stuff. And so I think we were around at the right time, and John's just, he's led the engineering, he and Tim did most of it in the early days themselves, and John since led the, how we've continued to build on that and develop it along the rest of the team. So, but thank you, Boris. I do appreciate that.
Thank you.
Well, if you want to join the conversation, have your questions come in, you can just come in online, any of the panelists, or if you want to raise your hand. I think lowering the bar has been absolutely, from all these features that we've seen out there, and being available everywhere. It's been, such a game changer. You mentioned one thing, which was the submission process, and the submission process has two faces. Has the face of the author, has to fit to certain standards, and also has the side of the production staff that receives on the other end, and has to make sure that what he sees is what the guy intention to write. And Overleaf bridges that divide. The divide of, yes, what I have, it's here, and in the next minute the production staff can continue to work with it and be sure that he is working on what the guy intended to, rather than some display of a specifically Russian font on an English manuscript that's not happening properly on page 147. That's really great.
Yeah, and I guess just to comment on that, I think, oh, sorry.
No, go ahead.
I was just going to say, yeah, we did, a couple of the publishers that we have worked with a lot over the years, the IEEE and the Optical Society. I think in particular now, like the Optical Society uses Overleaf for compiling the submissions that come through their site, because I think one of the benefits sort of they found in particular was, I think we've all been there when submitting a paper to a particular journal, is you might upload the LaTeX files and then it tells you that it can't compile them. Right. And it maybe gives you the error logs if it does, but then you've got to figure it out, and probably you're submitting it because it does compile on your machine. And so you've now got to work out why is it saying it doesn't compile on whatever system the particular journal is using. And so, like, what's really nice with how we've managed to get it to work with the Optical Society is, like, if you go to so first off, we work with them on templates, and then we work with on the submission from Overleaf. So if you submitted it from Overleaf, it could go straight in. But now the way it works, if you go to their submission portal directly, which most authors do, I think, because it's the natural, you go to the OSA and try and submit. And when you upload your LaTeX files, it sends them to us to compile. And if they do compile, then that's great. The PDF comes back, everything's fine. it's the same as it would do anyway, like if it's all gone through well. But if it doesn't work, the nice thing is that you get the option to open the project in Overleaf to fix the errors. And it means that like you and the editorial team could both see that to fix that, and it means that you know that if you do fix the errors here, they're definitely fixed, rather than trying to fix them on your machine when, like, from your perspective, it already seemed okay and everything. And like you say, I think having that common view of the document is actually very valuable, just for, like you say, not just reducing the frustration between co-authors who have maybe got different systems installed and see different layouts and things, but also for the publishers. If they know they're seeing what the author intended to submit, then they maybe avoid some of the miscommunication further down the line, or even having to sort of try and get the author to fix problems which aren't due to the author's system. One of the I think thing that I remember from it would have been a few years ago now on the publishing side, but definitely because we used to get questions come in from authors or sometimes from the editorial teams. Like, I think in a few cases we were actually able to help fix sort of underlying issues with, let's say, the bibliography layout. I remember one where there wasn't, DOIs weren't visible in the references, and it was because the reference style had been designed before sort of DOIs were used. But what the journal had been doing, because they didn't really understand exactly, necessarily understand like the details of it, they were just asking the authors to display the DOIs. And so I think each author had to keep trying to hack in a way to get the DOIs shown. And because some of those questions came into us and things, like we were able to sort of actually, suggest updating the bibliography style so that it did that automatically. And then, the publisher's happy because they no longer have to sort of have this frustrated authors who they're trying to sort of get to do a thing, which was really a problem with the template, the journal template. So I see there is now a couple of questions in the chat, and Jonathan has his hands up. So Boris's question about the best address for feature requests, I would say always sending stuff into support@overleaf.com is the best way to get it triaged and passed to the right person. And that's support@overleaf.com is always the best email address to reach us with. The question from YouTube: are we thinking to include Python tech in Overleaf once again in the short term? That is a good question. I think what they're referring to is it used to work in V1, I think, and now it doesn't work. I need to double check because it has been a long time. I don't really use Python myself, but I will take that one offline and we will follow up. So if the person that responded on, we'll try. Yeah, it was a question from YouTube, so I guess we might comment on YouTube. Jonathan, you had your hand up for a while.
Okay. John, one of the things that we have a hard time with in the tech community is sort of have an idea of how many tech users are out there and how distributed they are around the world, and who is really using it and so forth. I guess you have a much better bird's eye view of that action. Now, I don't know how much of that can you share with us, but is there at least a brush that you can give us of how tech is used and how broad?
Yeah, I think it is used. It really is used all over the world, and I think a lot of our users are students, at universities, and I think if you look at probably where there are technical universities or universities with sort of STEM, big STEM undergraduate populations, you'll probably get a good, that will probably correlate a lot with the usage of Overleaf, because we definitely see, I think Overleaf and just cloud-based LaTeX has really helped students pick up on the use of Overleaf. And I think for students it's particularly nice because it's a way for them to produce a report which maybe stands out, like especially if LaTeX isn't necessarily always used, in their group projects or something. It's a way for them to show that they've learned something, you know, at LaTeX, and that they can produce this and kind of a way to sort of, you know, get ahead of things. And so, yeah, I think it really is all over the world. Like we have a lot of use in the US. There's obviously a lot of students in the US. There's a lot of use in South America. There's a lot of use in India, and there's a lot of use in yeah, really in places, you know, across the world. Like, you know, we have a lot of users in Japan, and there's a lot of you know, there's a sort of Japanese community around tech and who use Overleaf a lot. And yeah, it's difficult to, you know, I do remember that, you know, we always seem to get once a year usage from the International Space Station, but then that is just a good old April the 1st on Google Analytics for anyone who has ever checked their Google Analytics on April the 1st. Yeah, I think it's if you follow the student populations, that would be the way to say it.
Well, thank you very, very much.
Oh,
I mean,
sorry,
was,
Jonathan still has his hand up. So.
Yes.
Yeah, I'm not quite sure. Hi, John, and thank you for coming to be interviewing, and thank you for establishing Overleaf, which really has made a big contribution to the tech community. But I sort of have mixed feelings, and in part it's because I'm an old timer, and it comes down. The mixed feelings have come down to this: that I'm trying to find a way of saying it that causes the least offence. The tech user group has had responsibilities, and I think still has responsibilities. And I feel as though part of Overleaf's remit has become things that the tech users group and the tech developers and the tech community generally should be doing for themselves. So the previous discussion of the distribution of tech users, where are the tech users? That's something that sort of the tech user group should know independently of the information you're kindly sharing with us. And another example is the strength of Overleaf, as you quite rightly pointed out, is that it provides a reproducible environment for the typesetting of tech documents. But you know, it's that reproducible environment, I think, is something that the tech developers should be solving themselves and not relying on, can I say, the heavy resources of Overleaf, because that reproducible environment is hard work to maintain, I'm told. And the sort of way I see this, for example, is that a PDF document now has the embedded fonts it needs. So you can send the PDF document to somebody and they can read it. And similarly, a Word document, together with the Word program, has all the resources it needs. Whereas I can't send a tech document to a third party in such a way that they can readily get the resources they need to compile it and compile it the same. And I feel that that's a problem that the tech community as developers should be dealing with, because we want our tech source documents to be archival and not rely on the massive resources of Overleaf. We'd like to be able to say, here's the secure hash that gives you the tree in the repository that tells you exactly what you need. Now, that's a technical thing, if you like, on one side, but those three things are examples, I think, where we're really grateful that Overleaf is solving the problem for us, but perhaps we'd be better off suffering a bit ourselves and solving it ourselves. So I'm not sure who I'm talking to and whether I've offended anybody, but I hope you can accept, I hope you can all accept that I'm representing a significant point of view, and I'd like you to comment and give your response.
Yeah, no, and you certainly haven't offended me. I think it is a very good question. I mean, I think, you know, certainly when, like I say, when a Write LaTeX was originally created, it was to solve a problem that we had within our research group, and I think it's great that it's grown and helped so many other people get into LaTeX and use it, and sort of help LaTeX, you know, help more people become aware of it, and you know, we certainly as well are very, you know, we use the TechLive distribution on Overleaf, and you know, we, like a lot of the new things that people enjoy on Overleaf and new things that people have created, you know, like to pick an example from someone that's here, you know, Sam Carter's TikTok packages, you know, like people enjoy that and they like using those and things. And, you know, that is through the tech community. I think from my perspective, like we, you know, I'm a researcher originally, I'm a mathematician, and I think it is important that we try and, you know, both, you know, not lose sight of wanting to get new users using things, but then also, like you say, things compile with certain versions, and, you know, we've had, and this is actually where some of the discussions around, you know, should there be a way of saying, you know, when something compiles, like what it compiled with, and you know, how you get that, you know, how you could recreate that exact document, you know, what exactly did it, you know, compile with. And I think it's the point that, I guess the way I look at it is that these questions are important, you know, from a certain perspective and certain people, and if we can help find a solution, which, like you say, means that, you know, a LaTeX document can take with it enough information for, you know, from that to be compiled at that instant, and I think that would be very valuable. For a lot of people, they do, you know, they want to, you know, they're looking to write documents and they want to, you know, keep them, you know, keep being able to write them. And so a lot of the work we do on compatibility. So for example, when we release, you know, new TechLive versions, you know, new documents use that new TechLive version. Previous documents still continue to use the previous version they had, so that from an author's perspective, you know, their document still compiles when they reload it. And so I think a lot of the stuff we look at from that user interface and user experience perspective is maybe something that can help with this. But right, that was my first thought on it, and you know, it is definitely worth thinking about.
Thank you for your response. It's very helpful, and I think we're almost out of time.
There's one very quick question, John, about support for context coming from Vit Novotny on the question and answer.
Oh, sorry, yes, I'm working at the chat box. Yeah, so it is a good question. And like you said, it's like, you know, there are some interesting new things happening with context. It's not something we've discussed internally recently. Like we do support the other LaTeX engines, but context is not something that we have supported, and it's not something we've looked at recently. It's certainly something that we can look at again, but I guess it's not in the short-term roadmap. So it would be something we'd have to look at and then, you know, take a view on. And given the number of things already on the list, I imagine it wouldn't happen immediately. But it's if it is being used a lot, and I think if it is, if there are new things with it, then maybe it's time we have another look at it. I see Frank has his hand up, even though we're nearly at the end.
Yeah. Hi. What I wanted to ask your thoughts about is something like this. When tech was originally sort of came into life, and Don wrote his book, he wrote something like "Join the user group" as Appendix G of the tech book. And in the early days, user groups were sort of essential for basically everybody who was using tech. People got together to get things going, and that was the way to do it. And out of that, the user groups evolved by providing services to worldwide users. By that means, they became less and less visible to users. Most users these days have no idea where these services come from, that they actually consume in all kind of ways, like having CTAL run by a handful of people doing nightly jobs to keep submissions in and so on and so forth. And the world turns and goes on. And what you did with Overleaf is in some sense, if you like, a missed opportunity of the tech community as a non-profit organization to keep the whole universe going. And it's the right thing to do, and it is the step forward that we currently sort of have to keep the whole ecosystem alive and kicking and improving. I think it is a great step forward, but there is a foundation underneath which has or is in the danger, I would think, of at least partially collapsing. And the services that you are now providing, and by this way, I think actually largely enlarging the ecosystem in some sense, is underneath that run through volunteers that are getting less and less possibilities to actually get this work managed financially and otherwise. So what's your thought on how this is going on in the future, and how much do you think are companies that benefit from it, like Overleaf, obviously in some sense, because if that would not be there, it is not going to sort of evolve further. How is this going to coexist and evolve together in some sense?
Yeah, I think it is a really good question. I think it is worth exploring, like how we can help support some of the initiatives, and even just not even the new initiatives, like say CTAN, and which is an amazing, like CTAN is amazing, and I think it's a resource that we should see what more we can do with it to help support it from Overleaf, because I think we make a small financial contribution, and I think we could probably do more. But equally, I think we want to try and find like a way to help it be sustainable in the long term as well. Like, because I think that's what's the most useful, right? Like, it's not about short term things. It's about how, like you say, how we make sure that there is enough people coming into it that will help continue it, and how it can be sustainable, not just from a financial perspective, but like you say, the people that are actually doing the work. But very open to discussion on this, and to sort of, I know we haven't got time now, but I think I'm very happy to sort of.
Yeah, it was certainly not really meant as a question to resolve.
No, but it's worth,
it is worth
but
it is something I think which is extremely important to sort of get a joint discussion on it in the future.
I'd like to make a quick contribution to what Frank has said. The MathJax Consortium, I think that's what they call themselves, have managed very well to get funding, and they're now part of the non-focus group that funds a large amount of data science projects, and they get extensive funding from people that got real stakes. I'd say that we have to look to, as a tech community, we have to look to ourselves in the way we manage things. And the TUG has an income of $100,000 a year, and I don't think it's well spent. And it's very hard to go begging for money when you're in that situation. That's controversial, I know. The other thing is about reproducible document compilation. The query about context actually made everything very, very clear. Overleaf is providing reproducible document compilation on a client hub basis. On a client hub basis, we have reproducible document compilation in the same way that Subversion provides version control. There's a hub, there's clients, whereas Git is a peer-to-peer. And I think the tech community, as developers, have got a real responsibility to develop peer-to-peer reproducible document compilation. And we do this with or without Overleaf. With Overleaf, I hope. It will make Overleaf's life easier. And sorry, I've lost my thread. Yes, that will make a lot of things much easier. It means that I can write a Beamer presentation and send it out to people just as a text file, which greatly considerably reduces the latency of giving presentations, for example. So I'll stop at that point.
I'd like to thank John very, very much. We enjoyed this conversation squarely, and we hope to do this in the future again.
Yeah, no, thank you for inviting me, and thanks for running a great conference. I have a lot of YouTube stream to catch up on. I do want to just highlight from the chat that Tix Bricks already exists apparently, and Sam is already on it. So hopefully, if nothing else, we have inspired some Lego tech in the future. But no, it'd be great to, it's been great to be here today, and I want to catch up on the other presentations and continue the wider discussion on all of this as we go.
Thank you very much.
Okay.
Boris?
Yeah. Okay. This was the last talk of this conference. And I would like to say a couple of things at the end. First, it's the second conference we did offline after the first one. And I again would like to say that without great people in the TUG conference committee who did enormous job and created a really interesting atmosphere and a really interesting meeting, you would not do this. I am absolutely grateful, and I think we are all grateful to all the people who did a very hard job, who chaired all the sessions, who created the nice technical support, and so on. It was a great job, and thank you. I would like also to thank all participants, either those who had talks or those who came to listen. Because of the differences in time zones, many of you, or I would say many of us, didn't sleep well the last couple of days. I understand that you are tired, but you did a great job, and it was great. I also would like to say that there is a silver lining in a lot of things. One of the silver lining of visit to conference is that we now understood that online meetings are useful and fun. And while I sincerely hope that next time our meeting will be in person, I think that we will add online component to it, and we will try to get the best of both worlds and meet in person for those who could and would, and make a lot of online presence for those who couldn't. Again, thank you very much for everybody, and I would like I would like to rephrase the old phrase by Knut, which you all know. I would like to say, now go forth and create beautiful books, articles, or other objects in whatever format in whatever output format you choose. Thank you very much. And here I have a bittersweet obligation to say that TUG 2021 is over, and see you at TUG 2022. Bye. Thank you.
And with that said, I'm afraid I'm going to have to close this meeting for everyone. Goodbye, everybody, and thank you to everyone, to the speakers, the attendants.
Same to you and everybody else.
Thanks, Frank. We'll speak on the board mailing list in a few minutes, no doubt.
Bye.